Yes, good morning guys to all of you. Please tell me, am I properly audible and visible to all of you or not? Yes. So guys, today we are here to start the vibrations. So I would like to tell you कि when we are starting the today's session, we would be starting with vibrations and after that we will go for the pending topics. What are the pending topics you remember? We are having gear trains. We are having gyroscopes, we are having governors, cams and balancing. So guys, it looks topics are more in number, but as they are not fundamental topics, as they are more related to formulas, so it will not take more time. But yes, vibrations we will be giving more attention because the weightage of vibration is going to be around 4 marks for sure, even sometime it may go for 5 marks. So 4 to 5 marks. Aniket, good morning. Uday, good morning. Shreyas, good morning. Vinay, good morning. Abhi, good morning. Bahut badhiya. So guys, we are starting the session. Just like and share the session so that other students are also joining. And then we are going to start. And we will go in that normal pace like we are going every day. Okay. And in vibration, you would be learning from the basics only. Others, good morning, bhai. So we are starting guys the session without wasting the time. It is related to theory of machines and vibration. Ashray, good morning. Yes. So guys, the Telegram channel Mechanical by Dheeraj Sardana, where you will get the PDF of the session. And now, you know, from 9th of January marathons are going on. This is about maths and aptitude, which will be starting from Monday onwards. And guys, you know, this is okay, this we have already seen. And you would be getting the link of the Google form which you can fill and get one-to-one counseling with our counselors. Yes, Faninder, good morning. Ronaldo, good morning. So we are moving further guys. Okay. So guys, now we are moving further. So we would be starting with vibration. Just let me pass. Okay, first I will be going for the vibration slides. Okay. And then we will be starting. First we are starting with vibrations because of high weightage of vibrations. Okay. So we are having the vibrations chapter here. Yes. So guys, let us start now. Abhi, we will do that. Don't worry. We will do that. Okay. So right now we are starting with the vibrations. So guys, when we are talking about vibration, first of all, I would like to tell you that a vibration system, a vibrating system consists of what? So when we are talking about a vibrating system, then my dear, it is having some things like that. First of all, a vibrating system will be having a kinetic energy storing device. It would be having a kinetic energy storing device. And my dear, I would like to tell you, as you know, we are going to say kinetic energy as half mv square or half I omega square. So obviously there would be some mass in the system to store the kinetic energy. So we would be showing that mass with this block. Okay, we would be showing this mass with this block. Then my dear, second, we would be having a potential energy storing device. When my dear we are talking about the potential energy storing device, you have written many times in engineering mechanics that potential energy is half Sx square. So it is somewhere depending on the stiffness. So my dear, because of that, we are representing it with the spring. And my dear, if a vibrating system is having these two things, kinetic energy storing device mass and potential energy storing device spring, then my dear, that vibration system is represented by the spring mass like this. And we call such vibration system as natural vibration system. Okay, we call such vibration system as natural vibration system. But when I show it like that, many students are thinking कि vibrations would be there only in spring mass system. But guys, this spring and mass are just the notation of stiffness and mass. They are actually not telling that in the system spring would be there. Like your heart is having some vibrations, you know that, but you will not find any spring attached there. So wherever you are having vibration, it does not mean you will be having spring and mass, but yes, you would be having stiffness and mass. So they are denoted like that. Then my dear, some system can have one more thing, that is said to be friction. Okay, when we are talking about friction, friction is going to be we can say relative motion majorly, and whenever this relative motion is there, that friction is the kinetic friction. And when we are talking about relative motion or kinetic friction, then that is majorly said to be damping, because damping is the technical name of kinetic friction. And my dear, that is denoted by a damper. And when we are talking about the damper, you know, it is having some damping coefficient C. Then my dear, we are going to have if those three things in the part of a system. Like if you are having a system of vibration where you have a spring, where you have a damper, and you have a mass. Then my dear, such vibration system we call it as damped vibration system. Malesh, good morning. So such vibration system we call it as damped vibration system. Such vibration system we call it as damped vibration system. And my dear, if the fourth thing is also coming, which is nothing but the unbalanced force. This unbalanced force may be coming from the rotating component, may be coming from the reciprocating component. But if it is present, then my dear, our system is represented like this. This is spring, this is damper, this is mass, and this is F unbalance. And my dear, this system is said to be forced damped vibration system. Forced damped vibration system. Forced damped vibration system. So my dear, I know majorly students are facing difficulty in the natural vibration. Why? Because when we are talking about damped vibration system, forced damped vibration system, there it is majorly formula based. And if you remember the formula, you would be very easily able to do the questions of that. So that is why natural vibration is going to be the major concern for the student. Keeping that into mind, we will go in the complete detail of natural vibration. After that, damped and forced damped vibration, you know, derivations are not mandatory. So there we will go for results and questions directly. Okay, I feel everybody is ready for this. So guys, first of all, I would like to tell you this vibration is classified into 3 chapters. First chapter is natural vibration, other is damped vibration, third one is forced damped vibration. Okay, so we would be starting the chapter from natural vibrations. Okay, so we would be starting very first chapter as natural vibration. And if you are talking about the weightage, from all the 3 chapters, one question will be coming. Okay, so natural vibrations we are starting with. So my dear, when we are talking about the natural vibrations, you have already seen it is denoted by a spring mass system. So first of all, I would like to tell you how the spring mass system is coming into picture. So initially, let us say we are having a spring only. Initially, let us say we are having a spring only. Okay, and this spring is having a stiffness of S. Okay, some people are showing it with K, some people are showing it with S. I will also be teaching today gyroscope. So if any student is having problem in gyroscope, that will also be removed today. Okay, this is the spring with stiffness S. Now my dear, if we are going to attach a mass with this, then my dear, this system will take this shape, spring mass. And my dear, you know that because of mass, the spring is getting deviated or deflected by some amount. And that deflection or deviation of spring, we are denoted it by delta naught. And my dear, this delta naught is said to be the static deflection of mass. This is said to be static deflection of mass. This is said to be static deflection of mass. And my dear, when we are talking about this stage, at this stage, this mass is in equilibrium. So we are also calling this position as mean position. So we are also calling this position as mean position. And my dear, when we are talking about this mean position, when we are talking about this as mean position, so if you will see at this condition, this is the mass M. You know, downward will be a gravitational force mg acting. Upward will be a restoring force S into delta naught acting. So you know, when the body is in equilibrium, upward and downward force should be equal. So we would be saying mg is equals to S into delta naught. So my dear, if that is the case, you know, from here you can say mg is already balanced now. So as mg is balanced, the body is in equilibrium now. Now my dear, vibrations will not be starting until you go for external disturbance. So disturbance is must if you want to start vibrations. So my dear, let us say some external disturbance I am applying. This is not the unbalanced force because I am just displacing it by the distance of x and then leaving the system. When I would be doing that, the next instant the system will look like this. Okay, and when we are talking about this, this is said to be the extreme position 1 for the system. Okay, now my dear, you know that as it is extra displaced by a distance of x. Now at this position, if you are talking about this mass, now downward mg and upward you are going to have s into delta naught plus x, and you already know s delta naught have balanced mg. So we can also show this system with mass m with the restoring force s into x when it is displaced by x. So guys, in the entire chapter you will find that I am not showing mass or mg. You will see I am never showing the weight acting downward. So you should not have the doubt, sir, where is mg? Because mg is already balanced by s delta naught. So that's why in this entire session, whenever I am talking about the natural vibration in spring mass system, you will always find weight is balanced. So when weight is balanced, the restoring force we are having is s into x, because of which the system will try to go to the original position. So guys, when that is going to happen, this is how the spring mass system is going to be there. And my dear, because of this force Sx, this will go in this direction. And at this condition, velocity is 0, but force is maximum, s into x. So because of force, acceleration is there. So here, my dear, you can say the body is at its extreme position. So you can see the total energy of the body is present with the spring in the form of potential energy of the spring. So at this instant, the energy of the system is half Sx square, only this much. Then my dear, it will start moving. Here the velocity is 0. When this mass will be reaching here, the velocity will become maximum. And when velocity will become maximum, this is the mean position, here potential energy is 0. So you can say here the total energy of the system is with the mass half mv square. And because the velocity is there, force is 0, but still it will continue to move, and at somewhere this place maybe the velocity becomes once again 0, and this will be the second extreme position at x distance. So here once again the entire energy will be converted into potential energy. So likewise the conversion of energy from potential to kinetic to potential to kinetic to potential to kinetic to potential will go on. Is it clear for everyone? Malesh, Abhi, Faninder, Ronaldo, Ashray, Adarsh, please tell me. So I am going from very basic, keeping that in mind. Let us say you have never studied vibration and you will become master today. Is it clear for everyone? Do like and share the session, guys. So this is about the natural vibration system. Very good, Faninder, Shreyas, Akhil, bahut badhiya, Malesh. Yes, ancient heavens Lord. Yes, very good, others. So guys, now we are talking about from where the vibrations are coming. I will be showing you now. Yes, Dhanesh, good morning. Now I will be showing you about the SHM, because you know in the vibrations, if you see, the system is having to and fro motion about some mean position. So this to and fro motion of the mass about the mean position is said to be vibration. But we know this is also SHM. So it means we can say in a natural vibration system, the system is having the motion same as that of SHM. So if we know SHM, we can study this motion as well. Yes, Aritro, good morning. So here there are some terms also. Like if somebody is asking you what is the amplitude of vibration, then maximum displacement of the system is x. That is said to be the amplitude of vibration. Now in a particular time, let us say in a unit time, how many cycles are completed, that is said to be frequency. What is cycle? When this is going down, coming up, coming back. So this complete one is said to be a cycle, and the time taken by this cycle is said to be time period. So we define time period, we define frequency, we define cycle, we define amplitude. Now if all the things are similar to SHM, we must know from where SHM is coming. So if you want to understand from where SHM is coming, let us imagine that we are having a ball, and that ball is having the circular motion and it is moving with a regular velocity of omega. Okay, let me see some comments. Sir, there is a little disturbance in the audio. Is there like that? Please tell me. Is there a disturbance in the audio? Now also we have. Now it is clear, please tell me. Now, please tell me now. Now is it clear? Now is it clear? Please tell me. Okay, fine. So now we will be going like that. Okay. So guys, when this ball is moving on this circle in the circular motion, then my dear, what will happen? What will happen? What will happen? So my dear, you will be taking the projection of this at any of the diameter. Let us say you are taking the projection of this in the vertical diameter. So when this ball will be rotating like this, 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 like that. So my dear, if you will be taking the projection of it, obviously the projection, when the ball is here, projection will be here. When the ball is here, projection will be here. When the ball is here, projection will be here. When the ball is here, projection will be here. Ball is here, projection here. Ball here, projection here. Ball here, projection here. Ball here, projection here. Ball here, projection here. So when the complete rotation is going to happen, then its projection is going to be like this. And this is said to be SHM. So my dear, the same type of motion we are having in our spring mass system. So if we understand this motion, we will be automatically understanding our motion. So my dear, because of that, when we are talking about this type of SHM, you could take at any of the diameter. Like now I will be taking this motion on the horizontal diameter. So my dear, let us say there is a ball at this position. And let us say this is rotating with an angular speed of omega. This time I am taking projection on x-axis or on horizontal diameter. Let us say in time t, this ball is reaching to this position. And you know this is the radius r. This is the radius r. And my dear, when it is moving with omega velocity in t time, it is reaching here. You know its projection will be reaching at this position. And my dear, this is said to be the displacement of this mass from its mean position, because about this only the vibrations on SHM will be happening. So in that case, this is the x. And I am saying that this angle is theta. I feel everybody know if omega is the speed, omega is theta by time. We can write theta as equals to omega t. And if theta is omega t, we can definitely write the x is equals to r cos omega t. So my dear, now we are going to derive the equation for SHM or vibration, and after that you are going to enjoy the entire chapter. I am telling you one by one. Every method will be coming in front of you. So guys, when x is this, I will be going for the differentiation of this. Okay, we are having x. So x is coming out to be r cos omega t. Now let us say we are going for differentiation. We will get velocity, that is dx by dt. So x dot will be coming out to be nothing but minus r omega sin omega t. Then my dear, x double dot will be coming out to be minus r omega square cos omega t. And you know that r cos omega t is x. So we can definitely write x double dot is equals to minus omega square x. X double dot is equals to minus omega square x. From here we get the equation x double dot plus omega square x is equals to 0. From here you can get a question that in vibration or SHM systems, this acceleration is directly proportional to displacement. They can also ask you acceleration or force. So yes, force is directly proportional to displacement you will be getting. And guys, you can see this is the governing equation of SHM. Governing equation of SHM. So my dear, when we are saying in vibration also our mass is having the same motion. So we can use this as the standard governing equation for our spring mass system as well. Okay, so now we are going to start with that. And my dear, once again we are reaching to our spring mass system. So when we are going to have our spring mass system, this is spring, this is mass, and you know when we are going to displace it by x, we are getting this mass is having a restoring force Sx. Now my dear, as we are preparing this marathon for gate only, so we will go in that way and we will skip those things which are useless. Like we will not go for Newton method, we will directly go for D'Alembert, because Newton we never use, you know that. So when we are going for D'Alembert, what he said? D'Alembert said add my component to the restoring force, because when you have displaced it with x, restoring force is Sx. So D'Alembert said add my component. What is his component? M into A. What is M into A? M into x double dot. So this is the component of D'Alembert. And he said add my component, equate it to 0, you will get the equation of Newton. So we are getting the equation here as mx double dot plus Sx is equals to 0. And my dear, this is the governing equation of this natural vibration system for spring mass. And guys, when we are getting it, we can also write it as x double dot plus S by m into x is equals to 0. And if you equate this with the governing equation of SHM, which is x double dot plus omega square x is equals to 0, from here you can say omega square is nothing but s by m. From here you can say omega is nothing but square root of s by m. As it is natural vibration system, we are representing it by omega n. And you can also write omega n as 2 pi fn. So 2 pi fn is root s by m. And my dear, we can write fn as 1 by 2 pi square root of s by m. Is it clear, guys? This is how we are representing the natural frequency of vibration. Please tell me, is it clear for everyone or not? Please tell me, is it clear for everyone or not? Yes, Malesh, Dhanesh, Shreyas, Akhil. So this is how we can find out natural frequency of vibration. We have done it for the spring mass system. And guys, now we would be moving for other methods. And the method we have used here is said to be D'Alembert principle. Because my dear, I would like to tell you, in vibrations, the question will be coming from nothing but the finding out of natural frequency. So we have started our work with the D'Alembert principle. Now my dear, we are coming on to this. There is no limitation of this method. It can be used in natural vibration, damped vibration, force damped vibration, anywhere. Now we are coming with the second method. So my dear, the second method in natural vibration is nothing but energy method. And whenever we are talking about the energy method, it is having some limitation. Actually my dear, when we are talking about energy of the universe is always conserved, everybody knows that. But I am here not interested in the energy of universe. I am here interested in the energy of system. So energy method is considering that key energy of system is conserved. And when we are talking about energy of the system is conserved, that can be conserved only if there is no friction present in the system. So that is why energy method will be applicable only and only for natural vibration. This is the first thing you need to take into mind. Then guys, whenever we are going for a number of method, you must be in a position to tell which method will give you answer easily where. So I would like to tell you, energy method is preferred in two cases. One is whenever you find pure rolling motion. One is when you find pure rolling motion. Second is when you have more than one mass in the system. More than one mass in the system. Okay, more than one mass in the system. So my dear, when you find this condition, and you know it is valid only for natural vibration. So for these two cases, in natural vibration, you can go for energy method. So when we are saying these two are the areas where energy method will give you answer quickly. But my dear, yes, these are two cases. But my basic system is spring mass system. So I will be learning this method from spring mass system only. So let us say we are having the spring mass system. This is the stiffness S, mass M. Now my dear, now when we want to find out this natural frequency with energy method says energy of the system is conserved. Means the total energy of the system is going to be conserved. So we can say, if I find out kinetic energy of mass, it is half m, velocity is x dot ka square. If you want to write down the potential energy of the system which is there with the spring, it is half sx square. And if you want to talk about, yes Rahul ji, good morning, how are you? So when we are talking about kinetic energy and potential energy, the total energy of the system can be written as half sx square plus half mx dot ka square. So guys, this is the total energy, and you are saying this total energy of the system is conserved. When this total energy of the system is conserved, it means this is constant. If it is constant, its differentiation should be 0. So you just need to do dE by dt to be 0. And when you are going for this, what you will be getting? Half s x square ka 2 into x dot plus half m x dot 2 into x double dot is equals to 0. You know x dot will get cancelled out. 2 will get cancelled out. So we will be getting the final equation as mx double dot plus sx is equals to 0. And this is the governing equation Once again we are getting the same equation, you know that. So if equation is same, can I write omega n will also be same, square root of S by m. Okay, the same equation we are getting from energy method. But you know, this was quite lengthier. Easier than that was D'Alembert. So I already told you, for these two cases, energy method is preferred. For other cases, obviously D'Alembert is there. There are other methods also. So energy method will give you quick answer, easy answer in these two cases. Okay? Is it clear for everyone? So we would not be going for derivations of damped, forced damped, but we will be going for everything in natural vibration, because in natural vibration you have to perform these things in the paper. In damped and forced damped you need to apply the formula. Is it clear up to this? Yes, this is energy method. So now we will see the use of energy method. For that I am considering the first case of pure rolling. Okay, first case of pure rolling. Now my dear, we are having a spring like that, and we are having this disc. And when I am saying this is disc, mass m, radius r, it is rotating with an angular speed of omega. S is the stiffness of the spring. So guys, now we are going to talk about the natural vibration of this system, and it is obviously given that the pure rolling motion is happening. When you see pure rolling motion, it means you have to go by what method? Energy method. Okay, so when we are going for energy method, you will write the energy. You will write the energy. So when we are talking about the potential energy, it is nothing but half Sx square. Okay, because when it is moving with omega, spring will be expanding. So half Sx square is the potential energy. But my dear, you must be aware, in the last class when we have discussed tome part 1, there I told you that whenever we have pure rolling motion, it consists of two motions. One is pure translation, other is pure rotation. Kinetic energy of translation can be written as half mv square, and kinetic energy of pure rotation can be written as half I omega square. So my dear, as pure rolling is the combination of both the motions, I will be adding these two. So when you would be writing the total energy of the system this time, it is going to be half mv square, half I omega square, half Sx square. You already know when it is disc, for disc I is given as mr square by 2. So my dear, like I have taken disc, they can take this as solid cylinder, hollow cylinder, solid sphere, hollow sphere. They can take any geometry. For that I will give you the I value for everything. Okay. So my dear, when we are going to put this value, what you would be getting? It is half m. When we are talking about velocity, can be written as x dot ka square plus half, what is I, m r square by 2 into omega square plus half Sx ka square. You know r omega is velocity, velocity is x dot. So we can also write the total energy as 1 by 2 mx dot ka square plus r omega is x dot. So you can say 1 by 4. This is m x dot ka square plus 1 by 2 Sx ka square. So my dear, you can say that here I can write 1 by 2m, 1 by 4m. It is 3 by 4m. 3 by 4m x dot ka square plus half Sx ka square. This is the total energy of the system which is conserved. So my dear, if total energy is conserved, obviously its differentiation should be 0. Constant means what? So you would be going for the d of total energy upon dt should be 0. If total energy is going to be conserved, my dear, then we can write 3 by 4 m. Differentiation would be 2x dot into x double dot plus 1 by 2 s into 2x into x dot is equals to 0. X dot and x dot will be getting cancelled out. 2 will get cancelled out. 2 will get cancelled out. The equation is coming as 3 by 2 mx double dot plus Sx is equals to 0. So this is the governing equation. So we can write 3 by 2 mx double dot plus Sx is equals to 0. Now you can also write this equation as x double dot plus 2s by 3m into x is equals to 0. Now my dear, you need to equate this equation by what? You know our governing equation of SHM was x double dot plus omega square x is equals to 0. So can we decide from here what would be omega? So from here we will say omega n is nothing but square root of 2s by 3m. Please tell me everybody understood, or any doubt if you have, please ask. If any doubt you have, please ask. Wonderful guys, बहुत बढ़िया, मजा आ गया. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. So square root of 2s by 3m would be the answer for this case. Now my dear, like I have calculated this, you know we have done this. Abdul, I did not get your point. You are going through marathon. Okay, let's do one thing, Abdul. You connect with me in the break. In the lunch break, I will give you around 2 p.m. So then we will connect on that. Okay, you call me at that time. I will give you the number. Okay. So when we are talking about omega n is square root of 2s by 3m. Okay, very good guys. So now my dear, in this only there is one catch. If we know the I value of the geometry, then only we can do this question. So for that I am telling you the I values of different geometries, and this I value is about the centroid. This is the centroid. So about this centroidal axis I am giving you the I value. So guys, if you are having different geometry, like if you are having ring, or you are having hollow cylinder, ring or hollow cylinder, then I will be mr square. If you are going to have disc or solid cylinder, you would be having I value as mr square by 2. If you are going to have hollow sphere, then you would be having it is 2 by 3 mr square. And when we are talking about the solid sphere, it is 2 by 5 mr square. Here my dear, there is a confusion sometimes ki where 2 by 3, where 2 by 5, where mr square by 2. Always remember, for hollow geometries, I is going to be more than the solid geometries. Because when mass is distributed away from the center, obviously the I would be more and more. Clear for everyone? I feel everybody understood this. So if you know these I values, you can do any geometry problem very easily. Okay. So guys, now we are moving further to the next method. Okay. But before that, there is one more case. If till now whatever we have discussed, we were taking the spring to be massless, there may be a condition when spring is also having a mass. So my dear, when the spring is also having the mass, like this is the spring, this is mass. Here I am saying this spring is having stiffness S and mass ms. So guys, although for this, as we are having more than one mass in the system, only we have to go for energy method. And if we need to go for energy method here, we are having total energy as kinetic energy of mass plus kinetic energy of mass of spring plus potential energy of spring. So here is once again the derivation, but that derivation is useless. Okay. That is not going to help you in any of the question. That's why I am giving you directly results. So where derivations are important, I am going for that. For this case, the answer is going to be S by m plus ms by 3. Okay. Because there is no help of this derivation in any of the question, because this particular is a question only. I would like to tell you one thing, if still you want, when you would be going for kinetic energy of mass and kinetic energy of this mass of spring, here you would be getting 1 by 2 m x dot ka square. This would be coming out to be 1 by 6 ms x dot ka square. That's why the answer is coming like that. Is it clear? But if anybody would say, I can go for derivation, but it is not required. So just follow me if you want to score good in paper without much hard work. Okay. So that derivation is not going to help you anyway. So that's why we are not going for that. So guys, now with this we have completed the energy method. Now we are going for the next method, that is torque method. Okay. And this, my dear, I would be saying that star mark. Why star mark? Because as per the previous year records, they says there are two methods from which more number of times questions are coming. One is torque method, other is Rayleigh method. Okay, and those two methods now we are going to see one by one. So torque method and relay method are very important for GATE exam, and 99% chances that question will be from these two methods only. 1% yes, it can come from energy method also. So guys, let us see the torque method. So torque method is nothing but the same D'Alembert. This is the D'Alembert for angular vibration. So this is D'Alembert method for angular vibration. So for that I would be starting with the simple pendulum. So when we are having the simple pendulum, you know this is M, this is L. Simple pendulum case is different than spring mass system. Okay, when we are talking about this, you are having this as mass, you know vibration will not be starting until I give initial disturbance. So this time I am giving some initial disturbance of theta, where theta is very, very small. So you know this will be coming in this position. And when this will be coming in this position, you can very easily write that there is a weight acting in the downward direction, mg. Okay, and that mg will be having two components as it is going with the theta. So one component will be coming out to be mg cos theta. One component will be coming out to be mg sin theta. Now my dear, you need to understand, previously the tension was balanced by mg. And now the tension is balanced by mg cos theta. So now tension is balanced by mg cos theta, then what is the force which wants to take this ball to the original position? That is mg sin theta. So this force will try to take the ball to the original position. So guys, that's why I would be saying the restoring force is mg sin theta, but here vibrations are angular vibration. So when vibrations are angular, I will say we have given initial disturbance with theta, then there will be a restoring torque. What is restoring torque? Mg sin theta into length, because angular vibration is happening about this axis. About this axis only the rotation is happening, na? So I would be taking restoring torque as mg sin theta into L. And what was given by D'Alembert? D'Alembert said add my component. What was D'Alembert component? It was I theta double dot. Okay, because this is angular vibration, so it would be I theta double dot. Previously it was mx double dot. Very good, Arithro. So guys, what you need to do? You need to do I theta double dot plus mgl sin theta is equals to 0. Here my dear, you know that theta is small. I already told. When theta is small, sin theta becomes theta. Sin theta becomes theta. And you know I, if we are having a mass from this axis at a distance of x, we say I is mx square. Here this mass is at a distance of L, so I will be ml square. So we can write it as ml square theta double dot plus mgl theta is equals to 0. From here you can say the angular vibration equation I theta double dot will be mgl upon ml square into theta is equals to 0. You can equate it with theta double dot plus omega square theta to be 0. Mass cancel out. It would be coming out to be length cancel out. It would be coming out to be omega ns square root of g by L. So if you see here g by L, so it is depending on g. That's why you were studying this type of question in 11th class, that if the simple pendulum is going to moon, what would be its natural frequency? It will change because it is depending on g. But if you see the spring mass system, in the spring mass system omega n was coming out to be s by m. It was independent of g. So when you are going to take the spring mass system to the moon, its natural frequency will not change. But if you are going to take this, definitely natural frequency will change. So this type of question have already been asked in the GATE. Okay, I feel everybody understand this. Now my dear, we are going to see what are the other questions and where to use torque method. Energy method I told you we can use in pure rolling motion. So my dear, for torque method the identification is pure rotation. Where you are having the pure rotation, then my dear you would be going for torque method. Pure rotation, you will be going for torque method. What is the identification of pure rotation? Pure rotation means when the rotation is happening about a fixed axis. In the pure rolling there is no axis because the body is rotating like that. So, okay, if you are having rotation about some axis, okay, then we can go for this torque method. I am showing you some of the application. Like let us say my dear, we are having a disc and that disc is fixed like that. Center is fixed. and then we are going to have a spring attached onto this, and we are having one more spring attached to this. Okay, and I am saying this is having mass of m, radius of r, this is having stiffness of S2, this is having stiffness of S1. And they are asking you to find out natural frequency of vibration. You know, this is the question I am doing, okay? So don't feel that I am just going with the concept. In natural vibration, every case is a question. This is a question. It can come in this paper, yes. So when we are having this, how to do that, I am telling you. The only difference in the paid course and this session is, there I may go for 10 cases of similar type. Here I may go for 4 cases. Like this case, I can go with 1 spring also, but I am here directly going with 2 springs because it is revision going on. So guys, now once again, let us say we are going to rotate this with the angle of theta. If we are going to rotate it with the angle of theta, we have given initial disturbance of theta. And when we have given initial disturbance, you can see about this axis pure rotation is happening. So torque method is useful. So guys, when torque method you are applying, you will see that this point, let us say, was there. And when this is rotating with omega, this point will be coming here. So you know this r into theta is the displacement of this point. Spring is getting expanded by the same. So there will be a restoring force coming in the spring, that is S into r into theta. And when this is happening, parallelly here also this point will be moving like this. And this point also will be moving by r into theta. So this spring will also be applying the restoring force, which is S into r into theta. But you can see this restoring force is applying restoring torque in anti-clockwise, and this also is applying anti-clockwise. So we would be saying anti-clockwise means this. So this is S1 r square theta and S2 r square theta. What was said by D. Lambert? Add my component I theta double dot. So I would be once again writing the same equation, I theta double dot plus S1 r square theta plus S2 r square theta is equals to 0. So my dear, you know I is of this disk, that is mr square by 2. You know it is said to be disk. So for disk, I is mr square by 2. So I would be writing mr square by 2 theta double dot plus S1 plus S2 r square theta is equals to 0. So you know r square will get cancelled out, and you would be getting theta double dot plus S1 plus S2 into 2 divided by m. Theta is equals to 0. And guys, I feel very easily you can say that omega n is nothing but square root of 2 S1 plus S2 divided by mass. Everybody understand this or not? Please tell me that. Everybody understand this or not? Please tell me that. Everybody understand this or not? Please tell me that. Very good guys. बहुत बढ़िया. I am very happy the way you are responding, guys. Okay, at the end of today's session, we will decide about the pending part of production. All other subjects are over. And after this marathon today, you will be getting heat transfer also. Very good, guys. Wonderful. Very good, guys. So moving further. Now, my dear, I would be showing you a case like, if you remember Sir Kennedy, where we have studied eye center approach. If you remember, eye center approach have converted the pure rolling motion into pure rotation. So even if we have pure rolling, we can do with the torque method, because pure rolling is getting converted into pure rotation. So if we want to go for that, let us take a case. Let us take a case. Okay. So I am going to consider, let us say we are having this disk. This is disk with mass m, radius r. This is the center of the disk. And we are having a spring that is at that point. And the distance of this center is d. Let us say d. And radius is r. So my dear, now it is going to have pure rolling motion, but we know that Arithro I will tell you after this session. Okay, today or tomorrow we will see. According to yours only we will plan. Okay, according to yours capability only we will plan. So we will discuss and then plan. Okay, So just wait till lunch. At lunch time we will do all these things. Right now concentrate on the class. Don't go here and there. So when we are talking about this, you know, this time pure rolling motion, and this is the point of contact. So this is the point of contact A, let us say. Okay, and this is pure rolling motion happening. And if this is pure rolling motion happening, you know, as per the Kennedy's theorem, as per the Kennedy's law, whatever we have studied, this A is also acting as I center. Means this pure rolling motion of this body can be considered as pure rotation about this axis. Yes or no? Yes. So my dear, if that is the case, it is pure rotation, I can go with the torque method. Even I can go with energy method also, because energy method is also valid for this and torque method is also. So guys, first of all, I will be going for the torque method, and then I will show you how energy method can also do that. So guys, when we are having this, let us consider that, you know, the velocity profile is coming like this. If you remember, it is coming like this. Everybody remember that? So you know that if this is the distance r plus d, so this spring is getting displaced by a distance of r plus d. So let us say we have given initial displacement of theta, and the spring will be moving ahead by how much distance? R plus d into theta. So I would be saying the restoring torque will be coming S into R plus D. This is the restoring force. What is the restoring force? S into R plus D into theta. This is the restoring torque. And you know, restoring force. And you know, force into perpendicular distance is torque. So S into R into D into theta into R into D, R plus D would be the restoring torque. And what was given by D. Lambert? He said I theta double dot, add my component, equate it to 0. So we can directly write I theta double dot plus S into R plus D ka square into theta is equal to 0. But there is one catch, that this motion is pure rolling, but it is pure rolling, but it is pure rotation about which axis? About this axis. So I need to write this I is about AA. This is not about the centroidal axis. Yes, Rudra, good morning dear. So when we are talking about IAA, you know the parallel axis theorem. We can write IAA as equals to IGG plus, you know, the mass into the distance between the axis. Distance between the axis is, this is IGG, this is IAA, it is R. So we would be writing R ka square. So when we are finding out IAA, it is coming out to be mr square by 2 because it is a disk plus mr square. So we can also write it as 3 by 2 mr square. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Then we are moving further. So we can say that 3 by 2 mr square theta double dot plus S into R plus D ka square theta is equals to 0. And we can write omega n as equals to directly 2S R plus D ka square by 3 mr square. Please tell me everybody understood this or not. Please tell me everybody understood this or not. Please tell me everybody understood this or not. Yes, Ashray, Akhil, Malesh, Abhi, Faninder, Aritro, Ancient Heavens, Dhanesh. Please tell me guys. Please tell me. Very good, very good, very good. So guys, this is how we have done it. Okay, I feel everybody have learned that how we can convert the pure rolling motion into pure rotation. But dear, when we have converted it into pure rotation, even energy method will give us answer soon only. How I am telling you. Like even if you go for energy method, then also you need not to waste your time. How I am telling you. Like if we are having the same question, this is the spring. Okay, if you are saying that I am going for energy method, but this time you are saying that about A it is pure rotation only. So for pure rotation you will say that if this is M into R, you will say the kinetic energy of the system is half I about A omega square. You will not be writing this time mv square. Why? Because it is pure rotation. So for pure rotation, mv square is not required. So it is directly kinetic energy, potential energy is directly half sx square. And now you can go for the total energy. Total energy is half. What is I about AA? We have just calculated. It is 3 by 2 mr square. Then we have omega square plus half sx square. Now you know we can write r omega to be x dot. So total energy will be coming out to be 3 by 4 mx dot ka square plus 1 by 2 plus 1 by 2 sx ka square is equals to 0. But here my dear, you need to say that when we are talking about x, what is x actually? X will be r plus d into theta. So x will be r plus d into theta. Okay. And if we are going to put it here and here, then my dear, you would be getting the equation once again the same what we have just solved. So choice is yours whether you want to go for energy method or you want to go for the torque method. Choice is yours. But torque method is always going to be better because it will give you answer very quickly. You need not do any differentiation and all. So that's why I will always prefer the torque method whenever I will see pure rotation or pure rolling motion. Please tell me everybody understood this or not. Please tell me everybody where you find, sir. Tell us this again. I will once again repeat. Please tell if anybody have any doubt. Yes, Adarsh, Ashray, Rahul, Malesh, Dhanesh, Faninder. I feel everybody understood. Wonderful, guys. So this was the beauty of torque method. Let us see one question on the torque method and after that we will go for the torsional vibrations. Okay. And that one question is from the previous year's gate only. Okay. This is the question. Just look at it. Just look at it. We are having once again a disc with mass m and radius r, and we are having springs. One spring is this, other spring is this, and you know the radius of this is given as a and difference between these 2 points is d. Okay, and you know that this is the point of eye center about which we are saying the motion is pure rotation. So let us say you are going to give a rotation of theta about this point. Then you know by how much distance the spring will move. Spring will be moving by a plus d into theta. So restoring force will be coming in this direction here, in this direction here. Why? Because this spring is expanded, this spring is compressed. So they will be giving restoring force like that. So when we have given the angular deviation of theta, restoring torque will be coming like this and this. From first spring it is coming, let us say S1, let us say S2. First spring is saying S1 into R plus D ka square into theta. Okay, let us say radius is R only. And second is S2 R plus D ka square into theta. And what was given by D. Lambert? IAA theta double dot. Just complete the equation, you will get the answer. IAA theta double dot plus S1 R plus D ka square into theta plus S2 R plus D ka square into theta is equals to 0. I feel now you can do very easily. IAA we have just calculated 3 by 2 mr square theta double dot plus S1 plus S2 R plus D ka square. You can also try with me. From here I feel very easily you can write omega n as equals to 2S1 plus S2 R plus D ka square 3m. Everybody understood or not? Please tell me that. Guys, one more case we will go for the road. We are going for one more case of the road and after that we will enter into the torsional vibrations. After torsional we will go for relay method. Okay. So out of 4 hours, 2 hours will be for natural vibration, 1 hour for damped, 1 hour for force damped. Okay. Likewise we will go for. Very good Faninder. Bahut badhiya, bahut badhiya. Very good. Okay. So we will go like that. So now we are moving further. Now we are moving further and now we are having the case of a road. So let us say we have a road hinged. A road hinged. This rod is having the mass of M and length of L. It is hinged about this. And guys, this is the axis. Now my dear, we are going to rotate this by theta y, because without initial disturbance vibration will not happen. So if you need to find out the natural frequency of vibration for this, you know we would be going for initial disturbance and the axis will move to this direction. You know that this is a rod of mass m, so it is a distributed mass. So whenever we have distributed mass, center of mass we are assuming at the center. So we would be assuming at L by 2, the center of mass will be there. So here we would be having mg acting downward, mg cos theta acting like this, and mg sin theta will be acting like this. So you know we have given an angular displacement of theta. Because of this, the restoring torque will be coming what? You know mg sin theta is restoring force. Perpendicular distance is L by 2 because rotation is happening about this axis. So you would be writing here mg sin theta into L by 2. What was said by D. Lambert? I theta double dot. Always remember I will be about the axis about which the rotation is happening. JS, I have already derived this previously. Just go back to the video, I have derived it. You can see here. Look at it. I have derived it. Parallel axis theorem. Okay, JS, this is parallel axis theorem. We know about this, we need to find about this. This is parallel axis theorem. Okay, moving to back. So guys, you know that this is the restoring force and distance from the axis of rotation is L by 2. So restoring torque. I is going to be always about the axis about which rotation is happening. So it means I will be about this axis. But we know in the engineering mechanics we have studied that if we have this rod, centroid will be here. So centroidal axis will be there. So about centroidal axis, so I would like to say JS, once again you see this, here also the same derivation is going to happen. So about this we know it is mr square by 12. Sorry, ml square by 12. Here it is ml square by 12. This is we are knowing from engineering mechanics. This is ml square by 12. But axis of rotation is somewhere here. We need to find out I about this. This distance is L by 2. So you would be writing IAA is IGG plus M into distance between the axes is L by 2 ka square. So we can write ml square by 12 plus ml square by 4. You will take LCM, you will be getting 12 ka 1, 4 ka 3 ml square. So it would be coming out to be ml square by 3. So equation will be ml square by 3 theta double dot plus mg L by 2. As the theta is small, sin theta can be written as theta is equals to 0. M cancel out, L cancel out. So you would be writing here omega n as square root of 3g by 2l. If anybody have any doubt, please ask. I feel now that level is there that with the equation I can directly write omega n. Clear for everyone? Please tell me. If anybody have any doubt, if you find I am going faster, you can tell me. Very good, Abhi. Faninder, very good. Aritro, very good. Please tell me, guys. Everybody understood? And do like and share the session, because you know there is no other. You will find that who is taking 5-6 marathons. I have taken your SOM with Abhinav sir. I have taken casting, welding, sheet metal operation. I could complete production in one also. But I wanted to give you in a proper revision, like when you are doing revision. Okay. I don't want you to do like the marathon 6 hours, everything is over. Not like that. That's why in Math Safety also we have given 1 day to one topic. Okay. Clear for everyone? Very good, guys. बहुत बढ़िया. So this is about the rod case. Now my dear, if the point of hinge changes, the things will change. like if we are having the same rod, if the same rod is hinged like this, then this is the point of rotation now. And if I am saying this is at a distance of L by 4 and this distance is 3L by 4. Okay, so this time they are saying find out the natural frequency of vibration. So guys, what we are going to do for that? We are going to give once again that it is a distributed mass, and distributed mass and pure rotation we are having. So torque method is the choice. We are giving initial disturbance like this by theta. You know mg was here, it would be moving here, mg. This is mg cos theta, this is mg sin theta. So what is restoring torque? This time the distance between the axis of rotation to the force is L by 4. So you would be saying mg sin theta into L by 4. DL number said I add my component, I theta double dot. I will be about this axis now, this axis. Okay. So you would be saying this point to be A. So I would be writing IAA theta double dot plus mg L by 4 into theta barabar 0. Everybody know if we are having the rod, if we know I value about centroidal axis ml square by 12, we can find out about any other axis. So we would be writing IAA as ml square by 12 plus this distance was L by 4, m into L by 4 ka square. So we would be getting ml square by 12 plus ml square by 16. Now you know we would be having 48, 7 ml square. So you would be having the equation 7 ml square upon 48 theta double dot plus mg L by 4 theta is equals to 0. So when you would be going for omega n, it would be coming out to be square root of. What is that? You will be having g L by 4. Here it is 7 ml square by 48. Okay, mass will cancel out. So you would be getting 12g by 7m. Please tell me everybody got it or not, everybody understood or not. Then we are moving further. With this we have completed actually this method. Very good Faninder, बहुत बढ़िया. Yes guys, do like and share the session. Let me also share the session in the Telegram channel. Tell me if you find any doubt, then I will help you in that. Yes. Shall we move on guys to the next method now? Everybody is okay with torque method? Fine. So let us move guys. Very good Shreyas. Malesh. Okay, 12G by 7L. I have written opposite. 12G by 7L. Yes. 12G by 7L. Very good. So guys, now we are moving to the torsional vibrations. Okay. Torsional vibrations. When we are talking about the torsional vibrations, here as the name suggests, torque will be happening. So my dear, let us take, there is a shaft and that shaft is connected with the rotor. So my dear, this rotor is having a mass moment of inertia I, and this shaft is having a G as the modulus of rigidity, J as the area moment of inertia about polar axis, L as the length. So my dear, you know, we can equate it with the spring mass system. Like here the mass is with the mass, stiffness is with the spring. So here stiffness is with the shaft and mass is with the rotor. So my dear, when we are going to give a rotation to this rotor by an angle of theta, as this end of shaft is connected with the rotor, because of this the shaft is going to twist, because shaft is having one end fixed. So if one end is fixed, we are going to rotate it, one end it is twisting. But if we are going to rotate it like this is rotation. So for rotor, rotation is happening, but for shaft, twisting is happening. M and M will getting cancelled. Okay, M and M, not M and L. Okay, that M and L, fine, I understood. So my dear, you know, if I am saying the stiffness of this shaft is K theta, and we are going to displace it with the theta, then restoring torque will be coming out to be K theta into theta. What was D'Alembert principle? I theta double dot. So you would be saying I theta double dot plus K theta into theta is equals to 0. And I would like to tell you, in the strength of material we have studied that if we are having a shaft, four shaft, K theta is given as Gj by L. Gj by L. And my dear, if you are going to put it that, you would be getting omega n is equals to Gj by IL. And this is going to be the natural frequency of the system. So you can also feel it like in the spring mass system we have S by M. So you can also write it as S theta by M, because S theta is Gj by L. So it is same as that of spring mass system. Is it clear for everyone or not? Please tell me that. Here we are going to use the concept of twisting, which we have studied in strength of material. Is it clear? Is it clear? Everybody, very good, very good, very good guys. So this is about the torsional vibration. Okay. On this torsional vibration, you can get a question on two-rotor system. Okay, you can get a question on two-rotor system. Two-rotor system. So my dear, what is two-rotor system? Let us say we are having a shaft like this. And this shaft is connected with one rotor here. Here it is connected with one rotor. This rotor is having mass moment of inertia I1. This is having mass moment of inertia I2. And this shaft is having the G, J and L, whatever previously we were having. Now my dear, if this shaft is having one rotor here, other rotor here. So if you are going to rotate it like this, there is no vibration. For vibration, shaft have to twist. So I am going to rotate theta clockwise for one rotor, anti-clockwise for other rotor. When I will do that, shaft will twist. Then you will see these vibrations. So I am going to give theta clockwise here, theta anti-clockwise here. So here if it is clockwise, here if it is anti-clockwise. So this is how the theta will be varying for the shaft. So the center point, not center point, maybe some of the point of the shaft where theta is 0 is said to be node. And from this node we are saying this as L1, this as L2. And whatever we have defined previously, the natural frequency for the first rotor is going to be G1, J1 by I1, L1. This would be the case. For the second rotor, we can write omega N2 as equals to square root of G2, J2 by I2, N2. You know that it is the same as that of S theta upon I1. Okay. And it is also S theta upon I1, upon I2. The only difference is the shaft is same for both, but the length is always taken from the node, because in the previous case also length was taken from the point where theta was 0. So here also we can write it in this way, कि this L1 and L2 are nothing but the distance from the node. But Gj are same for the shaft. So we can say G1, J1 is equals to G2, J2. Now my dear, if you have this shaft and two rotors like that, and you are going to get this type of vibrations, what do you mean by that? It means if you are having the shaft like that and vibrations are happening like that, both will be having the same natural frequency. They cannot have different natural frequency. I will always be of the disk. Mass is always there with the disk. Mass is for rotating body, stiffness is for twisting body. Okay. So guys, when we are talking about that, both have natural frequency same, otherwise shaft will break. So omega n1 should be equals to omega n2. You already know G1, J1, G2, G2 are equal. So we will be writing the square root of G1, J1 upon I1, L1 is equals to square root of G2, J2 upon I2, L2. If you would be going for square, G1, J1, G2, G2 will cancel out because they are equal. You will be getting overall I1, L1 is equals to I2, L2. So you can say the product of I and L is going to be constant. So my dear, when product of I and L is constant, if I will be more, L would be lesser. If I would be more, L will be lesser. So here what kind of question they can frame? They can say that initially I am having a two-rotor system. When I1 and I2 are equal, both are having the value of I. When they will say both are I, you know, if I am writing I L1 is equals to I L2, I cancel out, L1 will be coming out to be L2. It means the node will be there in the center. It means L1 and L2 are coming out to be L by 2. And then they say, now I am replacing the rotor with mass moment of inertia I with another rotor with mass moment of inertia 2I. It means after some time he is removing the I and placing the 2I. Rest is going to be the same. So now this rotor is having the mass moment of inertia I, this is having 2I. Previously node was at the center. Now they will ask where the node will shift. So you will say, we know that I1 L1 is equals to I2 L2. So you would say 2I into L1. I L2. I cancel out. From here you can say 2L1 is equals to L2. So L1 is L2 by 2. And you know L1 plus L2 is equals to total length L. So you can write L2 is 2L1. So L1 plus 2L1 is equals to L. L1 will be L by 3. L2 will be 2L by 3. So you can say previously it was at center, but now the node will be shifting to the rotor of more mass moment of inertia. The new position of the node will be this. L by 3, 2L by 3. So this type of question you can expect in the GATE exam from this topic. Please tell me everybody understood or not. Yes, everybody. Faninder, Danesh, Shavik, Aritro, JS, Shreyas, Malesh, Abhi, Faninder. Everybody understood or not? So guys, we are moving to the end of this natural vibrations. Okay. So I feel within next 20-25 minutes natural vibration may be over. And then we will enter into damped and force damped. So I will try to complete the vibration. Not try. I will complete the vibration before lunch break. And after lunch break, we will go for gear trains first. After gear train, we will go for cam, then governor, then balancing, like that. Gyroscope also. Very good, guys. Very good. So with this, we have completed this two-rotor system. Now we are entering into the relay method, the last method. Relay method. My dear, relay method, like energy method only, it is also based on the energy of system. It is also based on the principle of energy conservation of the system. So if it is based on that, obviously, yes, when we are talking about the relay method, this is valid only for natural vibration. Valid only for natural vibrations. And if you want to know from me that, sir, where to apply this, if you are having only point mass, If we are going to have a distributed mass in the system, then we cannot apply Rayleigh method. Like the rod of mass m, disk of mass m, whenever you see that, Rayleigh method is not applicable. Rayleigh method will be not applicable, means it is applicable, but that's what I am saying. In which cases it will be giving you answer fast. Then it will be giving you answer fast in this case when point mass are there. For distributed masses, you should go for energy method or torque method. Okay. So when we are having point mass, so I am giving you a case. First of all, I will explain it with the spring mass system only, and then we will go for multiple cases. I already told you torque method and Rayleigh method are two most important methods from where we can expect the question. So if we are having this spring mass system with stiffness S and mass M, with stiffness S and mass M. So this method says there is no need to go for any governing equation. It is saying directly omega n is equals to G by delta naught. Here delta naught is static deflection of mass. When we are talking about static deflection of mass, you need to understand one thing. You need to understand one thing, that static deflection is that deflection which is happening before vibration starts. So you know, initially we were having the spring, if you remember the very first slide, and when I made it spring mass system, I told you whatever this is happening, this is static deflection of mass. And I also told you that this is balanced as delta naught by mg. And you have written this equation. So delta naught can be written as mg by s. So when you would be putting this value here, you would be getting the omega n directly, g by mg by s. Answer will be coming out to be s by m. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Very good guys. बहुत बढ़िया. So guys, now we are going to use this method in difficult cases which are coming in exam. So first of all, I am making a case in front of you. We are having a rod which is massless, and here is the point mass available, m. And here we have a spring. This is with the stiffness of S. And I am saying the distance of spring with the hinge point is A and distance of mass is B. So when you have this type of system, you have one choice healthy as Rayleigh method, other is energy method. I already told you for such cases, when we can apply Rayleigh method, we will not go for any other method. Rayleigh method is the best one because here we need not to even make the governing equation. Okay, so that is why always Rayleigh method is preferable. Rayleigh method is our first choice. So my dear, if you see this, you need to find out static deflection of mass. Means by how much mass is deviated before starting of vibration. That is static deflection. So because of this mass, this will be having a tendency to go down. So mass will reach to this position. Why? Because spring is deformable body. So let us say the mass is getting displaced by delta naught, which is static deflection of mass. Spring is getting deformed by delta 1. Okay. So if you are going to say, can I say that there is a two triangles? One triangle is this yellow one, other is the white one. And if you see these two triangles, you can write delta naught by B is equals to delta 1 by A. From here, can we write delta naught as B by A into delta 1? Everybody is getting it? Yes, Hari, hello, how are you? So if we are getting delta naught as B by A into delta 1. Now my dear, when we are talking about this, wherever you get the hinge point, you always need to take moment to be 0. Summation moment about O to be 0. You know mg is acting in downward direction. So mg will be creating clockwise moment. So Hari, you are late today. Okay, no issues. Mg into B. and you know that this S delta will be creating anti-clockwise. So minus S into delta 1 into A is equals to 0. So from here delta 1 can be written as nothing but B by A into mg by S. You just need to put this value here to get the delta note. Delta note will be coming out to be B by A ka square mg by S. So we would be having the natural frequency of vibration as you know that it is G by delta naught. So when you will be putting this value G by B by A ka square into mg by S, G will be getting cancelled out. You would be getting A by B, S by M. Everybody understood or not? Please tell me. 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 Very good, Vinay. Faninder, बहुत बढ़िया. So GG will get cancelled out and you will get the answer. Okay? Very good. Very good. Very good. Now my dear, this is how we have found out for this complicated system also. Now the same complicated system can be there with the change of position of mass. Like you can also have this, where spring is present here, mass is present here. Okay. So whenever you have this, you know we are always interested in static deflection of mass. This is S. So this time also we will be making like this. This time this is delta 1. This is delta naught. And let us say this distance is A. This distance is B. So once again you will go for similar triangle. You will say delta naught by A. Delta 1 by B. From here delta naught is coming out to be A by B into delta 1. Once again you would be taking summation moment about O to be 0. So when you will be going for summation moment about O to be 0, you know this mg is creating clockwise, so mg into A. You know spring is deflected, so here will be S delta 1. This would be anti-clockwise. So minus S into delta 1 into B. From here delta 1 will be coming out to be mg by S and A by B. Put this value here, you will be getting delta naught as A by B ka square mg by S. From here we can write omega n to be G by delta naught. Everybody can do this, please tell me. Wonderful guys. सब कुछ होगा हरी, पहले ये तो पढ़ लो जो चल रहा है. सब कुछ होगा, जो सब कराया है तो एक दो चीज छोड़ेंगे थोड़ी. एवरीथिंग वुड बी डन. ओके, HMT भी होगा, मेटल कटिंग भी होगा, मेटल फॉर्मिंग भी होगा, सब कुछ होगा. मैथ्स भी होगा, एप्टीट्यूड भी होगा. ओके, इज इट क्लियर फॉर एवरीवन? Clear for everyone? Very good. So guys, moving further. Now one case will you try? One case will you try? Tell me, tell me, tell me. Yes. So the next case is slightly different. This time we have hinge in between. Here we have mass. And here we have spring. S is the stiffness, M is the mass, and the distance is A from here, B from here. Will you try this? Thank you, Hari, but that is from the BYJU'S side only. Okay, tell me the answer. Will you try this? Will you try this, guys? Will you try this? Yes. So guys, How to do this? Once again you will assume mass is going down. This will be delta naught. This will be delta 1. Okay. So try this. I am waiting for you, don't worry. Okay. So I would like to tell you guys, this type of question you will see in the exam. Okay. So try this, and after that 2 more cases we will go for pulleys also, and after that we will be going for longitudinal and transverse vibrations of beams. So by 12 p.m. natural vibration will be over. Then we will enter into damped and force damped. In damped and force damped, much time will not be required because we are not going for derivations, because they are useless, you know, for exam. So it will be completing soon. And even I feel if we will be going with the good speed, I feel that chances are we can complete gear train also before break. Okay, and that is required because I want to make you free by 4 or 5. Okay, so that we can complete tone and vibration pending by 5. Gyroscope also you will see live today. Okay, so every topic we will be covering as per the gate requirement, because these marathons are targeting gate. But yes, if you are preparing for other exams, they are equally useful. Okay, but for engineering services also they are useful. Okay, but I know for mechanical very less seats are there for ESC. That's why ESC students are less interested. Okay, now some students have given the answer, so I will definitely go for it. So first of all, you would be going for similar triangle. You know that this and this angle are equal. This is 90, this is 90, this angle is also equal. So we can go for it. You can write it as delta naught by B, delta naught by A. So delta naught will be coming out to be B by A into delta 1. So we need to find out delta 1, take summation moment about O to be 0. This is O. Going for summation moment about O to be 0, mg is clockwise. S delta 1 would be acting like this. This would be anti-clockwise. S delta 1 into A. From here delta 1 is B by A, mg by S. So you can put this value here and get the delta naught B by A ka square mg by S. So omega n would be coming out to be G by delta naught. Clear for everyone? Very good, very good. This is how we can solve it. Okay, I feel everybody have done it and it is very easy now. Now my dear, we will go for very good Vinay. So moving further guys, now we are talking about the cases with 2 springs in relay method. Springs can be more than one also. Okay, so when we are talking about this, we would be having this case. One spring is there like this with stiffness S1 and other spring is there with stiffness S2. If you see this case is similar to the first case. The only difference is with this stiffness. So if S2 is not there, so you will be doing it like that only. If S2 is not there, this mass will reach to this and it will become case number 1. And for case number 1, we have calculated delta naught as B by A ka square mg by S. So I would be saying B by A ka square mg by S, because here S is S1, so we would be going like that. The distances are same, B and A. Now my dear, forget about everything. Just imagine if this spring mass system is there. If only S2 is there. If only S2 is there, you know that. For that, what we can write? Delta naught will be. You know, for this, it is spring mass system. Mg by S2, it is similar to this case. Spring mass. So for that, you know, delta naught is mg by S. So I have written mg by S2. So my dear, but originally both are there. So what is principle of superposition? originally you will add both of them, b by a ka square mg by s1 plus mg by s2, and you know after that the next step is omega n is g by delta naught. So you can see difficult case how we can do very easily. इसका पीडीएफ मिलेगा हरी, कल भी तो दिया था, कल वाले का पीडीएफ भी तो दिया था, पीडीएफ मिलेगा, डोंट वरी, आफ्टर द क्लास यू विल गेट द पीडीएफ, सो डोंट वरी अबाउट दैट. Is it clear for everyone? Is it clear for everyone? Clear for everyone? Even I will try to merge this with the first part of tome and you will get the complete PDF. Okay? Very good guys. बहुत बढ़िया. So guys, now we are having last two cases for relay method. They are related to pulley system, and then we will go for longitudinal and transverse vibrations of beams. Degree of freedom also we will cover, don't worry. So guys, when we are talking about a system like this, spring with stiffness S, there is a pulley like this. This is the case, and here they are saying find out the natural frequency of the system. Here they are saying find out the natural frequency of the system. Hurry, for those things you can connect to me separately, okay, because that is particularly session going for some particular thing. For that you can directly connect with me, okay, separately on WhatsApp, call, Telegram, wherever you want, okay. So you can connect me after the class for that. So S and M, we are having this case. So my dear, first of all, when you will be having this mass M, you know that downward force is mg and tension will be always acting away from the mass. And when you will be seeing the pulley, you know that pulley is frictionless. It is given as frictionless. In natural vibration, friction is not there. So for frictionless pulley, tension is same at both the sides. So here we will be having a tension acting T, here we will be having tension acting T, here we will be having tension acting T dash. And if you see this equilibrium, from here we can write T is equals to mg. From here we can say T dash is equals to 2T. And if you see this spring, so on spring you would be having T dash. Okay, so this is the individual equilibrium diagram of free body diagram, we can say. But we are supposed to find out natural frequency of the system. For that we need to find out the static deflection of mass. Just imagine that you are having this pulley and mass system separately, and you are going to put this pulley onto this spring. Now we are having this spring, okay, and you are going to put this pulley onto this spring. Initially this is the spring like that. So you know, when you would be taking this point here, because of this mass, no doubt pulley is massless, because when two masses will come, we need to go for energy method. Only one point mass is there here. So when we are going to take this pulley here, because of this mass, spring will be deflected. So spring would be coming down, and let us say the pulley is coming to this position. Initially pulley was here. So let us say pulley is coming down by delta 1. Now because of this, mass will be also coming down. Now you know that initially pulley was at this position. Now pulley is at this position. What is the impact of that? You just need to understand now. Previously, if pulley was there, you were having the string like that. Like that. Okay, like that. Now you can understand one thing. Initially, let us say this was the condition for mass. Now my dear, when the pulley is going from this to this point, can you see this part of the thread and this part of the thread? Both are delta 1. And both of them will be wounding over the pulley like this, and because of that, mass will be going down. So mass will be going down by 2 times of delta 1. So if mass is going 2 times of delta 1, that is our static deflection of mass. Please tell me everybody understood this or not. because this is a very important concept where students are having doubt all the times. So if this is going down by delta 1, this will be going down by 2 times of delta 1. Delta naught is 2 times of delta 1. If that is the case, you can say now ki delta naught, which is static deflection of mass, is 2 times of delta 1. And you know, if spring is deflected by delta 1, T dash can be written as S into delta 1. So we can write delta 1 as T dash by S. So 2 into T dash by S. T dash is 2 times of T. So we can write 2 into 2 times of T by S. T is mg. So we can write 4 times of mg by S. And after that, you know, natural frequency of vibration is nothing but G by delta naught. So when you will be putting this value, you would be getting S by 4m. Okay, this is how we can solve this question. Everybody got it? So guys, this is how we can do this. Now my dear, we are moving for the similar case. This time we have this stiffness as S1 and one more spring is there with stiffness S2, and here we have mass. We will go with the same philosophy. If S2 is not there, it is previous case only. Then delta naught is 2 times of delta 1, or delta naught is 4 mg by S. So I can directly write delta naught is 4 mg by S, and that S here is becoming S1. But if I say if S2 only is there, then you can say this is S2, and you know the tension is T about the pulley. So you can write T is S2 into delta naught. So delta naught will be coming out to be T by S2. T is mg by S2. But you know, if both are there, you will go for principle of superposition, and delta naught will be coming out to be 4 mg by S1 plus mg by S2. And you know, omega n would be coming out to be G by delta naught. Is it clear, guys, for everyone? This is how we can do. Everybody understood? If anybody have any doubt, please ask, then we are moving further. Rudra, which case? The previous one or this one? Rudra, which case? Previous one or this one? Which should I repeat? Previous one or this one? Tell me. Tell me. Previous one. Okay. You can see the previous one. First of all, when you will see this mass FBD is mg downward, tension upward. When you see the pulley FBD, tension this side, because frictionless and massless pulley. So you would be having tension equal. If it is not frictionless, then you know T1 by T2 e to the power mu theta. But it is frictionless, so TT. And T dash above. Why T dash above? Because this is also a spring. In that also tension will be coming. For equilibrium, this T dash will be equals to 2 times of T. For equilibrium, T is equals to mg. Now my dear, you have the spring. Spring will be acting with T dash. Why? Because if pulley is having tension T dash, spring will also be having T dash, because body is in equilibrium. So guys, I feel FBD is clear. The problem is how to find out the delta naught of mass. So when you have pulley here, let us say, and you are going to put this pulley here with the spring. As pulley is having this mass, and when you will put this pulley here, you should understand that because of this mass, the spring will be getting deformed. So spring is coming down by delta 1. The same amount pulley is coming down. But you know, pulley was having this string like that. So this part will be coming as it is like this. But where will this part and this part will go? Both these delta 1 and delta 1 will be going on this side only. So because of that, mass will be going down by which amount? delta 1 of this side, delta 1 of this side, total is 2 delta 1. So that is my delta naught. And if you know delta naught is 2 delta 1. What is delta 1 from this equilibrium? S delta 1 is tension T dash. So T dash by S is delta 1. We have kept the value. And when we have kept the value, T dash is 2T by equilibrium. So 2T is mg, 4 mg by S. We got this. Now it is clear, Rudra. Please tell me that. Wonderful, guys. So guys, with this we have completed the Rayleigh method cases. Now similar cases, whenever they are asking, you can do like that. Okay? Fine, Rudra. Moving to the last part of this natural vibration, and in next 5 minutes we are going to complete it. Then we will enter into damped vibration system. So we are having longitudinal and transverse vibrations of beams. Longitudinal and transverse vibration. They are also the part of Rayleigh method only. Longitudinal and transverse vibrations of beams. Sometime they may be asking you that there is a cantilever beam, and on this beam at the free end we are putting a mass m. Find out the natural frequency of vibration. So for that, what to do? You know, because of this mass, this beam will be deflected like that. And you know, static deflection of mass without any external disturbance is nothing but the deflection of point A. So deflection of point A is nothing but static deflection of mass. And I feel everybody knows, if we have a beam, P is the load acting, length is the L, then you can find out deflection at A is nothing but PL cube upon 3EI. PL cube upon 3EI. So if we have PL cube upon 3EI, then my dear, here just imagine P is mg. They are equivalent cases. So we can write it as mg L cube upon 3EI. Now my dear, if you want to find out the natural frequency as per the rule, it is G by delta naught. What is delta naught? Static deflection of mass. Put the value. G, what is delta naught? Mg L cube upon 3EI. So answer will be coming out to be 3EI upon ml cube. So here you have to utilize the concept of strength of materials. And this type of questions have already been there in GATE. So you can get the repetition of these types of questions. Okay, the only difference is they will give you the value of EI, they will give you the value of M, they will give you the value of L. Rest thing are going to be same. They can also ask you by giving a simply supported beam. They can say mass is there. Then what you will do? You will imagine it as a simply supported beam, and this acting as mg. And once again you will find out the deflection. Deflection of this point is acting like static deflection of mass. Rest the procedure will remain the same. Please tell me, everybody understood the transverse vibrations? As they are acting perpendicular to the longitudinal axis, they are said to be the transverse vibrations. Everybody understood or not? Please tell me that. Everybody understood or not? Please tell me that. Yes, Abhi, Shreyas, Vinay, Dhanesh, Aniket, Aritro, Rudra, Rahul ji, Hari, Dhanesh. Wonderful guys. Wonderful guys. So now we are having the longitudinal vibrations. If we have a rod like this is massless bar. Massless bar. And let us say on this massless bar, we are having a mass at the bottom. So my dear, if that is the case, this bar is massless, but some external mass is acting like that. And they are asking you what is the longitudinal vibration of the system. So in that case, you can consider it like spring mass system. You know that stiffness for the bar in the strength of material you have studied as AE by L. So you will directly write omega n is nothing but square root of S by M. So you can go for AE by ML. Clear for everyone? And if you want to go by the static deflection of mass, then you can write omega n is equals to G by delta naught. Here how you will find out delta naught? You can consider it as a bar on which some force is acting P, and that P is equals to mg. You know delta will be coming out to be PL upon AE. So we can write mgl upon AE. So you just need to put the value. Whatever the deformation will happen, the same will be the static deflection of mass. So we can write G by mgl upon AE. Answer will be coming the same. So choice is yours whether to go by normal. Atharv, YA or YC means deflection at that point, because in the strength of material we were showing deflection by Y. Y is deflection at that point in the beam. Okay, if you have studied the strength of material, there we were showing deflection by Y. Okay, is it clear? If anybody have any such doubt, YA is deflection at A, here YC is deflection at C, because in the strength of material we have derived the expressions for that. That's why I am directly using that terminology, assuming that you have attended strength of material. Because if you don't know, so longitudinal transverse vibration we cannot do, then you have to leave this topic. Clear for everyone? With this, natural vibrations are over. Everybody is okay. Shall we move to the degree of freedom in next 10 minutes and then enter into damped and force damped vibrations? Are we ready? So damped and force damped vibrations will go like this. They will not take much time. And I am trying to complete gear train before lunch break. And after lunch break, we will be starting with gyroscopes. Okay? Yes. Moving further, guys. So we are having the last topic as degree of freedom. Atharv, you understand or not? Atharv, you understand or not? Degree of freedom. Degree of freedom you have studied many times. Even I taught you in the tome part first, where I told you degree of freedom is the number of independent motions in the system. So the number of independent motions in the system is said to be the degrees of freedom. And if we are having number of independent motion as the degree of freedom, then my dear, I would like to tell you here that in the vibration system, if we are having this spring mass system, you know this system will be having only one type of motion like this. So when it is having only one type of motion, so only one variable is required. So degree of freedom will be coming out to be 1. Similarly, if you are having simple pendulum, to see the motion only one variable theta is required. So degree of freedom will be 1. Now you tell me what can be the maximum degree of freedom? What can be the maximum degree of freedom? When we are having this system, one spring and two mass. Now in this direction one motion is possible. In this direction second motion is possible, because we have two springs. So one variable is required to define this motion, other is required to define this motion, x and y. So degree of freedom will become 2. Even if we have the system like this, degree of freedom will be 2. If we are going to have like this, just imagine this is in z direction, degree of freedom will be 3. Okay, so my dear, we can also have the case with this one more mole is there. Motion of first mole can be given by theta, second mole can be given by phi. Degree of freedom will be 2. If we are going to have a spring mass system, and along this we are having a simple pendulum, one motion is this, other motion is this, x and theta, degree of freedom will be 2. Okay, are we getting it? if we are going to have one spring, one mass, other spring, other mass. This is M1, this is M2, this is S1, this is S2. Now my dear, you can give, let us say, x1 motion to this mass. Because of this S2, it can also extend and compress. The motion of M2 will be different than x1. So I will be representing it with x2. It means if it is going down by 2 centimeter, it does not mean it will also go down by 2, it may go by 3 centimeters. So that is why two variables are required. So degree of freedom will be 2. Even you can have can you tell me the degree of freedom for this system? Can you tell me the degree of freedom for this system? Can you tell me the degree of freedom for this system? Yes, very good. 3. For this system, degree of freedom will be 3. So now I feel very easily you can tell the degree of freedom of a system. Can you tell me what can be the maximum degrees of freedom? Very good, JS. Very good. Ancient Heavens Lord. Ashray. Can you tell me what are the maximum degrees of freedom possible for any system? Very good, Hari. Can you tell me the maximum degree of freedom possible for any vibration system? Okay, like Rahul ji is saying 6. Very good. I told you 6. But for vibration system, they can be infinite as well. Because if I have more than 6 masses, like let us say, if I have 1 mass, 2 mass, 3 mass, 4 mass, 5 mass, 6 mass, 7 mass. So you will itself say the degree of freedom is 7. Even if you are having a beam, you can say every part of the beam can be considered as a small mass. And when it is going to deviate like that, this part is deviated by delta 1, this is deviated by delta 2, this is deviated by delta 3, delta 4. So if you will find out natural frequency for every part, you know it is defined as G by delta naught. So this is going to be delta 1, delta 2, delta 3, every part will be having different frequency. So here you can say degree of freedom will be infinity. So in a vibration system, the maximum degree of freedom can go up to infinite. There is no such limit of 6 and 12 on a vibration system. You need to take care of that. Okay? Yes. So with this we have completed the natural vibration system. Okay? Now we are entering into the damped. Okay. Would you like to see one more question before we complete? Would you like to see one more question before we complete natural vibration? Would you like to see one more question before we complete natural vibration? Thank you, Hari. But right now, please concentrate on the class. Okay. Fine. So the next question is this. We are having 2 springs. This is a bar. Spring 1 is with the stiffness of S1. Spring 2 is with the stiffness of S2. And this is a massless bar. We are going to have a point mass present like this. And this is at a distance of A from here, B from here. So guys, we are going to find out the natural frequency for this system. This question is already been asked in engineering services mains, and it can come in GATE also. Okay. So when we are going to have this system, we know that for a 1 point mass, we need to go for Rayleigh method. Rayleigh method requires static deflection of mass. Let us consider a particular condition of this bar like this. This is the condition of the bar. Now as we have two springs S1, S2, they have different stiffnesses and the mass is also not at the center. So because of that we may be having this side of spring will be deflected by delta 1 and that part of spring will be deflected by delta 2. Okay, and you know that we are interested in static deflection of mass. So we are interested in this. This is static deflection of mass delta naught. Just consider this difference as delta 2 minus delta 1. So if we are going to find out this, we can find out delta naught. Delta naught can be written as delta 1 plus y. This is y. And you know this distance is A, this distance is B. You can apply the similar triangle. From the similar triangle you can write delta 2 minus delta 1, this one, divided by A plus B. That is equals to, this is y by A. So from here we can find out the y. Delta 2 minus delta 1 into A by A plus B. So when we are getting this, when we are going to getting this, so delta naught is delta 1 plus delta 2 minus delta 1 into A divided by A plus B. You know when we will be getting this delta naught, omega n is simply G by delta naught. But the problem is we don't know delta 1, delta 2. So we can write that total weight is mg, and for equilibrium, whatever the spring forces are going on, they are going to balance this mg. So one equation is Fs1 plus Fs2 is equals to mg. Fs1 is S1 delta 1. Fs2 is S2 delta 2. It is equals to mg. This is one equation. And about this hinge point, there is no rotation. So we can take summation moment also. Fs1 into A is equals to Fs2 into B. So S1 delta 1 into A, S2 delta 2 into B. This is the second equation. So whenever the data is given to you, from this and this you can find out delta 1, delta 2, put it here, you can get delta naught, put it here, you can get omega n. So when this will be coming as a question, the data will be given to you. Please tell me everybody understood or not, and do like and share the session, guys. With this the natural vibrations are over. I already told you in first 2 hours we will be completing it. Ancient, that is very simple. Now when you will equate this by S by M, you can find out the equivalent stiffness. What is different in that? Okay, fine. And if you are still looking for equivalent stiffness, that we will be clearing with the help of questions in the practice session. Moving further to the damped vibration now. Natural vibrations are over. Okay, we have some questions if you want to do. Can you solve this question? This is the PYQ of gate. Yes, we can solve it. There is no requirement of what you are thinking. We can directly find out. But data are required because otherwise it is complicated. We can find out, yes. But with that complicated data, why to do that? Okay. If it is given, because in that 2 marks question cannot be like that. Data will be given to you. So a mass m vibrates on a frictionless platform between 2 sets of spring having individual spring constant. What is the combined spring constant of the system? Yes, you can see this K1 and K2 are in parallel, and this K1 and K1 they are in series. Tell me. First, what would be the answer? Hari is saying D is the answer. What about others? Try to solve it, guys. Try to solve it. Try to solve it. Okay, everybody is saying the answer to be D. Farinder also saying D. So when you are going to see that, you know K1 and K2 are in parallel. So K1 plus K2 will be the stiffness of this system. So we can say 1 by K1 plus K2 plus 1 by K1 plus K2. This will be the equivalent stiffness. Okay, 1 by K equivalent. So when you would be going for this, I feel you can find out very easily. K equivalent will be coming out to be. Is it clear? Because when you will see this K1 and K2, they are in parallel. So K1 plus K2 is for this, K1 plus K2 is for this. So you can say 1 by, this is, I feel answer will be coming out to be, K equivalent will be, this is 2 by K1 plus K2, 2 by K1 plus K2. Have I done something wrong? एक तो आपके कमेंट बार बार छुप जा रहे हैं. Okay. Yes. Fine. So what is the answer? A, B, C, D. What you are getting? You can consider these two in parallel. Sorry, I have done, I feel, slightly wrong. These two in parallel, these two in parallel. So when you would be considering this, it is 2K1 plus 2K2. There is nothing like series, okay? 2K1 plus 2K2. I feel it will be coming out to be B. B would be the right answer, na? Don't you feel B will be the right answer? Arey bhai, this K1 and this K1 parallel, this K2 and this K2 parallel, then this and this also in parallel. There is no series. It is like this. 2K1, 2K2. B would be the right answer. Is it clear for everyone? Please tell me that. अरे clear है कि नहीं? मेरे को भी confuse कर दिया आपने D बोल के. Is it clear? B would be the right answer. It is very easy question. This is a previous year question of gate only. Okay? B is the right answer. It is PYQ of gate only. Now my dear, we have this question. They are asking you the natural frequency of vibration. This is stiffness given. You know this is also a parallel. This is also PYQ of gate. So when you would be finding out omega n, it would be coming out to be S equivalent by mass m. What is S equivalent? It is going to be S1 plus S2. Put this value, get the answer. They are asking in cycle per second, so they are asking Fn. Fn is 1 by 2 pi into omega n. Solve it and get the answer. Yes. So whatever cases I have taught you, this type of questions are coming, and you can see they are the simple type of questions based on the series and parallel connection of springs. Solve this. Farinder is saying the answer to be C, 10 by pi. Okay, what about others? This is 20 plus 20, 40. 40 by 100. It is going to be 40 kilonewton divided by 100. So 10 by pi would be the right answer. C. 10 by pi would be the right answer. Okay guys, now I feel we can do very easily the things. Moving to the second chapter, we will do some questions in between also. Let us move to the second chapter, that is damped vibration system. So my dear, when we are talking about the damped vibration systems, first of all, damping is the name of kinetic friction. technical name of kinetic friction is said to be damping. And kinetic friction means there is a conformation of relative motion. And if there is a conformation of relative motion, we would be showing with this damper. And my dear, in this damper, I would like to say that whenever we say, there is a famous saying that friction eats velocity. Friction eats velocity. So that is why the damping force would be found to be directly proportional to x naught. More velocity, you will find more damping force, and Fd is defined as c times x naught. Here c is the coefficient of damping. And my dear, when we are talking about damping, damping can be there from two sources. It can be either Coulomb's damping or viscous damping. So when we are having the friction between two dry surfaces, it was observed by Coulomb's, so we call it as Coulomb's damping. And if we are having the liquid in between, so because of the viscosity, we are going to have viscous damping. So Fd can be written as C into x dot. And the system of damped vibration system is shown like this. There will be a spring with stiffness S, a damper with damping coefficient C, and mass with M. And there is no unbalanced force. We are going to displace it by x to start the vibration. So here you can say Sx will be the spring force, Cx dot will be the damping force, and Mx double dot is the D'Alembert component. And the equation is Mx double dot plus Cx dot plus Sx is equals to 0. This is the governing equation of damped vibration system. Everybody is ready with the results now? Shall I go with results? Nobody wants derivation because here derivation is useless. There is no use of derivation in any question. So if we have this equation can be further written as x double dot plus c by m x dot plus s by m into x is 0. And guys, then we are going to define something. This equation is further rewritten after some derivations. X double dot plus 2 zeta omega n into x dot plus omega n square x is equals to 0. And whenever you are going to see these two equations, you can very easily say that here 2 zeta omega n is nothing but c by m. And you can write omega n square is nothing but s by m. And you can see when we are writing like this, zeta is said to be nothing but damping factor. It is said to be damping factor or damping ratio. Okay, rest you already know. So from here you can also define zeta to be c by 2m omega n. This is the first formula for zeta. Okay, this is the first formula for zeta. C by 2m omega n is the formula for zeta. Now my dear, zeta is the damping factor and 2 zeta omega n can be written as c by m. There is one more term that is said to be degree of dampness. There is something called as degree of dampness. Degree of dampness is defined as nothing but the zeta ka square. So what is zeta ka square? We can also write it as c by m ka square by s by m. If you are going to say that, we can also write it as c by, let me write in other way, you can directly say zeta square is nothing but the degree of dampness. Okay, so zeta we have written in the previous slide as c by 2m omega n. So we can also write it as c by 2m omega n ka square. Okay, so if you are writing like this, you can also write it c by 2m upon omega n ka square. This is the degree of dampness. So the choice is yours how you want to write. So this is the degree of dampness. So my dear, the first formula is zeta. So guys, I know if I would be going with derivation, you will like it more. But I feel here our target is not to like. Here our target is to cover the syllabus in the most efficient and less time. Okay, more efficient way in the less time. So I am telling you whether I go for derivation or not, you need to remember some results from which direct questions will be there. So first result is zeta c by 2m omega n. C is damping coefficient. Second formula is degree of dampness, which is zeta ka square. C by 2m omega n ka square or C by 2m ka square by omega n. Whatever you want to write. Now my dear, when we will be going for the derivations, what we would be getting after that, I am telling you that as well. Okay, just let me move. So when we are going for the derivation, the final results we would be having based on the value of zeta. All the damped vibration system can be classified into three types. The very first type is overdamped systems. And when we are talking about overdamped systems, here zeta is going to be more than 1. Actually, zeta is telling you about loss but a restoration. So if loss is going to be more, restoration is less, we call it to be overdamped system. And when we are going for the expression for this, you need not to remember for overdamped system, it is coming out to be A e to the power minus zeta plus square root of 1 minus zeta square into omega nt plus b into e to the power minus zeta 1 minus zeta square omega nt. So my dear, this is the value of x. You can see it is shown by two negative exponential functions. You can see this is negative exponential because when you will put zeta more than 1, let us say zeta is 2. So it is e to the power minus 2 plus 2 ka square is 4, 1 minus 4 is 3. I feel I have written opposite. It is zeta square minus 1. Not 1 minus zeta square, it is zeta square minus 1. Here also zeta square minus 1. So when you will see this, zeta is 2. Minus 2 plus 2 ka square minus 1 is 3. So minus 2 plus root of 3. Root of 3 is less than 2. So overall this term is negative, this term is also negative. So this is the sum of two negative exponentials. Everybody understood that this is the sum of two negative exponential. Zeta is more than 1, this will be negative, this will be negative. So whenever we are having this, then my dear, whenever you are going to have two negative exponential, it can also be converted into single negative exponential. So when you would be converting it into the single negative exponential, it is going to be some constant, let us say r into e to the power some negative. And if it is going to be like that, we can plot it overdamped system like this. This is how overdamped system will be plotted because it is going to be the function of e to the power minus x or minus t. So you are having x on the y-axis, t on the x-axis. So when we are going to have this type of curve, what do you mean by that? It means whatever the displacement is, that is on the one side, that is not on the other side. And that kind of system, there is no vibration present. I would like to tell you, if you want to see whether vibrations are present in a system or not, for that you need to check only one thing, whether the final expressions are having sine cos term or not. You can see here final expressions are not having any sine cos term. A e to the power minus zeta plus zeta square minus 1 omega nt b, this, there is no sine cos, because sine cos are said to be harmonic function. There is no harmonic function. So when there is no harmonic function, we can say that there is no vibration present in the overdamped system. This curve is not correct. Whatever curve I have plotted, that is correct. So my dear, that is why in overdamped system there is no vibration present. So that is why we are using them in some of the application like door hinges. You will see they are used like this. So in the door hinges, whenever you are going to open the door like this, let us say you are going to open the door. So when we are going to open the door like this, you are going to open the door like this. Then door will be closing slowly like that. Is it clear or not? Please tell me. When you are going to open the door like this, it is going to slow like this. So very slowly it is going to close like that. And that is the application of overdamped system. Then my dear, you are also having the same application in the aircraft seats. when we are having aircraft seat. This is without damper, this is over damped vibration. Is it clear? Can you feel it? So this is without damper, what will happen there? This is with the over damped system. So these are the application of the same. So in the seats also these dampers are provided here. Okay, here the dampers are provided. And in door hinges, you are knowing this, you have seen in many times in the classrooms. Okay, now my dear, we are moving to the second, that is critically damped system. In critically damped system, we have zeta is equals to 1. And for that, x is coming out to be this, a plus bt into e to the power minus omega n t. Here a plus bt is a linear function. And this is a negative exponential. So you tell me, as there is no harmonic function, will there be any vibrations here? As there is no harmonic function, will there be any vibrations here? Will there be any vibrations here? As there is no harmonic function, will there be any vibrations here? No, there are no vibrations. So not in overdamped system, neither in overdamped system nor in critically damped system. So vibrations are not present in both of the systems. So we will say vibrations are not there. But my dear, when you are going to make the curve for this type of system, in the MSc mathematics you learned, whenever we are going to make the curve between x and t, then my dear, initially for some time, linear function is going to be dominating. For some time linear function is dominating, after that negative exponential will be dominating. So initially linear function will be coming like this. This is a plus bt. Okay, but this will not continue. After some time, you know that if I make the only negative exponential, it would be coming like this. But after this time t, negative exponential becomes dominating. So the curve which was starting from here will be starting from here. So when this curve was like this, now you are going to make this curve like this. Don't you feel it will be coming like this? Slope will be increasing. Because which was starting from here, it is starting from here. So you just pick this point here. So obviously this entire curve will be tilted to this point. So in the previous case you can see infinite time was required to close the door. Once you have opened the door, then you will find one person coming in, second person coming in, third person coming in, fourth person, maybe entire class is coming in until this is going to be completed. So response was very, very slow. But my dear, whenever we are talking about critical damping, response is not slow. Why? Because you can see that x is becoming 0 in a very small time. So here we will say the response is going to be quick. So if you want to understand, let us say I am going to apply the critical damping in the door hinge. Then the door hinge, like you are going to enter the door, door will be going like that. Critical damping is this. Over damping is this. Can you feel it? Critical damping is this. So if critical damping is applied in the door hinges, you are going to just open the door. Door will be coming onto your head. You will be into the hospital directly. Is it clear or not? Is it clear or not? So that is said to be critically damped system. So this, my dear, whenever critical word is getting into the picture, critical word is not a normal word. It is coming whenever there is a difference of earth and sky. It is not coming for the difference of day and night. Like have you seen in the movies of 90s, there was a theme of movie, the mother of hero was in hospital. Amitabh Bachchan, angry young man. And then doctor was coming and saying that the patient is critical. And all the people nearby start weeping. Why? They understood that the patient can go anywhere, because critical means the things are not normal. Death is very near of something. You have seen this thing many places. Like whenever we are studying the thermodynamics, you have studied this vapor dome. You know, this is critical point. Whenever we are talking about any constant pressure line, you have liquid, liquid plus solid, liquid plus vapor and vapor. But here liquid plus vapor stage dies. Liquids are directly converting into vapor without having liquid plus vapor phase. So at critical point, this phase is getting died. Similarly, you must have studied critical thickness of insulation in heat transfer. If you are not going to provide critical thickness of insulation, our electrical wires will die. They will burn out. If you are not going to provide the critical path is the minimum time required to complete a project. Industrial engineering. So my dear, everywhere, wherever you see the critical word, the differences are of earth and sky. जमीन और आसमान का फर्क होगा इस तरफ और उस तरफ. Are you getting it? So here, my dear, also whenever we are talking about the application of this critical damping was used in the guns, rifles and all. Because previously, if you have seen a video of Priya Warrior, which was famous before some time, I don't know exactly, 2017-18 maybe. There was a famous, you can say, that she is doing like this. So when you are going to provide over damping in the guns and rifles, you know, whenever you are going to just fire, it is taking the recoil and it is going back like that, because whenever you are applying that force, it is coming back as a reaction. Yes, Surjit, where were you? I have not seen you from many days. Where were you? So when we are having this kind of case, okay, so if you are going to provide the critical damping, AK-47 come up with this innovation that critical damping was provided. So when quickly you are going to fire, because it is going to give quick response. So because of that, it was possible to fire a complete belt in 2.5 minutes. And one belt is having 53 magazines. One magazine is having 33 bullets. So guys, this was possible only because of the concept of critical damping. Because if you would be doing like this, some person will be coming to you. If he is not fired, he will slap you and go away. Okay. So that is why we want the quick response there. In guns, in rifles. So that is why we are going with this critical damping. Okay. So guys, in the critical damping, whenever we are talking about the difference between the curve is like this. This is over damping. Critical damping is like this. This is the difference. So over damping is going for so long. Critical damping is making X0. But one thing common is vibrations are not present in both of the system. So that's why the derivations of theirs are useless. We need not to go for that. Now we are going for the underdamped systems. Now we are going for underdamped system when zeta is going to be less than 1. My dear, when we are going to derive for that, we are getting the x as equals to x e to the power minus zeta omega n td into sine omega dt minus psi or minus phi. This is the equation coming for underdamped system. That you need to remember. Okay, that's fine. Okay, Srujit. So my dear, this is the equation you need to remember. This is the expression for x for underdamped system. You tell me here, do you have any harmonic term or not? You tell me here, do you have any harmonic term or not? You tell me here, do you have any harmonic term or not? Do you have any harmonic term or not? Yes, Aritro, Ashray, we have. So this sign is present. So because of sign, I can give you guarantee that vibrations will be there. Vibrations are there. So these systems are important for us because here vibrations are there. But my dear, these vibrations are not this time with the natural frequency of vibration. They are with the damped frequency of vibration. Here once again one more formula is coming where omega damped is defined as 1 minus zeta square into omega n. So my dear, omega damped is always going to be, you know, zeta is less than 1. So omega d is going to be less than omega n. So the best thing here we get to know is vibrations are there, but they are with damped frequency which is less than natural frequency of vibrations. Don't worry, I will write all the formula at one place also. So vibrations are there but with the damped frequency, not with the natural frequency, and damped frequency is lesser than the natural frequency of vibrations. Is it clear? So if that is the case, my dear, what is the second thing? Amplitude. If you see, the amplitude is also not constant, it is negative exponential. So when we have amplitude negative exponential, so my dear, amplitude is reducing with the time. So when the amplitude is reducing with the time, we need not to worry. After some time, vibration itself will become zero. So we need not to worry. After some time, vibrations will become zero. So guys, when we are entering into the damped vibration system, we are introducing the first reality of mechanical system, that is friction. With the friction, in first two system, vibrations were not there. In the third system, vibrations are there, but they are becoming zero after some time. So we need not to worry about them also. So when we need not to worry about them, then why we are studying vibration? Because when we are going to enter into the last type of vibration, force damped system, there you will see vibrations will become in such a way. Vibration will become amar. Amar means they will never die. Vibrations are going to be something always present in the running system. But that will be coming after the second reality, which is unbalanced force. But for the timing, yes, vibrations are there in underdamped system, but they will be dying after some time. Like you are going for the normal door of your house, you are going to open it like this. It will be first of all coming back like this, after that coming back like this, after it coming back like this. In 2 to 3 cycles, it will be automatically stopped. Why? Air resistance is there. So that is the application of, that is the case of underdamped system. And in underdamped system, if we want to represent it graphically, you know, as harmonic function is there. If we have x is equals to r sine omega t, what is the way to plot? We are going to make an axis. We are going to make one line with plus r, one line with minus r. And we are running the sine between these two lines. So we are making amplitude 2 lines, then sine is running between these 2 lines. So here also we will be showing in the same way. Here also we will be showing in the same way. We are going to make it like this. We would be making the one line of amplitude like this. This is x e to the power minus zeta omega and t. Yes, the real is omega and t, not td, omega and t. So we are having this, and second line will be coming like this. This is minus x e to the power minus zeta omega and t. Now my dear, we will be running sine between these two curves. We would be running sine between these two curves like this. Why we are not starting sine with the 0? Because there is some initial phase difference. There is some initial phase difference. What is that? Phi. Is it clear for everyone? This type of graphical representation will be coming, and you can see in this curve, the first cycle is having this amplitude, second is having this amplitude x1, third is having this amplitude x2, fourth is having this amplitude x3, next is x4. So with every cycle, the amplitudes of vibrations are decreasing with time. And when they are decreasing with time, the next formula which is asked in the exam is the decremental ratio. So if the amplitudes are decreasing like this, they would be asking you the ratio of decrement. What is that? Decremental ratio is nothing but, they are asking you decremental ratio. Decremental ratio. What is that? They are asking you the ratio of amplitude of vibration in first cycle to the second cycle, or second cycle to the third cycle, or nth cycle to the n plus 1th cycle, like that. And when you will be finding out this x0 by x1, as we can go for the derivation, or xn minus 1 by xn, you would be getting it to be e to the power zeta omega n td. Here td is the time period of damped vibration. Time period. And you can write it as 2 pi by omega d, where omega d is omega n into 1 minus zeta square. I feel everybody understand this. Please tell me yes or no. Don't worry, at the last I will write all the formulas together which you need to remember. Here the formula is this only. Is it clear for everyone or not? Please tell me, guys. This is different chapter. This is not like natural vibration. In the classes, you may find this more interesting, but in marathon, you will find natural more interesting. Because in the marathon, I am going for complete detail of natural, but not complete detail of this. Okay? Because here only formulas are required. This is important for interviews. Natural is important for exam. So when we are going for the logarithmic decremental ratio, then my dear, it is defined as delta, and it is coming out to be nothing but 2 pi zeta by square root of 1 minus zeta. What is this logarithmic decremental ratio? Logarithmic decremental ratio is nothing but ln of x naught by x1 or x1 by x2 or xn minus 1 by xn. So if you are going for that ratio, that will be coming like this. Yes, very good. And you can also write it as the decremental ratio as x naught by xn minus 1 by xn as e to the power delta. Yes, it is correct. Because log will be going on to that side, will become exponential. So guys, now we have done these formulas in front of you. Okay, now we are coming to critical damping coefficient. Critical damping coefficient is defined as what? So when we are going to define the critical damping coefficient, you know that in critical damping zeta is equals to 1. So if you remember, we have written C by M as 2 zeta omega n. So if you are saying critical damping is there in the system, zeta will becomes 1. Here you can take the ratio of both. Mass will cancel out, 2 will cancel out, omega and omega n will cancel out. You will get zeta is nothing but equals to C by Cc. So whatever we are talking about zeta, actually zeta is nothing but the ratio of damping coefficient of your system to the critical damping coefficient. And when we are talking about this, can also be written as C by 2m omega n. And you know omega n can be written as root s by m. So from here you can write C by 2m s by m. From here you would be getting zeta is C by 2 root sm. But you know it is C by Cc. So from here we get the expression for Cc as 2 root sm. So guys, all the formulas of this system are being derived. Now I am going to write all the formulas on one slide, and then I am going to derive two cases which are special cases of damped vibration which can come in exam. They are wonderful cases. And once that will be over, we will enter into force damped vibration. Please tell me till this point everybody is okay or not? Are you getting or not? Because guys, don't worry about the derivation. I feel here you are interested more in the examination approach rather than the derivation. Okay? तो मजे से ज़्यादा इस बार अलग चीज़ों की ज़रूरत है. Let us see all the formulas at one glance. First formula will be, first formula is damped frequency, natural frequency 1 minus zeta ka square. Formula number 1. Formula number 2, zeta is C by Cc or C by 2m omega n. C by m omega n. C by 2m omega n, na? 2m omega n. Then we have C by 2 root sm. Third formula, xn minus 1 by xn e to the power delta. Sorry, e to the power first of all minus zeta omega n t. Sorry, e to the power zeta omega n td. Okay, this is the decremental ratio. And here fourth one is delta, logarithmic decremental ratio. It is 2 pi zeta 1 minus zeta का square. Please tell me everybody is clear about this. These are the 4 formulas we have seen. Fifth one, not very important, x is equals to x naught e to the power minus zeta omega nt sine omega dt minus phi. This is not very important, but still I am giving you. So damped vibration means these 5 formulas. If you remember these 5 formulas, you can do any question on damped vibration systems. Any question except 2 special cases. And those 2 special cases now we are going ahead. They are similar to the natural vibrations. That's why we need to do them. So these are the formula you need to remember. Here omega d is the damped frequency. Zeta is the damping factor. Okay, if one more thing you want to write is degree of dampness. This can also be asked. Degree of dampness. Degree of dampness is nothing but zeta ka square. So guys, with this we have completed the formulas of damped vibration system. Let me enter into the 2 special cases from where questions are coming. Okay, let me take some space. Keep. Let me take an extra slide to give you the special cases. Okay. Now my dear, I am going on to the wonderful case which can come in the exam. And if that case will be coming in the exam, very few students will be able to do. And it have already been asked also. Okay. What is that? Let us say we are having a rod. And that rod is attached with a torsional spring, which is having a stiffness of S theta at this point, which is also the point of hinge. Then we are having a spring here. Then we are also having a damper here. This is S, this is C. The distance from the hinges, B for this, A for this, and center is here, L by 2. Everybody please tell me, understood the figure or not? Is it clear or not? Please tell me that. Figure is clear to everybody or not? If they give this case, you can see damper is there, so it is a damped vibration system case for sure. And we want to find out the 2 things here. One thing is governing equation, let us say. Second thing is the equivalent damping coefficient. Third thing is the natural frequency of vibrations. So when we are having this, you know, this is the rod of mass m and length L. As damper is present, we cannot go for, energy method, and we cannot go for Rayleigh method. And also there is no point mass. So we have only one choice, D'Alembert method or torque method. So D'Alembert method or torque method are same. So I am going to consider this as axis. And let us say from that axis I am going to give you a rotation of theta. And when I will give the rotation of theta, this axis will reach here. This center part will be reaching here. As we are rotating it with theta, first of all, torsional spring will give a restoring torque S theta into theta. First thing. Then you can see the mg will be acting downward. This will be mg cos theta. This will be mg sin theta. So you can take a restoring torque mg into L by 2 sin theta. Then my dear, this damper is getting deviated up to this. What is that deviation of damper here? It is A into theta. So you can say this deflection is A into theta. So if x is A into theta, x dot will be A into theta dot. So you would be having the restoring force CA theta dot. Restoring torque will be multiplied by A, force into perpendicular distance, CA square theta dot. Similarly, this is going to be going like this, B into theta. So you would be having a restoring force of S into B into theta, and the restoring torque will be coming out to be SB square into theta. And my dear, what was given by Sir D. Lambert? Add my component, equate it to 0, I theta double dot. So you would be getting the equation as I theta double dot plus CA square theta dot plus SB square theta plus S theta into theta plus mg L by 2 into theta is equals to 0. Tell me everybody is clear or not? I will be taken about this axis, you know that. And I feel everybody remember in the natural vibration we calculated I about AA was ml square by 12 plus m into L by 2 ka square. So it was coming out to be ml square by 3. Everybody remember. Farinder, is it clear or not? So when we are getting this, the equation will be ml square by 3 theta double dot plus CA square theta dot plus S theta plus mg L by 2 plus SA square into theta is equals to 0. And when you are having this equation, if you are going to equate it with mx double dot, or let us say m theta double dot, I theta double dot plus C theta dot plus S theta is equals to 0. If you are equating it with this equation, you can say this is C equivalent, this is S equivalent. So C equivalent is, you can say CA square. The coefficient of theta dot is this, CA square. So no doubt the damping is having the damping coefficient of C, but because of its position, it is not acting like C, it is acting like CA square. So if somebody asks you the governing equation is ml square by 3 theta double dot plus CA square theta dot plus S theta plus mg L by 2 plus SA square into theta. This is the governing equation for this system. And if someone is asking you the equivalent damping coefficient, it is CA square. If somebody is asking you the natural frequency, you would be saying it as S theta plus mg L by 2 plus SA square divided by ml square by 3. So these are the three questions which can come from this system. Please tell me everybody is getting it or not. Please tell me everybody is getting it or not. Guys, please tell me, because it is very important for me whether you are getting the things properly or not. We have done this case and you can get this question directly. Arey bhai Vinay, you are saying correctly, it is SB square because CA square I have written. You are correct. Wonderful. Saurabh, bahut badhiya. Wonderful. Ashray. Yes, Sujit, Atharv, Dhanesh, Shreyas. You will get the PDF also of this on the Telegram channel Mechanical by Dheeraj Sardana. Okay. So guys, this is about the natural frequency of the system. Let us see the same case. Now, this case till now is not asked in gate. But similar to this case have already been there in the gate, which was with the horizontal case. What is that? There they have taken like this. It is hinged, there is a rod, the same rod. And in that you are having C like this. You are having the spring like this. And they said the distance is B here, the distance is A here. And my dear, with that they have also attached a torsional spring S theta. And they said this is the rod, mass m, length L. So my dear, only one difference will be there in this case and the previous case. This time when you will go for the static deflection, initially whatever, or you are going to give some deflection. Actually, when the rod is going like that, static deflection is already balanced by the spring force and the damper force. So as that is already balanced, mg component will not come in this case. Okay, you have seen whenever we are having vertical springs, mg component is balanced by the spring. In the previous case, we were having the horizontal spring, that's why it was not balanced. So when we have vertical spring, the mg component is balanced by the static deflection, and that's why mg will not come. Here if you are going to give angular deviation by theta, you would be having a restoring torque as theta into theta. You would be having a restoring torque C into B square into theta dot. You would be having a restoring as S into A square into theta. But there is no force from the mg side. And you will say I theta double dot. I will be about this axis only. So you would be writing once again IAA theta double dot plus CB square theta dot plus SA square plus S theta into theta is equals to 0. This is the governing equation. If someone is asking you the equivalent damping coefficient and natural frequency, tell me what is CE, omega, and I will tell you. Tell me what is equivalent damping coefficient. Tell me what is equivalent damping coefficient. Tell me what is equivalent damping coefficient. Let us check yours. Very good Vinay, very good Faninder. It will be CV square. Omega n would be coming this time is S theta plus SA square upon IAA. IAA will come out to be ML square by 3. Very good guys, with this we have completed the expressions for damped vibration system. Very good Dhanesh, very good Adarsh, Srujit, Abhi, Shreyas, Ashray, Faninder, Vinay, Atharv, Ancient Heavens, Hari, very good. So guys, now we are having some questions. Let us see, are you able to do these questions or not? I already told you formula based question. You can feel this equation as mx double dot cx dot plus sx. They are asking you find out damping factor C by 2 root Sm. Find out. This type of question you are going to see in the exam for sure. Solve this guys. Solve this guys. Solve this. Shreyas is saying 0.5, Shrujit is saying 0.5, everybody is getting 0.5. Okay, you know C is 9 by 2 root 27 into 3. Answer will be 0.5. Okay. Yes. This question now. I am not going for every question because for vibration we will also have a, like for tone 2 and vibration we will have a practice session soon. In a vibrating system, the stiffness is this, mass is 2 kg. So first of all, find out critical damping coefficient 2 root Sm, and then you see whether this is more than C, less than C. You need to find out ratio C by Cc. Then see whether this ratio is more than 1, less than 1, or equals to 1. You need to tell what type of system it is. Critically damped, over damped, under damped. Farinder is saying under damped. So you can see 2 is the mass, 32 is that. So when you will be going for this 2 into 32, 64 ka 8, 8 is 16. 16.5. It is under damped system. Very good. It is under damped system because C by Cc is coming 0.5. C is 8, Cc is 16. This question, find out the natural frequency of vibration. Find out the natural frequency of vibrations. We have already done wonderful cases. After that, some simple numericals of 1 mark. What would be the answer for this? This can also be felt like x double dot plus omega n square x is equals to 0. Very easy question. Arey bhai, it is 8 pi na? Why 4 pi? Okay, hertz. Sorry, D is correct. Fn is omega n by 2 pi. D is correct. Very good. D is correct, bhai. B is wrong, D is correct. Because they are asking in hertz. This will be coming in radians per second. D is correct. Very good. Very good, Shreyas. Here, can you tell me the critical damping coefficient? So here we can see all our gate or gate type of questions only. Some good level question you will see in the practice session. Okay. So be ready for that as well. Practice session is not today. We will see that in next 1-2 days. Either tomorrow or day after tomorrow, like that. You know, here S is 16. C is M. This is 4. So are we getting the answer to be 16? Critical damping coefficient? Yes. Very good. Okay, I feel we have done these. Find out logarithmic decremental ratio. Logarithmic decremental ratio. Delta. Solve this. Solve this question, guys. Solve this, guys. Solve this. They are saying this is mass, this is S, this is C. So you know that zeta is C by 2 root Sm. First find out zeta, put it here, you will get delta. This type of questions are coming in GATE many times when they are asking logarithmic decremental ratio. So this is not a new question, old question only. Solve it. Solve it, solve it, solve it. Yes, answer may not match here. .422 will be coming. D is the right answer. It is coming out to be 0.422. Very good, very good. 0.422 is correct. So guys, moving to the next question. this question, then we will enter into forced damped vibration systems. Forced damped vibration systems. Ha, that is correct, Ashray. The amplitude versus time curve is given and they are asking about this curve. This A is represented a logarithmic decremental curve, an exponential decreasing curve, a linear curve or hyperbolic curve. Is it linear curve, Farinder? अरे भाई, this is x e to the power minus zeta omega nt. So answer will be exponentially decreasing curve. Is it clear? And because of the ratio of log and exponential, the amplitude we have written logarithmic decremental ratio. Okay, so this was decremental ratio. We have found out logarithmic decremental ratio. Okay, the curve is negative exponential. B is the right answer. Is it clear? Fine. So guys, now we are entering into the last part of the vibration, and most probably next 1 hour we will be completing the vibrations, and after that we will be going into the lunch break. Okay, so are we ready for that? And after lunch break, just after that we will go for gear trains, gyroscope. Gear trains will not take much time, gyroscope will also not take much time. So for exam point of view, when we are going for gate, none of the chapter will be more time taking right now. Okay, whatever the time is required for vibrations only. So when we are talking about the force damped vibration system, we are going to have the second reality of the mechanical system, that is the unbalanced forces. So when we are talking about the unbalanced forces, we are having this: a spring, a damper, a mass and unbalanced force. So guys, this unbalanced force can come from two areas. One can be because of rotating components. Let us say we are having a rotor which is rotating with an angular speed of omega. And my dear, let us say you are having the center of mass acting at a point at E eccentricity from the center. Why this? Because my dear, you know that in this universe there is nothing like homogeneous and isotropic. Whenever we are going to make a component, there is no material which is completely homogeneous isotropic. So you would be having some eccentricity present. So because of which a outside force, centrifugal force me omega square will be acting. And my dear, this force is acting at this point. With the rotation, this point will also keep on moving like that. So this force will keep on changing the direction. And whenever a force is changing the direction, it is said to be a fatigue force. And fatigue forces produces vibrations. So that is why this force is creating vibrations. And whatever vibration it will be producing, they will remain in the system until this force is present. So until the rotor is rotating, this force will be there in the system. So that is why I said, when the unbalanced force will be coming into the picture, vibrations amar ho jayenge, vibration kabhi khatam nahi honge, and that is because when they are present in the system, they will keep the system vibrating. So this is vibrations coming because of rotating components. That's why when we go for balancing, we need to balance the rotating components. Then my dear, same we can see the reciprocating component also. Like if you have a cylinder, you have a piston, you have a connecting rod, you have a crank like this. Like this. So when my dear, you know this crank is going to rotate, you know this slider is going to reciprocate. This slider will be applying a inertia force onto the crankshaft, and that is going to be equals to mr omega square cos theta plus cos 2 theta by n. You can see here also harmonic component is coming. Here this force is acting. This is also varying in magnitude with time, because when the time will change, theta will change. Theta is the crank angle. So when time will change, theta will change, this force value will change. So when this force value will change, the magnitude of this is changing, and this is also becoming fatigue force, because if magnitude or direction or both for a force change with time, we call such forces as fatigue forces. So, and my dear, this is coming because of reciprocating components. This is coming because of reciprocating components. So if a force is coming because of rotating or reciprocating components, that is generally going to create the unbalanced forces onto the system. I already told you unbalanced forces are nothing but the forces which are coming because of change. Either magnitude will change or direction will change. Fatigue forces are the unbalanced forces. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. So guys, this is how we are going to study this. Now my dear, when we are having the unbalanced force, the governing equation will be slightly changing. Because this time you have this kx, this cx naught, this mx naught and f naught sine omega t. This is the unbalanced force. Because of that, the equation will be coming like this. X double dot, mx double dot plus cx dot plus sx is equals to f naught sine omega t. This is the equation for force damped vibration system. You can see in the damped vibration system equation was same, only right hand side term was not there. So this right hand side term is new in this system. So you can also write it as x double dot plus 2 zeta omega n x dot plus omega n ka square x f naught by m sine omega t. So my dear, this is the governing equation of force damped vibration system. Force damped vibration system. And for damped vibration system, we had the same equation. X double dot plus 2 zeta omega n x dot plus omega n square x is equals to 0. So you remember, when the right hand side is 0 in the differential equation, you know, here the solution is x is equals to complementary function. And when we are going for this equation, x is equals to complementary function plus particular integral. So my dear, as the left hand side of both the equation is same, so complementary function for both the equation is going to be same. But my dear, right hand side is non-zero here, so particular integral will be different here. But my dear, you know, we have seen the CF also. In the CF part, we have three cases. We can have three cases for CF. One is over-damped system, other is critically damped system, other is under-damped system. But you know, in over-damped and critical damped, vibrations were not there. So we will not be considering over-damped and critically damped, we will be considering the under-damped system. So for under-damped system, we have already found out what was the complementary function. And complementary function we have found out as equals to x e to the power minus zeta omega nt into sine omega dt minus phi. This was the CF we are going to use. So now when you will be going for calculation of particular integral, already the calculation have been shown here. So particular integral will be coming out to be this. It is going to be f naught by s into sine omega t minus psi divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. Here r is nothing but omega by omega n. So this is coming out to be particular integral. So my dear, when you will see the equation of particular integral, you know that CF is going to be 0 after some time. So I can write here, just look at it, at t is equals to 0, when time is 0, and it is going from 0 to t. The solution will be x e to the power minus zeta omega nt into sine omega dt minus phi plus particular integral is, it is f naught by s sine omega t minus psi divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. This is initially you would be having, but after time t, CF will become 0. So after time t, after t, CF will become 0. and our x value will become particular integral only, which is nothing but f naught by s into sine omega t minus psi divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. So my dear, if you can see this final equation after some time, you tell me by looking at that equation, vibrations will be there in the system or not? Vibrations will be there in the system or not? Because you know, by looking at the equation, we can tell whether vibrations are there in the system or not. So do like and share the session, guys. We are at the third type of vibrations, and within 40-50 minutes we will complete it. Yes, vibrations are there in the system, because when you will see this sine function चिल्ला चिल्ला के बोल रहा है कि vibrations है. Because of harmonic function present in the system, this sine curve is telling us that yes, vibrations are there in the system. But my dear, if someone will be asking, vibrations are there, but with what frequency? Natural frequency? No. Damped frequency? No. This time vibrations are there with this omega, which is said to be forced frequency. So my dear, omega is nothing but the forced frequency. We can also call it as excitation frequency. It is forced frequency or excitation frequency. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Is it clear for everyone or not? Please tell me that. Okay. So guys, when we are talking about force frequency, it was nothing but the same what we have shown here, the rotation of rotor omega. Here also it is rotation of crank omega. So my dear, it means this time vibrations are neither with the natural frequency nor with the damped frequency, but they are with the frequency of the system, which is either rotor's omega or crank's omega. And you know, until the crank will be rotating, vibrations will be present. Why? Because this time amplitude is not negative exponential. This time, if you will clearly see, this is the amplitude which is a constant. So this time amplitude is constant. That's why sometime we are also writing this. X is equals to A sine omega t minus psi, where A is this is the amplitude of vibration. The very first formula in front of you from which the questions are coming, this is said to be the amplitude of forced damped vibration system. So this is the very first formula from which the questions will be coming. You know, whenever I was teaching you for the paid courses, we have studied vibration in 15 hours, because every derivation we have done in the classes, but they are not required for gate point of view. That's why here we are not going for any derivation. We are directly writing the result. If you remember this result, you can very easily answer any question on amplitude of vibration. So here omega by omega n is also written as R. So we can write this expression as A is equals to F naught by S divided by square root of 1 minus R square ka square plus 2 zeta R ka whole square. This is the amplitude of vibration. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. So guys, next term we are going with is magnification factor. But before that, I would like to tell you how the graphical representation of this are. I would like to tell you how the graphical representation for this are. Let me show you the graphical representation. So when we are going to represent it graphically, here we have time, here we have x. You know, up to some time we have CF plus PI. After that we have PI. You know, PI have constant amplitude. So PI have constant amplitude like this. But when we are reaching to this time t, CF are negative exponential and they are added to PI. So PI are always having this amplitude. But when CF are added to them, the amplitude will become like this. So when you will be making the sine curve between them, this would be coming like this. So after this, we call it as steady state vibration. And they are said to be unsteady state vibrations. Clear for everyone or not? Yes, Sujit, Aritro, Ashray, Shreyas, Rahul, Faninder, Atharv, Abhi, Ancient, Rahul. This is the expressions, or you can say graphical representation. Okay. Arey bhai Hari, here we have CF plus PI. You know CF was negative exponential like this. This is added to PI because PI is always there. So when you have made for damped vibration, you were making like this, na? So this one is added to this one. It will result into this one. Clear now? And they are not exact, they are approximate, because you know in both the curves angle was different. One was sine phi, other was sine psi. So this is approximation, not exact. Okay. So this is how the graphically we can represent. I feel everybody understood. Yes, Hari, you understood or not? Now we will move to the next term, that is nothing but magnification factor. Now we are going to move ahead to the next term, that is magnification factor. So my dear, here there is a clear comparison between two things. Like if we have a spring, a damper, a mass, unbalanced force. So when we are having this forced damped vibration system, for that equation is coming out to be x is equals to a sine omega t minus phi, or psi you can write. Omega t minus psi. This is the equation for the vibration system. And if we are going to have the same force, Fn is F naught sine omega t. If you are going to apply the F naught force here, so from here, for here you will get the deflection as F naught by S, static deflection. And here if you see, the maximum deflection is A. So here delta of force damped vibration system will be coming out to be A, and delta is coming out to be F naught by S here. So when we are going to take the ratio of delta force damped vibration system to the static deflection, it is coming out to be A by delta naught. You know what is A? We have calculated A was F naught by S divided by square root of 1 minus R square ka square plus 2 zeta R ka whole square, and divided by we have F naught by S. F naught by S will get cancelled out. So it would be coming out to be 1 by square root of 1 minus R square ka square plus 2 zeta R ka whole square. This is the expression for magnification factor. So my dear, magnification factor results we have done. Here omega by omega n is R. This is the magnification factor, and at least 7 to 8 times they have asked the question from that. So guys, in damped vibration system and forced damped vibration system, if you know the formula, you can do the question very easily. Here they will be giving you the value of omega, omega n, zeta, okay, or some functions from which you can find out. You need to find out magnification factor. So we have done two formulas till now. One is amplitude of vibration, other is magnification factor. But here nowadays they are also asking the question from the graph. So when we are going to make the graph for magnification factor, you would be getting some this type of graph is coming. I am making it for you, don't worry. So graph whenever we are making, we can see magnification factor is a function of r and zeta. So that is why we would be having magnification factor on y-axis, r on the x-axis, and we are making it for all zeta. So when we are making it, there is a line which is made for r is equals to 1. There is a line which is telling us magnification factor is 1. So you know, for such functions we don't learn how to make the graphs. So we just need to understand this and verify this. So the first curve will be coming for zeta 0, that is coming like this. This is for zeta is equals to 0. Because when the zeta will be 0, you know that zeta will be 0. Zeta 0 means this term is 0. This term is 0, so when r will become 1, 1 minus 1 is 0, 1 by 0 is infinity. Okay, so that is why when you see this r1, zeta 0, we are getting infinity. After that, for other curves, when you will increase the zeta, as zeta is in denominator, increase in zeta will decrease the magnification factor. Curve will be coming like this. So this may be the curve for zeta as 0.3. Then we can have one more zeta increase. Maybe for zeta is equals to 0.6. One more zeta increase. Maybe for zeta is equals to 0.9. Maybe for zeta is more than equals to 1. You can see zeta is in denominator. So when this term will increase, magnification factor will decrease. Is it clear for everyone? So this is what we are going to get. Now the questions will be framed on this. How the questions will be framed on this. That is the important fact. So when we will be going for the questions on this, the very first type of question will be coming, that when we are increasing the zeta, what will happen to the magnification factor or amplitude? So when zeta is increased, you can see the curve is coming lower. So when zeta is increased, magnification factor will decrease, amplitude of vibration will decrease, life will increase. Sometimes they will be twisting the question by asking what will happen if underdamping is increasing. Like when you go to the doctor say your body have deficiency of calcium. And if you come after 7 days and doctor says deficiency of calcium have been reduced, then you will not become happy. Yes, I got calcium. No, deficiency increase means calcium is reducing. Okay, so when we are saying underdamping increases, when you will see this word underdamping increases, underdamping is the deficiency of damping. So underdamping increases means, underdamping means zeta less than 1, increasing means zeta reducing. Zeta reduce, magnification factor increase, amplitude increase, life reduce. So this type of question can also be there. They can also ask you that we are getting the maximum value of magnification factor when. You can see all these maximum are coming just before r is equals to 1. So you would be getting magnification factor is becoming maximum when r is less than 1. Only equals to 1 condition is valid when zeta is 0. Otherwise you can see before r is equals to 1 all are becoming maximum. Only one curve is becoming at r is equals to 1. Clear for everyone? Please tell me that. This was the curve for magnification factor. We have completed this and moving to the next topic, that is phasor diagram. Phase or phasor diagram. Okay. Now before we go to the vibration isolation, we need to understand the phase diagram or phasor. Phase diagram or phasor. Let me take some extra slides for that. So we are moving guys to phase diagram. Oh sir, please tell deflection of magnification factor. Definition. Okay, dear, magnification factor is telling that how bad the force damped vibration system is with respect to a simple spring. Because when we have a simple spring, you have seen the deflection is what? F naught by S. So how more amplitude will be coming, how much bigger amplitude will be coming if we are having unbalanced forces in the system. So it is nothing but the ratio of amplitude of force damped vibration system to the static deflection when the same value of maximum force is applied. Is it clear? That is the definition. Now my dear, we are going for the phase diagram or phasor. Phase diagram or phasor. This is important. Phase diagram or phasor is important. After that we will see vibration isolation, transmissibility ratio and critical speed of shaft. That will complete this chapter. So after this we will have the lunch break, and after lunch break we will see gyroscope, we will see gear trains. Okay, those are more important. Then we will go for cam governor, okay, and balancing. Okay, phase diagram. So when we are talking about phase diagram, this is not about the thermodynamics phase diagram or not from the material science phase diagram. This is the phase diagram which is telling us about the various forces. Like you have said that x is equals to a sine omega t minus psi. This is the equation we derived in the force and vibration system. So from here can we say x dot plus a omega cos omega t minus psi. You can also write it as a omega sine 90 plus omega t minus phi. We can write differentiation once again x double dot minus a omega square sine omega t minus psi. Actually I want to write every force in the form of sine. If you remember, the equation was mx double dot plus cx dot plus sx is f naught sine omega t. We can also write it as f naught sine omega t minus mx double dot minus cx dot minus sx is equals to 0. So if you are writing this equation, you would say f naught sine omega t minus mx double dot minus m, what is x double dot? This minus a omega square sine omega t minus psi. Then you have next term as minus cx dot minus c. What is x dot? X dot is a omega sine 90 plus omega t minus phi. Then my dear, we have the next term as minus sx. What is x? X is a sine omega t minus phi equals to 0. Psi. So guys, now actually what this is? It is the combination of four forces. The resultant is 0. One force is unbalanced force. This is the inertia force. This is the damping force. This is the spring force. So if we want to write all these forces together, they are together becoming 0, but they are not in the single phase. One force is omega t, other is omega t minus phi, because all four are harmonic forces. Harmonic means their magnitude direction will be varying. Like if you have the f naught sine omega t, f naught sine omega t will be like this, na? So when I am talking about like f naught is maximum, then other forces are not maximum, because other forces are having some phase difference. And that is why whenever we want to show all the forces by showing them what is the phase difference between them, means one force is lagging or leading the other force by how much angle, that will tell you the phase diagram. So my dear, we are going to consider this phase diagram. They are plotted in this way. I am showing on x, y. When we are showing some force, the very first force is F naught sine omega t. The way of representing any forces, I will make the magnitude. I will make the magnitude in such a way that it is making anti-clockwise angle phi. Sorry, anti-clockwise angle omega t with the x-axis. So F naught is making an angle of omega t from the x-axis. So I have made angle anti-clockwise with the x-axis. So if I want to show this m a omega square sine omega t minus phi, you know this minus minus will become plus. So next force is m a omega square sine omega t minus phi. So I would be saying if it is omega t minus psi, so next force will be coming somewhere here, where the angle between two is nothing but psi, because this is omega t minus psi. And this force is having the magnitude of m a omega square. Please tell me, everybody understood this or not? Everybody understood this or not? Please tell me that. So if you want to see the angle between these two forces, this is psi. And my dear, if you see the next force, it is Ca omega sine 90 plus. So 90 plus means I will be going 90 degree in the anti-clockwise direction. So this should be the direction of Ca omega. But because of this minus sign, it will come just opposite. So Ca omega is going to be at an angle of 90 degree with the inertia force. Similarly, when you will see this Sa omega t minus phi, this is coming in this direction only. But as minus sign is there, so it would be coming just opposite. This is Sa. You can see Sa and C omega A are 90 degree to each other. So the outcome of this is nothing but the angle between damping force and spring force is 90 degree. The angle between inertia force and spring force is 180 degree. The angle between inertia force and damping force is also 90 degree. Please tell me, everybody understood this or not? And this wonderful diagram, we call it as phase diagram. And as I said, bodies are, as I said, the entire system is in equilibrium. At that case, if you will make the force polygon by all these four forces, net force will be coming out to be 0. So this is said to be the phase diagram. How the question can come? First of all, you understand what we got. The first point, C omega A and Sa. This is damping force, this is spring force. They are at an angle of 90 degree to each other. Second, Sa and Ma omega square, they are at 180 degree to each other. If you know these 2 points, they can ask you a question. They will say that I am giving you a diagram where this is force F naught in such a way that this angle is psi. And they will say I am making two forces, one is C, other is D. And you need to identify which force is C, which force is D. And your options are Ma omega square and Sa. Options are Sa and C omega A. Options are C omega A and Sa. Options are C omega A and Ma omega square. You need to tell which one is correct. Give the answer to me for this question. Beautiful question. Solve this, guys. Solve this. Solve this, solve this, solve this, guys. Okay. some are saying C, some are saying B, some are saying A. Okay, that's what I was thinking. Ki you guys would not be able to give directly right answer. Okay, you know we have angle between F naught and MA omega square is psi. So this will be F naught first of all. Sorry, this will be MA omega square. And you know that MA omega square and SA are at an angle of 180 degrees. So this is SA. And SA and C omega A are at an angle of 90 degrees. So the answer is C is C omega A. Answer is C. Is it clear for everyone? Yes, ancient, Rahul, Atharv. Answer is C, na? Answer is C. Because MA omega square and SA are at an angle of 180 degree. You can see this. Clear? This is about the phase diagram or phasor. Okay, very good. So guys, this is about phase diagram or phasor. Now we would be entering into the next topic, that is very good Hari. Now we are going for the next topic, that is vibration isolation. So my dear, I would like to give you the introduction for that. What is vibration isolation? So let us say we are going to have one machine like this, other machine like this, other machine like this. We have three machines. Let us say M1, M2 and M3. So my dear, let us say you are having a condition. You are going to open a machine shop where you are putting the three machines, and you are going to say that there are some components in these machines which are having some fatigue life. First of all, why we have fatigue life? We have already seen in the force damped vibration system, amplitude is constant. Frequency is force frequency. So I can give you a statement that vibrations in a running system can never be zero. Vibrations in a running system are always present, and if vibrations are present, fatigue loading is there. Fatigue loading is reducing. Fatigue loading is going to have some rated life. You have seen the life defined for endurance limit. So guys, you have studied in the machine design SN curve. So from that SN curve, we can define the life of a component for a particular loading. Let us say, you know, for this loading, this is the life of the component, and that component needs to be replaced. That component needs to be replaced. Okay, Atharv. So that component needs to be replaced. That component needs to be replaced before they fracture, before the accident happens. So let us say we have that component in all the three machines, and the life of that component is given as, let us say, 50,000 cycles. So 50,000 cycles is the life defined for that. And let us say you are going for an operator, and operator is working there, and let us say the operator is working on this M1 for some 40,000 revolution. You said, okay, its life is still remaining. You are saying operator to operate on second machine. He operated there for 35,000 revolutions. Then he was working on the third machine. Third machine also have completed its 25,000 revolution. And you were saying कि अभी तो बहुत life पड़ी है. And you were saying the worker was working here, and after some time you will find the blast happened and there was no worker. Worker was getting converted into parts, body parts. When you say that kind of accident happened, you will say how it can happen. You will be doing case over the manufacturing company, and you will find that you are in the jail because of that. The reason is because, my dear, whenever you are having these vibrations, yes, these 50,000 are the cycles which the component in M1 will be leaving for sure, for M2 also, for M3 also. But the problem is when the vibrations are happening, vibrations from M1 are getting transferred to the earth. From earth they are getting transferred to M2 and M3. No doubt they will be transferring to less amount, but they will transfer. So whenever this M1 was having the motion 40,000 cycles, at that 40,000 maybe these two machines were at rest, but they were still feeling the vibrations. When this machine will be running, it will transmit vibration here which will go to this and this machine. So we are not happy with that. Now it is like you are having a good friend group, 7 persons are there. Out of them everybody is smoker, you are not smoking. And they are always saying, okay, tu piyo mat, chal to pad saath. You are going with them, they are smoking like that and you are just standing with them. You are not smoking actively, but you are taking that passively. So the person who is smoking, he knows smoking causes cancer. But the person who is not smoking, he don't know about that, na? So if the person who is smoking, if he get that disease, it's fine. Because he know from this it can happen. But a person who is not who is not smoking, he should not be affected by that. So when this machine is running, I am happy with that ki its life is utilized. But why its life is utilizing at that time? Why its life is utilizing at that time? So because of that reason, we are always going to provide sometimes, not sometimes, all the times, we will provide the isolations. And that's why when you will be having these machines, you will see the generators which are kept permanently in the coaching institutes. You will never find them, they are put it on the earth. They will always be put it on some of the foundation. Yes, in the marriages when the generator is coming with less frequency, there they may not put the vibration isolation. But generally whenever you will see heavy machines, you will always find the vibration isolations. So if this is the machine, we are going to provide some isolation or foundation. So this is isolation. So now my dear, when this machine is running, it is going to transfer the vibration here. Then isolation will also transfer the vibration to the earth. Let us say F0 is the force coming from machine, Ft is the transferred force. Then you will find the isolation effectiveness is transmissibility ratio, that is given as Ft by F0. We want the ideal value to be 0. We want there should not be any transfer of force. But that is not possible all the times. So in that case, we would always want the transmissibility ratio should be less than equals to 1. It is desirable. Then only there is a benefit. If transmissibility ratio is coming out to be more than 1, उखाड़ के फेंक दो ऐसी vibration isolation को. It is useless. Because it is like कि without isolation the component will fail in 2 years. With isolation it is getting failed in 1 year. It is like a patient is there in the ICU or let us say in the hospital, he have sugar. You are going to take sweets for him and forcefully you are making them eat that sweets. They will die soon, na? Then they will say, why you are coming to see him? Okay, don't come. So guys, if that is the case, when we are talking about the vibration isolation, what is the best material for isolation? I would like to say, my dear, rubber is said to be the best material for vibration isolation. You can see whenever you have the ceiling fans, when you will open in the clamps, you will find rubber. Whenever you are using the calculator, where is the calculator? This is a calculator. Here you are applying the forces like that, producing vibrations. When you will open the buttons, below that you will find rubber. In the laptop also you will find rubber. Then you may be thinking, sir, but when we see the foundation of big generators and all, there we don't find rubber. So my dear, the reason for that is, there also rubber is there, but rubber is added in the powder form. So they add rubber powder plus cement plus concrete. The reason is rubber is having less strength. So when less strength is there, rubber can be cut by the weight of the machine. So because of that reason, you will find always either they would be having cement plus concrete or rubber powder, and where we are not using this, we would be using the second best material, that is cast iron. Very good, Sujit. Like you have seen, if I talk about the application of jigs and fixtures, there you are using grey cast iron material. Why? because rubber material is not having the strength. So where we cannot use the rubber, we go for grey cast iron. Like the wheels of the car also having rubber wheels. Have you seen that? Why? Good isolation. But in the trains we cannot use rubber, rubber will get cut. So we are using cast iron wheels or steel wheels. Okay. Good afternoon, Abhishek. So this is how we are going with. Okay. So isolations are looking like this. Here this is spring, this is damper. So obviously when we are talking about the isolation, thank you Abhishek, but this is from the side of BYJU'S only. So when we are talking about the vibration isolation, it is also having some kind of stiffness and some kind of damping coefficient. Okay. So my dear, when we are going to find out the vibration isolation, you can see in the heavy machines, these are the isolations. Example of isolations. You can see these, this is isolation, this is isolation, this is isolation. Okay. So my dear, when we are going to find out the transmissibility ratio for vibration isolation, which is coming as the ratio of Ft by F naught. Whenever you derive the formula for that, it will be coming out to be 1 plus 2 zeta r ka whole square divided by square root of 1 minus r square ka square plus 2 zeta r ka whole square. So my dear, this is the third formula which we are going to see. So if you remember, first formula for amplitude of vibration, second formula for magnification factor, third formula for transmissibility ratio. Every year one question is coming from these formulas. One formula is still left, that is critical speed of shaft. So is it clear for everyone? Please tell me that. Yes. Sujit, Abhi, Danesh, Aritro, Atharv. Please tell me, everybody is clear? Everybody is clear? Yes, we are moving towards break, don't worry. This is transmissibility ratio formula, and if you are going to see the graph of this, once again, like magnification factor, when you will be plotting the graph of this time some differences you will find. This time, let us say you are having this R is equals to 1, R is equals to root 2. Transmissibility ratio is equals to 1. This is transmissibility ratio R for all zeta. When you will make the curve, zeta 0 will give you this. Zeta 0. So here when you will increase the zeta, the curve will be coming like this, but there is a change. Here it will come above this curve. Zeta is 0.3. You can see this when you will be plotting the curves. When you will further increase zeta, the trend will continue like this. When you will further increase the zeta, you will be getting this. When you will further increase zeta, this time also the curve will be coming like this. प्रियांशु, काफी हो गया है, वाइब्रेशन इज अबाउट टू कंप्लीट. और अगर आप पहली बार आए हो इस सेशन में, तो मैं आपको बता दूं कि ये तो लास्ट के मैराथन चल रहे हैं. ऑलरेडी सोम हो गया है ऑलरेडी. हाँ भाई, जय श्री राम. ठीक है, जा रहे हो क्या अयोध्या 22 को? यस. सो गाइस, दिस इज द कर्व. यू कैन सी when we are talking about this curve, you already have seen that transmissibility ratio should always be lesser than or equals to 1. It should not be more than 1. So we never operate in this region. If we are having this region, vibration isolation is not required. Like whenever you are having your ceiling fan, it may be running with the omega less than root 2 times of omega n. So in that case, vibration isolation is not required, because without isolation life will be better. So vibration isolation would be required after this, because after that you are getting the transmissibility ratio to be less than 1. And when it is coming less than 1, then only it is beneficial to use the vibration isolation. Is it clear? It is not like that, Rahulji. Critical damping and no damping is not equal. So when we are talking about this, so operating range is R should be more than √2. Always remember that. And here if you see, before this we are not using isolation. After this only we will use isolation. And after this you can see, if you are having more zeta, we are having more transmissibility ratio. So in the operating range, zeta should be lesser only. So you know, whenever we were studying magnification factor, there more zeta was beneficial. And here less zeta is beneficial. So we need to make a compromise, because neither we want magnification more, nor we want transmissibility factor more. So we need to go for a compromise. So my dear, because here you can see, if zeta is lesser, then transmissibility ratio will be lesser. If you want to see the transmissibility ratio, I would like to say there are 3 cases you can have. One is when R is √2, when R is less than √2, when R is more than √2. So when R is less than √2, zeta more, transmissibility ratio less. When R is equals to √2, for all zeta values, transmissibility ratio will be 1. You can see every curve is passing from these 2 points. And when we are going to have R is equals to more than √2, then you will be having, as zeta is increasing, transmissibility ratio is increasing. So here we call zeta becomes detrimental. So zeta should be smaller here, because we never want transmissibility ratio to be more. Clear for everyone? Please tell me that. This is about the transmissibility ratio. Now my dear, whenever we are talking about the last part, that is critical speed of shaft, first of all solve this question. Consider the following statement of transmissibility of vibration is more than 1 if this, less than 1 if this. Tell me. Try to solve this. After this we are just having one formula left, critical speed of shaft. After that we will have the break. So I already told you, before break we will complete vibrations. After vibrations we are meeting for gear trains, gyroscopes, cams, governor, balancing. बताइए. If you can see, transmissibility is more than 1 when R is less than √2. Yes, it is correct. It is less than 1. This is not correct. Okay. So you can say 1 only. Is it clear? Is it clear? Farinder, you got it. D is the right answer. Very good. Okay. Fine. Now let us move to the, this we have already done, I feel. Solve this question. They have given you the mass 250 kg spring, but they are saying stiffness unbalanced F0, speed is 3600, omega will be 2 pi n by 60. Assume a damping factor zeta 0.15. Find out transmissibility ratio. Okay, omega n will be S by M and R will be omega by omega n. Solve this question. Only calculations are required. So here questions are directly formula based. There is nothing more than that. Solve this question, guys. Solve this question, guys. Tell me, guys. Solve this. I know calculations are there, but calculations would be there, na? Very good. Yes, Ashray, Rahul, Aritro. Fine, guys. कर लेंगे कि नहीं? I don't remember the answer for this. Just you need to put the values. Zeta is directly given. You can find out omega from here. Vaibhav is saying answer is A. Yes, anybody else? किसी और ने किया है? Previous year's question ही है ये भी. Farinder is saying C. Everybody is giving different answer. I also feel answer should be C. Rest, let us wait for others. Or let me check. Yes, C is correct. Ha, Abdul, my number is so guys, the answer will be C for this. Okay, very good. So guys, moving further to the last part. Last part is critical speed of shaft. If I teach you critical speed of shaft with the complete physics which I do in the classes, it will take 1 hour at least, because there are wonderful explanations related to that. But they are important for interviews. For gate it is not. For gate we have simple formula for critical speed of shaft, and that is coming out to be y is equals to E by omega n by omega ka square minus 1. We have this as the formula when we are having a power plant shaft, and on this power plant shaft we have a rotor. So because of that rotor, it is eccentric with E, center of mass, one force is acting mb omega square. So because of that, when you will be finding out y is that deflection for which the body will come in equilibrium. So this is omega n by omega ka square minus 1, and here omega is equals to omega n is referred as critical speed of shaft. So critical speed of shaft is that speed at which denominator will become 0, y will become infinity, and when y will become infinity, shaft will be breaking into parts. So that is why we call it as critical speed, because it is the depth of shaft. And my dear, this is given as square root of s by m. So it depends on stiffness, it depends on mass, and this is how we can go for. And guys, I feel with this we have completed the vibrations. But as I told you that there is a wonderful physics behind all this that we are not going into, because that is important for interviews. Because you have the application of this in the power plant, we have the application of this in your laptop computer. So there are many applications of that. So I gave wonderful examples there, but they are not required here for gate. Okay, they are required for interviews. So guys, with this we have completed vibration. Now we are going for a lunch break, and after lunch break I will be starting with the gear trains, gyroscope, then cam, then governor, and last will be the balancing. Okay, so this is how we are going to move with. So we are having the break here. I feel everybody is okay with that. If anybody have any doubt, you can ask me. Okay, if anybody is having any doubt, you can ask me. So let me make a empty slide. With the next topic. So we would be starting. Class will resume. First of all, tell me till now whatever we have discussed, you enjoyed it or not? Yes. Class will resume at 2:40. So after the lunch break, the sequence of the topics would be like this: gear train, gyroscope, cam, governor, balancing. Okay, so we are having the lunch break. I feel everybody is happy with whatever we have discussed. Yes, very good guys. So many of the students are aware of the applications. Is it clear? Yes. Hydraulic machine nahi hua hai Ashray. Okay, I will talk to the sir. Okay, if it is not done, we will do some arrangement for that. Okay, so shall we go for the break now? Everybody is okay with this? मिले फिर 2:40 पर. 40 मिनट break is enough, and I want everyone to be back after the break. Okay, अगर आप चाहते हो मैराथन लाइव चले तो आपको भी लाइव आना है. अगर आप रिकॉर्डिंग देखोगे तो हम भी रिकॉर्डिंग चला देंगे. रिकॉर्डिंग्स आर अवेलेबल फॉर द लास्ट ईयर, वी नो दैट. Okay, so we will meet at 2:40 after the break. Be ready for that. Yes, guys. Am I properly audible and visible to all of you guys? Yes, Aritro, I have taken. So guys, do once again like and share the session so that other student can also get to know that marathon is restarting again. Okay, guys. So now we are going to enter into the next topic, that is nothing but the gear trains. Okay, that is nothing but the gear trains. So guys, if you remember, in the previous class only the gears was completed. In the previous Tom part 1 marathon we have completed the gears. So right now we are going to enter into the gear train. Okay. So when we are talking about when more than two gears are connected together, we are calling it as a kind of gear train. So when we are talking about gear trains, first of all we need to understand what is the need for gear train. So when we are talking about need, the very first need is to cover the center distance. First need is to cover the center distance. Like if we are going to have a center distance between two gears, like this is 1, this is 2, then we are going to have one choice is we will be making one very big gear, another very big gear, like that. So sometime we are having the restriction on the radial space. Sometime we are having restriction on the radial space. So when you are having restriction on radial place, you cannot use that big gears. So for such cases we would be going for some small gears like this. Like this. Okay. So like you are going to connect the 4 gears, this is a gear train. So you can see, to cover the large center distances with less radial space, we are going for the gear trains. So this was the very first need or requirement of the gear train. Then my dear, second requirement of gear train is nothing but the high speed ratios. Second is high speed ratios. So when we are talking about high speed ratios, then my dear, when we are understanding a set of gear, you have seen omega 1 by omega 2 was coming out to be R2 by R1. So my dear, if you want to have a speed ratio of 10, you need to have the radius ratio also 10. What do you mean by that? Means if one gear is this, another gear will be 10 times bigger. So if another gear will be 10 times bigger, the teeth of the smaller gear will be getting bent, and smaller gear is going to fail because of that. Okay. So whenever we have this condition, we are going to say this as we cannot use it for more than 10:1. If you want a speed ratio of more than 10:1, for that we cannot go with the gears. We are going with the gear trains. Third thing is nothing but the desired direction of rotation. Desired direction of rotation. What do you mean by desired direction of rotation? If you are having a set of gear, it is compulsory that for clockwise it will also rotate anti-clockwise. So for clockwise you will be getting output as anti-clockwise. But my dear, if you want clockwise to clockwise, that you can get in the gear train by adjusting the intermediate number of gears. And also the fourth thing is if you require multiple speed ratios. So when we are talking about multiple speed ratio, that can be given only by special type of gear trains which are said to be epicyclic and planetary gear trains. Okay, so one by one we will see all of them. So the point is, these are the 4 major requirements for which we are looking for the gear trains. And when we are looking for the gear trains, we are going to have two ratios. One is said to be speed ratio, other is said to be train value. Speed ratio is defined as the angular, like you are saying, angular speed of driver to the angular speed of driven. So when we are defining speed ratio, it can be written as n of driver but a n of driven. And when we are talking about the train value, it is 1 by speed ratio. So it will be n of driven by n of driver. These are the terms which I will be continuously using in the gear trains. That's why I told you these. Okay. Yes. So guys, now after going into the speed ratio and train value, we are going for the types of gear train. The very first gear train is simple gear train. The second is compound gear train. Third is reverted gear train. And in these three gear trains, we would be having only three parts. One is driver gear, other is driven gear, and third we would be having the intermediate gears. Okay. And when we are talking about the planetary or epicyclic gear train, here other than these three, we would be having an additional element that is said to be arm or spider. So guys, these are the various parts of the gear train. Now one by one we are going to enter into the gear trains. First we will enter into simple gear train. So my dear, a gear train is said to be simple if every shaft is having only one gear. Here you can see this shaft is having one gear, this shaft is having one gear, this shaft is having one gear, this shaft is having one gear. So when every shaft is having one gear, that kind of gear train is said to be simple gear train. And I would like to tell you that we have already seen omega 1 by omega 2 can be written as R2 by R1. We can also write it as D2 by D1. Okay, that is one thing we already are aware of. When we are talking about the second thing, that is module, and module of the mating gear is going to be equal. So we can also write D1 by Z1 is equals to D2 by Z2. So from here we can also write D1 by D2 can be written as Z1 by Z2. So we can write from here that omega 1 by omega 2 is equals to nothing but D1 by D2 is Z1 by Z2, D2 by D1 will be Z2 by Z1. So this is going to be always equal. Is it clear for everyone? So guys, if we have this, we are saying this to be gear 1, gear 2, gear 3 and gear 4. So when we are going to have gear 1 and 2 are the mating gear. For mating gears, both these conditions are correct. That's why we can apply this. So we can write omega 1 by omega 2 is equals to Z2 by Z1. Similarly, when we will be going for the gear 2, 3, we can write omega 2 by omega 3 is equals to Z3 by Z2. Similarly, we can write for gear 3 and 4. We can write it as omega 3 by omega 4 is Z4 by Z3. If we see these equations, all these three equations are for the set of gear, but we are studying the gear train. So if you want to write the speed ratio of gear train, you can multiply all the three equations. When you will multiply all the three equations, omega 1 by omega 2 into omega 2 by omega 3 into omega 3 by omega 4. You know that omega 1 by omega 2 into omega 2 by omega 3 into omega 3 by omega 4. And that will be coming out to be Z2 by Z1, Z3 by Z2 and Z4 by Z3. You can see, my dear, here omega 3, 2 will get cancelled out. Z2, Z3 will get cancelled out. So you can say omega 1 by omega 4 is coming out to be Z4 by Z1. If you see this ratio, you will get to know that in the speed ratio there is no contribution of gear 2 and gear 3. There is no contribution of gear 2 and gear 3. No contribution. And if there is no contribution of gear 2 and gear 3, we can say such intermediate gears, those who do not give any contribution to the speed ratio, such intermediate gears are said to be idlers. We are calling them idlers or idle gears, like Vinay is saying. Very good, Vinay. So we are calling them either idlers or idle gears. Idle gears or idler are the gear which do not give any contribution to the speed ratio. So my dear, when we have this, what do you mean by that? If you are only having 1 and 4th gear, then also you would be getting the same speed ratio. If you are having only 1 and 4th gear, then also the same speed ratio will come. So 2nd and 3rd have only helped in covering the center distance. And also when this is going to rotate clockwise, this will be anti-clockwise. This is anti-clockwise, this is clockwise, this is clockwise, this is going to be anti-clockwise. So you can see, my dear, when I was using even number of intermediate gear, for clockwise here, I am getting anti-clockwise here. If I would be using a odd number of intermediate gears, then I would be getting clockwise to clockwise. So if you want the same speed sense of rotation of input and output gears, you would be using odd number of intermediate gears. If you are using even number of intermediate gears, you will find driver and driven will be moving in opposite direction. Okay, so that is how we are going to have the directions. Clear for everyone? Clear for everyone? This is about the simple gear train. Now my dear, we are having the compound gear train. When we are talking about the compound gear train, if in the entire gear train you find any shaft where more than one gear are present, like here there are such two shafts, I am saying even if we have only one such shaft where more than one gear are there, we will be calling such gear train as a compound gear train. So this is a compound gear train. And when we are going to find out the speed ratio for this, what you will get? Omega 1 by omega 6. The same procedure which I have done in the previous case. Have you seen that procedure? The same procedure when I will apply for compound gear train. I will be getting here T2, sorry, I am showing the number of teeth with Z. So Z2, Z4, Z6 by Z1, Z3, Z5. Many students are remembering it like even number by odd number. Never remember like this. Because in the gate when examiner is giving the question, he says this is link number 1. And if says this is link number 1, this will become gear number 2. And this will become gear number 3. This will become gear number 4. This will become 5. This will become 6. This will become 7. In that case, the same speed ratio will be coming like that. You would be having here Z3, Z5, Z7 and here Z2, Z4, Z6. So I want to say never remember like odd and even, but remember it like driven by driver. You can write it as, you can see this as the product of number of teeth on the driven gear by driver gear. Because if you see here 1 is rotating because you have given input there, but 2 is rotating because 1 is driving the second. So second is driven, 1 is driver. When you see 2 and 3, 3 is rotating because the shaft consisting of 2 and 3 is rotating. So 3 will become driver, 4 will become driven, 5 will become driver, 6 will become driven. So always remember like driven by driver. So I would be saying the speed ratio as this is product of number of teeth on driven by product of number of teeth on driver. So guys, if you see what is the identification of intermediate gear, this time gear number 2, 3, 4, 5 are intermediate but not idler because they are contributing to the speed ratio. You can see. So as they are contributing to the speed ratio, they are not idler, they are intermediate gear but they are not idler. So for idler, they should not contribute in the speed ratio. But what is the identification? How? By looking the figure I can say whether this intermediate gear will act like idler or not. So guys, I would like to say that only that intermediate gear which is present alone on the shaft can act like idler. Like here you can see both the shaft are having two intermediate gears. If any of them would be having one intermediate gear, that one intermediate will be acting like idler. Like if I give you one more example for this. If I have this one gear, this another gear, then this and this. In this case, these are intermediate gears. Out of these intermediate gears, if I say this is 1, this is 2, this is 3, this is 4, this is 5. So I can say yes, 4 would be acting like idler. And you will not get in the formula about number of teeth of 4. Like here, if you are writing omega 1 by omega 5, what you will write? You will write 1 is driving second, second is driven. Third is driving fourth, fourth is driven. And fourth is driving fifth, fifth is driven. First is driver, third is driver, fourth is also driving fifth. So here fourth is acting like both driver and driven will get cancelled out. You will get Z2, Z5 by Z1, Z3. This is about the compound gear train. Everybody understood this or not? Yes, Vinay, Faninder, Lemon, Aritro, Abhi, Rahul, everybody, please tell me, is it clear or not? Aniket, very good. So guys, this is about the gear trains. Then when we have the reverted gear train, there is a speciality of reverted gear train. When we are talking about reverted gear train, they are joining the coaxial shaft. Like if we are having this shaft number 1 and this, you can see both shafts are coaxial. If you have this as a driver, this as driven. For coaxial shaft, you can join them with the flange coupling also. But when we are going to join the flange coupling, it cannot give the different speed. Very good, Malesh. It will give the same speed of rotation. So if you want to give different speed, you need to use the gear train. So for that, what we are going to do, we are having 2 more gears, gear number 2 and gear number 3, and they are going to be connected with one shaft. So as on one shaft you have 2 gears, so these 2 will act like not idler, they are intermediate only. And as on one shaft we have 2 gear, reverted gear train is a type of compound gear train only. So here what is going to happen? 1 will transfer the power to 2, 2 will transfer the power to 3, 3 will transfer the power to 4. So likewise the power transfer will happen. But here there is one thing, that whenever we will be solving it, as it is a compound gear train, so we can write omega 1 by omega 4 as, 1 is driving the 2, 2 is driven. Third is driving the fourth, fourth is driven. And 1 and 3 are acting like driver. So this will be the speed ratio for reverted gear train. But when we are going to have the speed ratio of reverted gear train like that, here they are playing with you, they are not giving all the number of teeths. They are giving you only 3 number of teeths. And they are expecting you to calculate the 4th one. So for that, you can see the center distance between these 2 axes. Center distance between these 2 axes and center distance between these 2 axes is equal. So you can say radius of 1 plus radius of 2 is equals to radius of 3 plus radius of 4. And everybody knows that module is diameter by number of teeth. So module is 2r by z, and from here we can say r is mz by 2. So radius is mz by 2. So we can also go like that, ki m1 z1 by 2 plus m2 z2 by 2 is equals to m3 z3 by 2, m4 z4 by 2. 2, 2, 2, 2 will get cancelled out. Very good, Nisha. So if you see, gear 1 and gear 2 are mating gear, their module will be same. 3 and 4 are mating, their module will be same. So you can also assume that m1 is equals to m2 is equals to m, and m3 is equals to m4 is equals to m dash. So you can also write here that m into z1 plus z2, m dash z3 plus z4. You will see some relation is given between m and m dash. Generally I have seen the questions. Nisha, this is class going on for mechanical engineering, those who are going to appear for GATE examination. Okay, so this is the design subjects going on for GATE. Okay, so when we are having this m z1 plus z2, m dash z3 plus z4, generally they are giving m and m dash are equal. If they give it like that, they will get cancelled out with each other and you will get the equation as Z1 plus Z2 is equal to Z3 by Z3 plus Z4. So with this equation you can find out the unknown. Okay? With this you can find out the unknown number of teeth, and after finding out that, by applying this formula you can find out the speed ratio. Okay? So guys, after the end of this session I will also tell you about heat transfer. Okay? Now I am not teaching heat transfer to you. I will tell you about the marathon of heat transfer. So you can see this is the figure for reverted gear train. This is let us say you want to transmit the power from here to here. 1, 2, 3, 4. Like that. Okay. So guys, this is how the reverted gear train will look like. So, okay. Okay, this is the question of center distance. In the last class I told you how to find out the center distance between two gears. The module of gear 1 is 5 mm. Meshing with gear 2, 20 teeth, find the distance between centers of the mating gears. So you are given two gears. You need to find out the center distance between them. Number of teeth are given to you. You can see it is going to be the sum of two radius. X you need to find out. Module is equal for both the gears. You can also write it like this. That will be your answer. Solve this question. Lemon, Danesh, Aritro, Adarsh, Malesh, Ashray. Solve this question. After this we are entering into the most important epicyclic gear trains. Yes, Aritro, it was there. Every time questions are coming from here. So you would be writing X to be, module is 5 by 2. $75 is the answer. Very good, Farinder. Wonderful, dear. Moving further, guys. This is the PYQ of gate. You need to find out this distance, X. You can see this is radius of P, radius of Q, radius of R and radius of S. So here X is nothing but radius of P plus radius of Q plus radius of R plus radius of S. You can also write directly module, but module is different for different gears. Here for P and Q module will be same, for R and S module will be same. So you can write M by 2 ZB plus ZQ plus M dash by 2 ZR plus ZS. Okay. Try to solve this question. This is the PYQ of gate. Once you will be able to solve this question, then we will enter into epicyclic gear train and planetary gear train, and we will be completing this chapter, and then we will enter to gyroscopes. Okay, in gyroscope also we will not go for derivations. We will go directly for the results and directions. Solve it, guys. Yes. So guys, I would like to tell you that we are having a civil versus mechanical war on the app where 3 students will win up to 2100 rupees. In this 4:30 PM on app, every day a quiz will be there. Okay, and in that quiz, me and Abhinav sir would be taking alternate days session. Like one day I will be there, the next day Abhinav sir would be there, and this is going to start tomorrow 4:30 PM. It will be starting from tomorrow 4:30 p.m. Be ready. Tomorrow will be the introductory day where we will be telling you all the rules and all, and you can earn while you learn. Okay, every day one chapter. Timing will be 4:30 p.m. on the app from 21st to 30th of January. Nisha, I feel you are not from mechanical in that case. If you are from mechanical, then this is the core topic of mechanical engineering. So when we are talking about the compound gear train PQRS, they have given the number of teeth like this, and they have also given you the module of R is 2 mm. So M dash is 2 mm, we know that. M dash is 2 mm. You also know that M we need to find out. M can be written as diameter of Q by number of teeth of Q. Okay, and you know that what is M dash? M dash is diameter of R upon number of teeth of R, and it is given as 2 mm. And you know that when we are saying that dr by zr, this is M dash is 2 mm, and we are also knowing that ki diameter of R from here we can find out as 2 into zr. What is the number of teeth of R? 15. So we will be getting 30 mm as the diameter of gear R. So if you know that it is given that diameter of Q is twice that of R. So we can write it dq is nothing but 2 times of 30. It is 60. What is the number of teeth in Q? It is 40. Module will be 3 by 2. So we get the value of M. Now you just need to put the value and get the answer. Okay. Then Nisha, this session is not for you. Okay. You are 4 years behind this session. Okay. So what would be the answer, guys? You know the value of M. You know the value of M dash. Just put it here. Get the answer. Put it here. Get the answer. Shreyas, 120 is wrong. 120 is wrong. Check it again. Check it again. Very good, Ashray. 80 is correct. 80 is correct. Very good, Ashray. 80 is correct. Shreyas, very good. 80 is the right answer. 80 is the right answer. Okay, 80 is the right answer. 80 is the right answer. Very good, Aniket, Faninder. You just need to put the values here. You have M in front of you. You have M dash in front of you. Put it here. Put the number of teeths are given. You will get the answer. Very good, Aritro. Answer is B for this. Moving further, planetary gear train. So for planetary gear train, I would be making my own figure because this figure is not correct. Okay. So let me take another slide for that. So when we are talking about the epicyclic gear train, this is one gear, another gear. If I make just these two gears, this is the set of gear, you know that. So when we say epicyclic, here epi means arm or axis. Cyclic means rotation. Epi means arm or axis, cyclic means rotation. So when, my dear, you have a rotating element arm, or if you have axis of one gear to be rotating about the other, like if you are talking about these two centers are connected with this arm, and this is like this. Now this axis is fixed, but this axis is not fixed. So you can say this axis would be rotating about this gear. Like that. And when you are going to find out the degree of freedom for this, this is link number 1, link number 2, link number 3, link number 4. This is higher pair. This is ternary joint, because here 3 links are connected, 1, 2 and 3. This is ternary, this is binary. So when you will be going for degree of freedom, it is coming out to be 3 into L minus 1 minus 2 into J. Joints are 1 ternary and 1 binary, so 3 minus 1 higher pair. 9 minus 6 minus 1 coming out to be 2. Whenever we are getting degree of freedom 2, it means we can control 2 inputs to get the desired output. So we can control 2 input. We have to control 2 input to get the desired output. So that is why when you will see the question on epicyclic gear train, out of 3 things, one is gear B, other is gear C, and other is arm OA. These are 3 things. Out of these 3 things, you would be having 2 inputs and 1 output. So as you are having 2 inputs, so you can give sometime input different, other time input different, and you can get more than 1 possible output. So here you can get the multiple speed ratios. Multiple speed ratio. This is the major advantage of this. And multiple speed ratios are possible because you are having 2 inputs and 1 output. So you can take any 2 as input and any 1 as output. So with that you can get multiple speed ratio possible. So how to solve this type of question when it is coming? So for epicyclic gear train, we are going to have a tabular method where this kind of table is formed. In this table, we are taking the first step. We are fixing the arm and giving 1 rotation to gear A clockwise. Okay, let us consider it in different way. Let us say this is gear B. Sorry, here it is B only, na? It is C. Okay, C. Keep it C only. So let us say we have fixed the arm, and whenever we say plus for clockwise, negative for anti-clockwise. So he is saying we are giving plus 1 revolution to gear C. When we are giving plus 1 revolution to gear C, we are having gear C, we are having gear B. So my dear, we are giving plus 1 revolution to gear C. So you know arm is at rest, so the speed of arm will be 0. And gear C is given plus 1 rotation. And as you can see, both the gears are like external gear. If I am keeping arm fixed, it is the set of gear. So we can definitely write NB by NC is equals to minus of ZC by ZB. So from here we can find out NB as minus ZC by ZB into NA. So this is NC. As you are giving plus 1 revolution to C, the answer will be minus ZC by ZB. So here I will write minus ZC by ZB. When you are going to give 0 revolution to arm and X revolution to gear C, then you would be getting minus X ZC by ZB. You know my dear, either arm is not there, but if arm is there, it is the heart of the mechanism. Because whenever you are going to have arm, if arm is given any rotation, automatically that revolution will be added to the rotation of B. Why? Because this axis is not fixed. So this gear is also rotating about this gear. So if this is one gear, other gear is also rotating about this like that. So if you are going to give rotation to arm, automatically those would be added to both the gears. So whenever arm is present, arm rotation are directly added to all the gears. Okay, so that is why when you are going to have, let us say arm is given the rotation, then rotation of arm will be given to all the gears. And when you are going to see the total, the rotation of arm is plus y, rotation of gear C is x plus y, rotation of this is y minus zc by zb. So you can see we get the final row like that. So in the question, out of these 3, they will give you 2, they will ask you third. They will say you that, let us say gear C is fixed. Let us say gear B is rotating with 100 RPM. Find out the speed of arm. So out of these 3, you need to remember the last row. Out of these 3, they will be giving you 2, they will be asking you 1. This type of questions are coming in the epicyclic gear train. Okay, if you want to see some question I have for you. Let us see the question on epicyclic gear train. This is the question. This is the question. This is gear A, gear B and arm C. Let us change. This OA is arm, this is gear C and this is gear B. Let us say like that. They are saying in the epicyclic gear train shown in the figure, A is fixed. Okay, this gear C is given fixed. If you have seen, we were getting the speed of C as x plus y when the arm was rotating. So they have given this to be at rest, so speed will be 0. They are saying that A has 100 teeth, B has 20 teeth and arm is making 3 revolutions. So they have given you an arm which you were treating it as y, it is plus 3. As they have not mentioned direction, we will assume it to be clockwise. Then they are saying find out the rotation made by B. You need to find out the speed of B, which was nothing but y minus x ZC by ZB. Can you solve it? I have given you the last row of the table in front of you. Can you solve it? I have given you the last row of the table. Last row of the table is in front of you. This is a very good revision for those who have studied this. Okay? Y minus x ZC by ZB. Yes, Falinder. Lemon is saying the answer to be C. Very good. Yes, Arithro. Vinay, Abhi, Aniket. Okay, Aniket is saying the answer to be C. Abhi is saying C. Very good. Okay, now Abhi is saying B. Okay, let me tell you how to solve it. You are given that, okay, Farinder is saying B. You are given that this gear is fixed. So x plus y is 0. When x plus y is 0, you can write x is equals to minus y. It is minus 3. So when you will be putting the value for NB here, y is 3. X is minus 3. ZC is 100. ZB is 20. So it is going to be 5 and you would be getting 18. Answer will be B. Very good Faninder, very good Shreyas, very good Aniket, Vinay, बहुत बढ़िया. Ashray, you understood or not? Lemon, you understood or not? Abhi already have said B. Is it clear? Everybody understood how to do this type of questions? Everybody understood how to do this type of questions? Everybody understood how to do this type of questions? Faninder, actually, when we are talking about the concept is, it is actually like if the arm is fixed. If the arm is fixed, then you know this is a set of gear. And for set of gear, if this is going to rotate like that, this will be going to rotate like that. And you can write the ratio like NB by NC is ZC by ZB. Why we are keeping minus sign here? Because whenever it is rotating clockwise or it is anti-clockwise, it will be clockwise. So as the direction of both is reverse, so that's why we are putting negative. For external gearing, we always have minus sign. For internal gearing, we have plus sign. Is it clear? And then, my dear, when we are talking about this, we can find out NB from here very easily. We found out that. And then we have put it the value here, and this is going to be minus ZC by ZB. Now, whenever you are going to talk about the last row, in last row, till now we were having the arm to be fixed. Now we are going to rotate the arm by y revolutions per minute. Now just imagine if you are standing on a train. You are standing on a train like that. That train is very long, you know that. If train is stationary, you will move like that from first coach to last coach. If you are entering in the first coach, you are exiting at last coach, definitely you have traveled some distance. That is the case when train is stationary. But if train is also moving, then the motion of train is added to all the coaches. So because of that, now when you will come out, you will be having two motion. One is the motion of train, one is the motion of yours. So when the arm is moving, this arm is rotating the axis of the gear. And when it is rotating, obviously, previously also these gears were like this, na? Like this gear was rotating like this or rotating like this. So when the arm will be giving some rotation, that will also be added to this gear. And both the gears are moving teeth by teeth like that. So whatever motion will be going to this gear, the same will be going to this, because both the gears are going to travel like that. It is not like a gear is just like sliding like that. Gear is moving like that between teeth to teeth. So that is why whatever rotation Y will be getting, arm will be getting, that will be given to all the gears. Because gears are mating with each other. Clear, Faninder? So always remember, arm rotations are added to every gear. Very good, Aritro. That's fine. So now, my dear, we are going for the planetary gear trains. So first of all, when we are talking about the planetary gear trains, after that I will also tell you the algebraic method. After that I will also tell you the algebraic method. I will also tell you the algebraic method. So now, my dear, whenever we are talking about the planetary gear train, in reality, in the planetary gear train, we are having one annular or ring gear. We are having one annular or ring gear. Annular or ring gear. Okay. Then we are having a sun gear. So like in the sun planet system, we are having planet revolving around the sun. So we are having some planet gears. Like here is a planet, here is a planet, here is a planet. So my dear, these planets are added or attached with the help of a arm. So you can see we are having these three arms connecting the center with the planet gears. So you can say this is planet P1, this is planet P2, this is planet P3. First of all, you know that the center of sun and ring gear is same. So all the planets are of the same size. All the planets are of the same size. And if all the planets are of the same size, they will give you the same speed ratio for sure. So then you may be thinking, sir, one more thing is there. Can they give different speed ratio because of arm? Yes. If their arms will be rotating at different speeds, then they can give you different speed ratio also. But if they will be moving with different speeds, don't you feel these gears will be getting collide with each other? Like if this arm is moving fastly, this is moving slowly. After some time, these two gears will collide with each other. That I never want. That's why these three arms are never provided actually. Actually, these three arms are provided in this format. They are going to be a single element known as spider. In such a way that angle between these two arms, angle between these two arms, angle between these two arms is always going to be fixed. There are two advantages of this. One, they will never collide. Second, because of the centrifugal force, as they are rotating, centrifugal forces will get balanced. So for better balancing of centrifugal forces, we are providing three planetary gears like that. So these three forces will balance each other. You have studied the Lami's theorem. Okay, so when they will be balancing very easily, obviously now all the three planets will give you same speed ratio. Why 3 we are providing? For the balancing purpose. And second is, here we can distribute the load equally into all the three planets. So that is the other advantage. But in reality, as all the planets are giving the same results, for analysis purpose, I will make only single planet, like here I have made. And now if I am going to analyze that, once again here I would be doing the operation. Here I would be writing the speed of arm. Here I would be writing the speed of sun gear. Here I would be writing the speed of planet gear. Here I would be writing the speed of ring gear. Tabular method. After that I will also tell you the algebraic method. So when, my dear, we are going with that, initially, you know, first arm is at rest and sun gear is given the +1 RPM. +1 means clockwise. So we have an arm as 0. Danish, just refresh. I don't feel there is a blur screen because my screen is very much clearly visible. I feel maybe some data problem you may have. All other students, please tell me, is it blur? Is it blur? Please tell me. I don't feel it is blur from my side. Yes, tell me. It is clear. Dhanesh, just check your internet connection. It generally becomes blur whenever our internet connection is getting poorer. Very good, Archana. Okay, fine. Lemon. So when we are having arm is to be at rest, sun is given +1 rotation. So you know that sun and planet are the mating gears and they are external gears. So we can write NS by NP is equals to minus of ZP by ZS. And we can also write NP as equals to minus ZS by ZP into NS. So if NS is 1, you know NP will be minus ZS by ZP. So I would write here minus ZS by ZP. Now what about the ring gear? Ring is connected with the planet in internal gearing. In internal gearing, if it is rotating clockwise, it will also rotate clockwise. So minus sign will not come. So we can also write the next equation to be N of planet by N of ring will be equals to Z of ring by Z of planet. We can also write the N of ring as equals to Z of planet by Z of ring into N of planet. What is N of planet? Minus Z of sun by Z of planet into speed of sun. You know that ZP will get cancelled out. Planet is acting like idler. So here we would be having Z of sun by Z of ring into NS. When NS is 1, it is minus ZS by ZR. So we can write it minus ZS by ZR. Is it clear for everyone? This is happening because planet is acting like idler, because it is an intermediate gear present alone at one shaft. Is it clear for everyone, guys? Please tell me that. Clear for everyone? Please tell me that. So guys, now we would be having the second case. If arm is still at rest and sun gear is rotating with +x, +4 clockwise. Here it is 0, here it is +x, then minus x times of ZS by ZP, minus x times of ZS by ZR. Then, my dear, we are going to have the third thing. If arm is given the rotation of y RPM clockwise, you know arm rotation will be added to all the gears. Either arm is not present, but if it is present, it is acting like the heart. Okay, so you would be saying plus y, plus y, plus y, plus y. The final speed of all the elements, for arm it is plus y, for sun it is x plus y, for planet it is y minus x zs by zp. Here it is y minus x zs by zr. So I feel everybody understood. The last row you need to remember. Questions will be coming. You need to put this last row all the time. Is it clear? Are we ready for 2-3 questions on this? Because this is very important for GATE. Now let us solve 2-3 questions on this. Okay, gear train is very important topic, I am telling you. After going for 2-3 questions, we will enter into the next chapter. Sorry, next chapter, the next method. That is algebraic method. Then with algebraic method, we will see the concept of fixing torque. And then completion of this chapter will happen. I will also teach you line diagram here. And after that, we will enter into the next topic. That would be gyroscopes. Question is in front of you. Solve this. They have given ring gear fix. You know the speed of ring is y minus zs by zr into x. Okay, they have given sun gear x plus y 100 rpm clockwise. You have two equations. You need to find out the arm rotation. Two equation, two unknowns x and y. Solve it and get the answer. Solve it and get the answer, guys. Solve it and get the answer, guys. Solve it and get the answer, guys. Solve it, guys. Solve it, solve it, solve it. When you would be going for this, y is coming out to be Zs by Zr into x. Sun is having 20, ring is having 80, x is 4y, x plus y is 100. अरे भाई, what is easier than that यार? Farinder, answer is galat. Answer is wrong for you. 20 RPM will be the answer. Yes, tell me, everybody understood what I have done? Everybody understood what I have done? Please tell me that. Very good Vinay, very good श्रेयस, वेरी गुड अभी, आश्रय, बहुत ही बढ़िया. यस यस यस, वेरी गुड. सो गाइस, आई फील एवरीबडी अंडरस्टूड. द आंसर इज 20 RPM. नाउ वी आर गोइंग फॉर द algebraic method. Algebraic method. Let us see the algebraic method. Algebraic method. Okay, so when we are talking about the algebraic method, in algebraic method we are going to use the concept of relative velocity. If we have these two gears which are connected like this, okay, so my dear, when we are going to say this is OA, gear B and gear C, gear B and gear C. So if arm is fixed, yes, Farinder, you understood the concept? What mistake you have done? Have you seen? So when we are having the arm to be fixed, we can definitely write NB by NC to be minus of ZC by ZB. Okay, minus of ZC by ZB. So when we are having this NB by NC is minus ZC by ZB, we can also write it as, like arm is fixed now, so we can write N of arm by NC minus N of arm minus ZC by ZB. So this is okay until the arm is fixed. You know, when arm is rotating, the arm rotation are added to all the gears. So don't you feel the NB will becomes NB plus N arm, NC will become NC plus N arm. So even when arm is rotating and you are going to calculate the value of this, let us say this speed is becoming, this is NB plus NA is NB dash, this is NC dash. So if you are going to apply the same formula to the new speed, NB dash, NC dash, if you are going to apply this formula, NB dash is nothing but NB plus NA, NC dash is nothing but NC plus NA. So NA will get cancelled out, you would be getting this ratio once again coming out to be NB by NA. Sorry, NB by NC, which is equals to minus ZC by ZB. It means always this ratio is equal. It means whether the arm is rotating or not, always we can write NB minus N arm by NC minus N arm is equals to ZC by ZB minus for external gearing, and this is valid only when these two gears are connected with the arm. Clear for everyone? Clear for everyone? अरे भाई थक गए क्या? है थक गए तो हम फिर गायरोस्कोप के बाद खत्म करेंगे in that way. Okay, is it clear for everyone? Clear for everyone? This is how we can write this, and we can use this algebraic method very nicely. I will show you in one of the question. Okay, if you see this algebraic method, and we are going to apply this algebraic method here. Once again, here. You can also write it here like this is, let us say now we are going with the given names. There is no problem. When we are going for algebraic method, we are going to have, let us say this is OA arm, this is B, this is C. So we can write for this NB minus N arm, NC minus N arm is equals to ZC by ZB minus for external gearing. So you know that here this is, you need to find out the revolution of B, that is unknown to us. Arm rotation is 3 RPM. Gear number C is given to rotate 0 minus arm is 3 RPM minus number of teeth on C 100, number of teeth on B 20. So you can see when you will be finding out NB will be coming out to be 18. So the same question can be done by algebraic method also very easily. So choice is yours which method you want to use. Is it clear for everyone? Is it clear for everyone? Is it clear for everyone? Clear for everyone? Very good guys, very good guys. बहुत ही बढ़िया, wonderful. So guys, now we are going to have one more question on total gear train. After that we will enter into line diagram and then we will complete this chapter. So in next 15 minutes gear train will be over. Okay, then we will start the next chapter, gyroscope. Okay. So guys, after gyroscope I will tell you about HMT and metal cutting, how we are planning them. If the annular wheel of epicyclic gear train has 100 teeth, so this is nothing but the ring gear, and the planet wheel, this is ZP. The number of teeth on sun you need to find out. Whenever you have this type of question, just consider it. This is a new type of question. You know that you need to find out the number of teeth on the sun. For that you need to apply the radius of sun plus diameter of planet is the radius of ring. You need to apply the radius of ring, radius of sun plus radius 2 times of planet. So radius of ring can be written as module times number of teeth on ring by 2. You know module of all the gear will be same because all are mating gears. So module of sun into ZS by 2 plus 2 times module of pinion ZP by 2. This will give you the number of teeth on sun. Okay, this will give you the number of teeth on sun. Solve it and get the answer guys. Very good. Sorry. Solve it guys. Okay, everybody is getting 60. Everybody is getting 60. So this type of question can also be asked. Okay. The same thing we have done in reverted gear train as well. Now my dear, I am showing you the line diagrams. whenever you get this type of figure given, how to read this. So I would like to tell you, whenever you are given a gear like this is considered as an external gear. This is considered like an external gear. Okay? Whenever a gear is given like this, even I would say full external gear. Like this is full internal gear. So if they are showing it like this is half internal gear. Internal gear. This is nothing but the ring gear actually. Everybody is getting the notation? Everybody is getting the notation? Everybody is getting the notation? If you are having this is half external gear. And if you are having this is arm. So you can feel this is an external gear like this. This is half external gear like this. With this arm is connected. This is external gear like this. This is internal gear like this. Can you feel it? Can you feel it? Can you feel it? Bolo bhai. Can you feel it? Everybody. So whenever you are having this, what this is representing, this part, external gear, this is a gear like that. Okay? Understood? So it is very difficult to make such diagrams in 3 dimension. That's why we are showing this with the line diagrams. So you can be given this type of diagram sometimes. Okay? Like if we see one question is there in gate like this. You can see this is the axis of one gear, this is the axis of one gear. And they are fixed. Gear 1 is connected with gear 2 and gear 2 and 3 are on the same shaft like this you can say. And this is carrier. Carrier is the name of arm. Okay, the same figure I am showing you here. If you see this, by looking at the option, we can say that algebraic method would be used here. Just by looking at the options. So my dear, you know that gear 1 and gear 2, about these two gears, I can write the relation like omega 1 minus omega arm by omega 2 minus omega arm. If arm is present in the system between any two external mating gear, I can write it as Z2 by Z1. This is one equation. Then 3 and 4 are also mating gear. So we can write for 3 and 4 also. Omega 3 minus omega arm. Faninder, are you getting or not? If any doubt, you can ask me, everybody. Z4 by Z3. These are two equations I have written. If I multiply both of them, I can write omega 1 minus omega arm by omega 2 minus omega arm multiply by omega 3 minus omega arm by omega 4 minus omega arm. You know that omega 2 and omega 3 would be equal because both the gears are on the same shaft. So omega 2 minus omega arm, omega 3 minus omega arm will get cancelled out, and left hand side you would be getting omega 1 minus omega arm by omega 4 minus omega arm. For right hand side now, you have minus Z2 by Z1. Z2 is 45, minus 45 by 15. Second is Z4 by Z3. Z4 is 40, Z3 is 20. You would be getting it to be 6. So you are getting omega 1 minus omega arm is the fifth link. So answer, I feel you would be getting A as the right answer. Very good, Faninder. Everybody, Ashray. Is it clear? Aritro, Vinay, Abhi, Shreyas, Lemon. Clear for everyone? Answer will be A for this. Answer will be A for this. Okay, let us do the last concept to complete it. Okay, in this gear, can you tell me which one is idler? In this gear train, can you tell me? Okay, note this one. In this one, can you tell me which one is idler? In this, can you tell me which one is idler? Can you tell me which one is idler? Fifth one. Fifth one is acting like idler. Answer will be C for this. Okay, guys. Now the last concept we are going to discuss is this one. Fixing torque. If we are having one gear, another gear, you know this is fixed axis, and here we have the arm like this. This is, let us say, gear B, this is, let us say, gear C, this is arm OA. And you know this axis will be rotating like this because it is epicyclic gear train. If you see this, as this is complete a system, nothing is coming from outside nor is going outside. This is the entire system. As there is no external power is coming, no internal power is going, so it is going to be inside. So I can say the summation torque to be 0. Here I would like to say, let us say, torque of input, torque of arm plus torque of output is equals to 0. This is the first equation. And as nothing is going outside, the summation of total power is also going to be 0. Input and output power. So we can write torque input omega input plus torque of arm omega arm plus torque of output omega output. Now my dear, you know that out of these three elements, whenever we are studying epicyclic or planetary gear train, you are going to say one gear is fixed or arm is fixed. Any one thing is going to be fixed. So if any one thing is going to be fixed, for that speed will be 0. Let us say this output is going to be 0. So this part will become 0 and you would be getting the equation Ti omega I plus Ta omega A. You are fixing the gear number C. Let us say here I represent gear number B, O represent gear number C, or arm is nothing but OA. Let us say that. So you are assuming omega output. This is not output actually, just imagine omega C. If omega C is 0, you would be taking input on gear B, arm will be giving you output. That is in your hand, where you put input, where you put output. Or if you have any confusion, just give me one more minute. I am correcting it. I am correcting it. Just give me 1 minute. खाने के बाद मेरे को भी नींद से आने लग गई है, मुझे लग रहा है. Okay, let us concentrate. So we have three torque. One is torque of B, torque of C, torque of arm. 0. Equation number 1. Now you know torque of B, omega of B. One will be input, other will be output. Plus torque of C, omega of C. Plus torque of A and omega of A is equals to 0. Why summation power is 0? Because you have assumed this as a system. Nothing is going outside, nothing is coming inside. So when we are writing this, you know that out of these three, one you are going to keep it fixed. You may fix gear B, you may fix gear C, you may fix arm, choice is yours. So any one thing, let us say gear C is fixed. So omega C will be 0. So you would be getting the relation TB omega B plus TA omega A to be 0. This would be the equation. And here you would be getting the relation between TB and TA first of all. And once you will have that relation, you know that as you have kept the C, so torque of C will become the fixing torque. So you would be writing the second equation as TB plus T fix plus TA as equals to 0. And guys, from here you can very easily find out the fixing torque value. That's why sometime when they are asking the concept of fixing torque, you need to use these two equations. So from here you can make the relation between TB and TA. That relation you will be putting here, and one torque will be given to you. From that you can find out the fixing torque. They will give you one power or one torque will be given to you, and they will be asking you the fixing torque. So out of these three, one will be given, one will be asking. The relation between third one you can make from here, because speed will also be known to you. Is it clear for everyone? In the practice session, I will be taking one question on that, don't worry. It can be asked in the gate examination. It can come to the gate examination. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Yes, everybody. Yes, very good, Ashtray. Everybody got it? So we have completed the gear trains, guys. Now we will be entering into gyroscope. If you want to understand the gyroscope, yes. So guys, I feel you are aware of this thing. When you are going to put this rotating about one axis, you can see it is not going down because of gyroscopic couple. You have also seen gyroscopic effect like that. You must have seen the videos available on that topic. Even I have taken one day Sunday ka funda on this, and you know many people have made this video about the gyroscopic couple. So when we are going to start this gyroscopic couple, you know initially you were giving rotation. Initially you were giving rotation to something about this axis. Okay, and if it is rotating about this axis, now if the axis of rotation itself is rotating like he is doing, then you will be getting a couple will be coming in the third plane, because of which that is going to rotate, and that is said to be gyroscopic effect. You can see we were having a rotation in this way. Once again you see the video, I will be giving you the observation what I want to say. Rotating about this, then changing the axis of rotation, and because of that one third couple is coming into picture. That is said to be the gyroscopic effect or gyroscopic couple. So my dear, we are going to see this mathematically also, don't worry. So just I am telling you, let us say you were rotating it in this way and it was rotating. This is the axis of spin. Then the axis of spin was twisted and it was going to be in this direction. So this axis was given a move in this way, and when you are going to give this, then in the third direction one rotation is produced. That is the gyroscopic effect. Is it clear? So you can say you were already having rotation about one axis. Then this axis of rotation is given the rotation like that about this z axis. And when it is going like that, a third rotation was coming about the y axis like this. That is the gyroscopic effect. Can you feel it? Something was rotating like this. This is the axis of spin, and that person have done it like this. So he have given the rotation to the axis of spin. So the body was rotating like this. He have given like this. So because of that, a third rotation came into picture. That is said to be gyroscopic effect. Is it clear? So now we would be having the clear picture of gyroscopic effect when we are starting with the very basic thing in the gyroscope. That is said to be, first of all, the 3D space coordinate system. 3D space coordinate system. 3D space coordinate system for gyroscope. For gyroscope, when we are making the 3D space coordinate system, we are having this direction as x, we are having this direction as z, and we are having this direction as y. You know that whenever we are making these axes, they are always going to follow right hand thumb rule. This is x, this is y, inside is positive, and you are going to have z is acting like this. This is the 3D coordinate system for gyroscope. When we are talking about gyroscope, this is the 3D coordinate system of gyroscope. You can see if you are having your fingers in x direction, you rotate your fingers in y direction, then the thumb will be giving you the z direction. So this is how the three-dimensional system of gyroscope can be defined: x, y, z. Is it clear? So you can feel one thing, that in the y inside is positive, y outside will be negative. So we are taking this coordinate system like this. Yes, Faninder, is it clear to you? Ashray, is it clear to you? Aritro, Dhanesh, Shreyas, everybody is clear? Aniket, this is going to be the three-dimensional coordinate system for gyroscope? No. Inside y is positive, outside y is negative. Okay, that's why I have shown you opposite. This is going to be the coordinate system for gyroscope. So if we are going to use this coordinate system for gyroscope, first of all, the first thing we are going to define is said to be the axis of spin. What is axis of spin? We will see now. Let us say we are having this as x-axis, this as z-axis, this as y-axis. We are having a rotor like this, and this rotor is rotating. This rotor is rotating in clockwise direction. But whenever we are going to say clockwise, if I will be looking from here, something is rotating clockwise like that. The same thing from here, I will say it is anti-clockwise. So that is why here view is very, very important. So my dear, if I am saying view is this, from this view, if I am saying clockwise, then I am looking from here, clockwise means this. I would be rotating the fingers in the sense of rotation, right hand, and the thumb will be giving you the direction of omega. So I can say the direction of omega is this. I am always telling you that whenever we are going to write the direction, it does not mean that when this is rotating like this, this will start moving in this direction. No. This is just a direction defined to avoid the confusion of view, whether I am watching from here or I am watching from here. Because if I am saying this is clockwise from here it will become anti-clockwise. So if it is anti-clockwise from here, I would be rotating the fingers here, direction will remain the same. Even you change the view, direction will not change. If I am looking anything clockwise from here, I will say this is the direction. The same thing from here will be anti-clockwise, na? So same thing here will be anti-clockwise. Once again the direction is same. So the point is, with the view, sense of rotation changes, direction does not. With the view, sense of rotation changes, direction does not. So when with the view, sense of rotation is changing, direction does not. So it is better to use direction, so that even if the view will change, we will not be having any confusion. And this view, whenever we are showing, this direction when we are showing, this is also said to be the axis of spin. Because about this axis only the rotor is rotating. Rotor is rotating like this. Clear for everyone? This is said to be the angular velocity. You know, angular velocity is a vector quantity, and when we are talking about the direction of angular velocity, when we are saying the angular velocity, we are calling it as a vector. To define a vector, we need to tell the magnitude and direction. But when we are talking about direction of angular velocity, it is given by right hand thumb rule. And right hand thumb rule is helping us to find out the direction. So always remember, whenever you find the question from gyroscope, keep your left hand into your pocket. Because if your left hand would be outside the pocket, there are chances that left hand will be coming up and make your question wrong. Okay, so for a gyroscope question, you assume like you don't have your left hand, you have only one hand. Otherwise there are chances that you will be making the mistake. So when you see question is there, just put your left hand back. Okay, because otherwise the chances of mistakes are there. So I am showing you the direction of, okay, I am showing you the axis of spin for 4 particular cases. Okay, and I am teaching you in a full-fledged way. Don't worry, because gyroscope, I know many students have the problem. So just wait, I would be starting, don't worry. So we are having this 4 cases for axis of spin. So you never have any mistake, you never do any mistake. We have, this is the coordinate system. This is the rotor rotating like this. One case is we are having view from here and looking like clockwise. The second case can be view from here looking anti-clockwise. Third case is rotor view from here clockwise. Fourth case is looking from here, we are looking as anti-clockwise. All the possibility I am going to show you. So my dear, just imagine I am having view from here. If I am looking at anybody is rotating like this in the clockwise direction, I would be saying the direction of omega is this. I will make this is the direction of omega, which is also said to be the axis of spin. Now from here only, this is clockwise, this is anti-clockwise. Direction will be coming like this. Axis of spin. If you are having this, looking from here clockwise like this, this is the direction. Looking from here clockwise, anti-clockwise like this, this is the direction. Everybody understood? Please tell me why I am telling you this axis of spin and all. Because from here only the gyroscope is going to be starting. Gyroscopic effect will be coming when we are going to rotate the axis of spin itself. First of all, tell me, everybody understood this or not? Please tell me that. Everybody understood or not? Please tell me that. Everybody understood or not? Please tell me that. Wonderful guys, wonderful guys, wonderful. So this is about the direction. Now my dear, we are going to talk about angular acceleration. Just listen to me properly. We are talking about angular acceleration. We are talking about angular acceleration. If you are talking about angular acceleration, my dear, angular acceleration is defined as d omega by dt. When we are having this d omega by dt, you know that omega is angular velocity. And angular velocity itself is a vector quantity, to define which we have magnitude also, we have direction also. Now my dear, if magnitude changes, alpha will exist. If direction changes, alpha will exist. So we can say alpha can be present because of 2 things. Alpha will be having 2 components. One is because of change of magnitude, other is because of change of direction. But my dear, in the paid course, I go for the derivation of alpha m and alpha d both. And then I tell that bhaiya baat aisi hai, it is like that ki in our entire gyroscope chapter, we assume the magnitude of speed is going to be same. That we are not changing the magnitude, we are changing only direction. So for that we are going to take only this component. And this component is coming out to be omega p. Here omega is nothing but angular speed of rotation of body. Omega p is said to be angular speed or angular velocity of precession. What is precession? Just imagine we are having a rotor like this, and this rotor we are going to see from here, and it is rotating in clockwise direction. Just say this is the y. So we are going to see here, this is clockwise direction, this is how the rotor is rotating, this is the direction of omega. So we will make the direction of omega like this. This is the omega. Always keep the tail end fixed like that. This is the omega, we have this. Now just imagine I am going to rotate this axis like that. when I am going to rotate this axis of rotation about which already some body is rotating, if you want to see example of that, I would like to say that you must have seen the wall fans. Like you cannot see, but just write to me there is a wall fan. You must have seen whenever you are going to any coaching classes, wall fans are there. There are two threads. One thread is to change the speed of the fan, other is to rotate the fan. You know, table fans are there. Table fans are like this only. But when you are going to put the rotate button, table fans start rotating like that. Application of gyroscopic couple. Okay, I will show you the same application in aeroplane, in automobile, in ships, everywhere it is there. But right now I am telling you, let us say, just take a normal example, rotor is rotating about this shaft. And I am going to rotate this shaft on which the rotor is rotating like that. So with the velocity by which I am going to rotate it, that is said to be the angular velocity of precision. And when I am going to do that, you are going to apply some torque, then only this rotation is possible. Like you were running a car at some speed, you thought there is a turn, I have to take the turn. So for taking the turn, you are applying some torque onto the steering wheel. Because of that torque, you know, car is taking the turn. So whatever torque you are applied, that is going to be utilized in taking the turn. The same is with aircraft, the same is with ship. Yes, it is. So whenever we are going to apply some torque to move this axis, that is said to be active couple, because we have utilized it. But you know, by Newton's third law of motion, every force is having a reaction. For every action, there is an equal and opposite reaction. So when you are going to apply this active torque, a reactive torque will be coming. So when you are going to apply this active torque, there is a shortcut to see the direction of the reactive torque, which is going to be asked from you in the exam. If I am having this as active torque, you just need to rotate this vector by keeping it fixed from the tail end. So it is rotating like this. So I will say this is the active couple, opposite will be the reactive couple. But you know, this is the direction of couple. We are interested in sense of rotation. Sense of rotation will be given by the fingers, and the fingers are giving you the sense of rotation of the reactive couple. And this is said to be the direction of reactive couple. And how we will write the reactive couple? The reactive couple can be written as I alpha. I alpha means I omega omega p. This is the magnitude of gyroscopic couple. So this reactive couple, we are calling it as gyroscopic couple. This is said to be gyroscopic couple or gyroscopic effect. We will see this at least 6 times. So you will never forget how to tell direction. So here you just need to remember 2 things. One is the magnitude, which is I omega omega p. Other is the direction. The way to see the direction is, this is the direction of omega. This is precision happening. Active, reactive, answer. Active, reactive, answer. Okay. And my dear, you can also see as it is moving in inside, you can see this is y direction. If you want to see this, it is moving in y direction. But you know, on this plane, whatever is happening in y direction, I can show in z direction only. So I am showing it on z, but in reality it is happening on y. So you have seen this was the initial omega, this is the final omega, this is active couple, this is reactive couple. Active, my dear, is going to be spent in turning the car, and reactive is going to be coming onto the system to reduce the life of system. That's why we are saying that we need to find out the reactive torque, which is gyroscopic effect. Okay, is it clear? For that I would give you an example. Like let us say you just get a fight with someone. Like you were going into the sabji mandi, you are just going like that, and someone is just get collide with you, and there was no mistake of yours, and he started abusing you. You would be feeling very bad. You also starting abusing abusing him. And you said ki you just tell me your address, I will come to your home and I will see you. He will tell the address, okay, aa jaiyo. You went to his street with your 20-30 friends and you find him alone. You do whatever you want to do with him, and then you go back. And when you go back, all your friends who were there, that person have taken the image of theirs and given their image to their friends, and wherever your friends would be having the interaction with the friend of the second person, they were getting punished. So they have not done any mistake, they have just tried to support you. The same thing is happening. We are going to take the turn of the car. After taking the turn, our task is completed. Then reaction will be coming onto the system. Because of that, the life is getting reduced for the system. Is it clear? Is it clear for everyone? This is what is going to happen. So guys, we have seen the gyroscopic couple I omega omega p. I am not going here for the derivation because derivation is not required much. Only magnitude is important. But I feel all the paid course students, they must be knowing how I have done wonderfully the derivation of all the two things. Okay, if you will see the video, you will get to know the derivation. Okay, everybody understood? Because that will take 30-40 minutes unnecessarily. So when we have this, now we will apply this on the multiple cases. One is for the aeroplane or aircraft. We will be applying this to the ship. We will apply this to the power plant shaft. Okay, and we will apply this to the automobiles. Clear for everyone? Moving further, guys. So we are going to have, okay, this is actually the derivation part only. Here they are showing initially we were having the initial velocity omega. Finally we have the final velocity omega p. So you can see this is the component responsible for change of magnitude. This is the component responsible for change in direction. Okay? Is it clear? So when you will be going for the direction component, you can find out this would be coming out to be omega omega p. Very good. So moving further, guys, moving further, now let us see for the aircraft. We are having this aeroplane. The top view of the aeroplane is said to be nose. Sorry, this front part, front end of the aircraft is said to be nose. And rear end is said to be tail. Let us say we are having view from here, and when we are having view from here, we can see the shaft or propeller shaft is rotating clockwise from tail. When we are going to see from here, we are having clockwise rotation of the propeller shaft of the aircraft. So when you see the clockwise rotation like this, you will rotate the finger, thumb will give you the direction, and you will get this is the direction of omega. I am making 2 times. I will tell you the reason for that. Now just let us see the aircraft is moving in this direction. Like I am moving in this direction. So you know that the left of the aircraft will be this, right of the aircraft will be this. So I am making here in this way. Left here, right here. As you know, this is 2D, and in 3D it is in negative y direction, it is in positive y direction. Left, right. So when this is the direction of omega, you will hold the tail end. When this is going to take the left turn, then you know this is going to go like that. When you are going to take the left turn, this is going to go like that. So active is this, reactive is this. This is the sense of rotation. Because you know in rotation, sense of rotation is important. Direction is useless. Direction is just a vector defined to avoid the confusion. So when we are going to have this, this is active, this is reactive. So I am making it, this is active, I am making it in this side, but it is in y direction only. This is active, this is reactive. So when we are going to say this is active, this is reactive, this is the sense of rotation. Just imagine if this is the aircraft. Just imagine if this is the aircraft, it is going to be like that. So can you say the front end will be having a tendency to go up and rear end will be having a tendency to go down? Arey bhai, this is going like that. So front end will try to go up, rear end will try to go down. So it means what I can say here, what I can say here, nose will have a tendency to go up and tail will be having a tendency to go down. This is gyroscopic effect. So you have taken this, but the effect is coming this. This is gyroscopic effect. Yes, Faninder, Danesh, Ashray, Shreyas, everybody is getting it or not? Very good, very good, very good, wonderful. Aniket, bahut badhiya. So my dear, whenever we are going to have this, the second case may be the right turn. The second case may be the right turn. So when we are going for the right turn like this is the direction of omega, right turn is this. Hold the tail like that, right turn is this. Active, reactive, sense. So, active, reactive, sense. Nose down, tail up. Is it clear? Is it clear? Is it clear? Very good, very good. So next, my dear, we would be having the case of ship. Gyroscopic effect on the ship. My dear, ship is having three phenomena. One phenomena of ship is like aircraft, taking left, taking right. Second phenomena of ship is this, rolling. Third phenomena of ship is this, pitching. So my dear, we have three phenomena: turning, rolling, pitching. So I would be telling you one by one all of them. First, let us assume the ship is having turning. So first phenomena is turning. But for all of the phenomena, we are going to define, this is the ship, rotor of the ship, and it is view. We need to take some view also. Front part is said to be bow, second part is said to be stern. As see from stern, left side is port and right side is starboard. Okay, right is starboard, left is port. And let us say this time we have this view, but rotation is anti-clockwise. When we are going to see from here, this is clockwise, this is anti-clockwise. So guys, this is the rotation, this will be the direction. So we are going to have the direction of omega like this. This is the omega. Now don't feel कि if omega is in this direction, ship is going back. No, ship is moving in this direction only. This is just a notation, nothing more than that. Okay, you know that these arrows do not mean that body is going in that way. Body is moving in this way, where this is its left, this is its right. So this time you need to be careful, because the direction of omega is like this. You need to hold the tail end carefully. And when you are going to go, like you are moving like this, when you will be taking the left turn, when you are going to take the left turn, you know we are holding it tightly. So when the left hand will be taken, when the left turn will be taken, when the left turn will be taken, when the left turn will be taken, you will find it is going outside. Outside is negative y. Outside is negative y. And negative y I am showing in downward direction. So this is going to be active. This is going to be reactive. Just imagine once again. This is omega. Left turn is this. In left turn it feels like it is going outside. Active, reactive, sense. Tell me what will happen. Tell me what will happen. Tell me what will happen. Just imagine the ship. Tell me what will happen. Just imagine the ship. Who will down? Bore's turn. Tell me, can I say bow down, stern up? Very good, Faninder. Very good, Faninder. Bow down, stern up. Bow down, stern up. So guys, if we have bow down, stern up here, now let us see the second case. Second case is, this is for the left turn. Second is right turn. For right turn is like this. When it will be going like this, you will feel it is going inside. Active, reactive sense. So, positive Y, we are showing it like this. Active, reactive. So, we will say bow up, stern down. Clear for everyone? Very good, Pujita. Okay. Wonderful, guys. So this is about the turning. We can also see the effect of pitching. So pitching is, once again, this time I am taking the same ship. Okay, this time let us change the direction of rotation. Sorry, this is the ship, let us say. This time just imagine we are watching from here only, but it is clockwise. So when it is clockwise from here, you know that omega is the direction, this. So if you are having ship like this, this is the direction of omega, I will keep it like that. Now pitching means this. Pitching means this, either this or this. So pitching means, you are saying, pitching means bow will be up, stern will be down. This is the one case. Second case is bow will be down, stern will be up. So when it was turning, then these were the results. When these are the effect, these are the pitching, it will result into gyroscopic effect in different direction. Like if you are having this omega and you are saying that bow is going up, stern is going down. This is the first time in the history I will be showing the correct direction on the board. This is active, this is reactive. Ship will have a tendency to move in the right. Right is starboard. So I would like to say this is active, this is reactive. It will try to move towards the starboard. Tendency to move towards starboard. If you are having bow down, stern up, active or reactive sense. So you are having active, reactive. Sense is this is port. So it will have a tendency to move towards port. Clear? Everybody clear? Everybody clear? So my dear, whenever we are going to have this, now whenever you would be having the rolling of the pitch, rolling of the ship, then in the rolling, you can see rolling is going to happen like that. If this is your omega vector, in the rolling, the direction of omega will not change. And if direction of omega will not change, there is no precision, there is no gyroscopic effect. That's why whenever we are going to see the rolling, in the rolling there is no gyroscopic effect. In the rolling there is no gyroscopic effect. Okay, so I can say in the rolling, in rolling the axis of precision is always parallel to the axis of spin for all the positions. So there is no gyroscopic effect. Okay. This is pitching. Okay. Credit to Roger Hope. Okay. Can you see the effect? Now there is a question coming that, sir, whatever you are saying, will it happen in really? So my answer is, dear, it will depend on the magnitude. Have you ever noticed whenever you are going, any turn is coming, it is written कृपया धीरे चलें आगे तीव्र मोड़ है. Because you know, whenever you are going to take the turn, there are many things, like we know some centripetal force is required for that, and also gyroscopic effect will be coming into picture. And more the speed of yours, more the gyroscopic effect will be, because it is I omega omega p. That's why if you are running at slower speed, its effect will be lesser. If you are running at higher speed, its effect will be higher. So that's why whenever you are taking the turn of the car, you are safely turning. But whenever it is a movie of Rohit Shetty and Ajay Devgan is driving the car, whenever he is going with very high speed, whenever he is going to take turn, he come out of the car, because after some time car is going to get blast. Yes or no? Yes or no? So guys, now we are going to talk about the last case of power plant shaft, which is very important for gate. Whatever the case right now we are doing is very important for gate. Okay. So we are going to have, let us say, this is the axis of a shaft. Okay. And let us say this power plant shaft is rotating with an angular velocity of omega. Okay, just try to imagine, this is a very interesting case and important as well. So when we are talking about this is rotating like that, and let us say this time we are having a view from here. Just give me a minute. Okay, this time let us say this is the view. This is the view. So we are watching from right hand side, and on this shaft we are having a rotor, and that rotor is having a weight of W. It is symmetrically placed. So guys, first of all, if you would be considering it as a simply supported beam, because of load W, you know, support reaction will be coming out to be W by 2 and W by 2. And I am going to see the rotation is happening clockwise from this view. This is the direction of omega. This is the view. Clockwise from here. Now my dear, you know that they would be giving that we are watching from the top. There will be an eye at the top. And you are going to see that from the top, this power plant shaft axis is rotating anti-clockwise. So you already have seen the direction of omega is this. Now you are watching from the top. This is clockwise. Anti-clockwise will be just inverse. So when it is going to rotate like this, this is negative y direction. This is active. This is reactive. This is the sense. You just need to make this sense here. This sense is like this. This is gyroscopic couple, which is given as I omega omega p. I feel everybody knows, because of this couple, the reaction at A and B you can calculate. So reaction at A now will become W by 2 minus CR by L. L is the total length. And here you would be having the support reaction at B, W by 2 plus CR by L. So you can see some extra reaction will be coming. Because of that, bearing has to be designed. That's why we need to calculate this gyroscopic effect. Please tell me, everybody understood this or not? Everybody understood this or not? Please tell me that. You can see na, from this view, this is clockwise, this is direction, omega. So if you are going to talk about that this is the direction of omega, and from the top view it is anti-clockwise. From top view this is clock, this is anti. It is going like this. Active, reactive. Clear for everyone? So this is the beauty of gyroscope you have seen. And guys, I feel they will be asking you the support reactions. Then it will become the combination of SOM plus vibration, SOM plus gyroscope. Is it clear? Is it clear for everyone? Fine. Now my dear, you can see this is what was happening actually. Some body was rotating about one axis. You have given rotation to the axis of rotation, and then precision is coming in the third direction. You know, some body is rotating like this about this axis. You have given rotation to this. Gyroscopic couple is coming in third axis. So that is why if they ask you the degree of freedom here, so degree of freedom will be 3 because of three directional rotation. So one is the axis of spin. Second is the axis of precision. And third is the axis about which gyroscopic couple will come. So that's why if they ask you degree of freedom, it will be 3. Rotation is happening about this, axis of precision will be about this, and gyroscope will be coming about the third axis. Now my dear, the last case is for automobile. When we are talking about automobile, I would just like to tell you that in automobile we have 4 wheels. In automobiles we have 4 wheels and 1 engine. So because of that, whenever you will be finding out gyroscopic couple, it will be coming out to be I engine into omega engine plus minus I wheel into omega wheel, and that is into omega p, because omega p will be same for both. So you can see here I is the mass moment of inertia of engine, omega is the speed of engine, W is the mass moment of inertia of wheel, this is speed of wheel, this is angular velocity of precision. So my dear, you know that whenever we are talking about the automobiles, you have wheels rotating with different speed, engine rotating with different speed. Because of gearbox, the speed is getting reduced at the wheels. That is why omega E is different, omega W is different. But omega P will be same for both. Engine I will be different, wheel I will be different. So why we are doing 4? Because there are 4 wheels. Why we are doing plus minus? Plus is for the direct gearing, minus is for the reverse gearing. In the direct gearing, engine and wheel will be rotating in same direction. In the reverse gearing, they will be moving in the opposite direction. Okay, and just imagine the car is going like this. Car is going like this. So this is the direction of rotation. Okay, this is the direction. It is going like this. Car is going like this. Okay, car is going like this. So this is rotating like this. This is the direction of omega. This is omega. Now let us say it is taking the left turn. You can see the direction in the same way. It is taking the left turn, then this direction will become this. This is active, this is reactive, this is going to be the case. So gyroscopic couple will be acting like this. It will try to go like that. So whenever you have left turn, it is going to go like that. Whenever you will take right turn, this was the direction. Whenever you are taking right turn, it will go like this, active, reactive. You can see this, it will be moving like this. Means whether you take left turn or right turn. In the left turn you are going like this, in the right turn you are going like this. So always you can feel here one thing I would like to tell you, that in the right and left turn, if this is the left turn, This is your car. This is inner wheel. This is outer wheel. So inner wheels were going up, outer wheels were going down. And when you are going to take the right turn, then you were getting this. Inner wheels were going up, outer wheels were going down. So for automobile, it is fixed that always inner wheel will go up, outer wheel will go down. Everybody understood this or not? If anybody have any doubt, you can ask me. Everybody understood this or not? Please tell me. If anybody have any doubt, please ask me. Clear? Here major problem is with the direction where students are having doubt. So here major problem is with the direction, not with the magnitude. Fine, Zakhmi Atma. Is it clear for everyone? So guys, with this we have completed the gyroscope. Okay, let us do some one question and then we will be looking for something else. Solve this question. Solve this question. A rotor of turbojet engine of an aircraft has a mass of 180 kg, polar moment of inertia this. About the rotor axis, the rotor rotates at a constant speed of 1100 radians per second. And you can see they have given this mass 180 kg. Moment of inertia 10 kg meter square. Constant speed 1100 radians per second. Aircraft while flying at a speed of 800 km per hour takes a turn. Omega P is V by R. 800 km by 1.5 km. So you need to find out I omega P, and then we will see the direction. First calculate the magnitude. Okay, Zakhmi Atma is saying 1629.6. So A or D? A or D? Answer will be A or D. So as per the results, you would be saying either A or D. Okay. So the question saying rotor of turbojet engine has this mass, this inertia about the rotor axis, rotates at constant speed in clockwise direction and views from the front of the aircraft. यहां से देख रहे हैं front clockwise. Direction of omega is this. So this is the direction of omega. The aircraft while flying at a speed, the speed takes a turn with a radius of 1.5 km. The gyroscopic moment exerted by the rotor on the aircraft structure and the direction of motion of the nose of the aircraft to the left. Okay, the turn is taken in the left. For the left turn, if it would be taking the left turn, you know we need to hold the tail end. So we will feel that tail end is fixed and it is going out. Active, reactive. So it is, nose will be going down. Answer will be D. Clear for everyone? Clear for everyone? Very good Dhanesh, very good Vinay, very good Shreyas. Fine. So guys, answer is D for this. With this we have completed the gyroscope. So guys, now I would like to tell you some things. अभी कुछ राज की बातें. Okay. The very first thing is कि great Zakmi, fine. Okay. So I would like to tell you the first thing here is fine. So when we are talking about the first thing is about HMT. So guys, just when I will close this session within 1 to 2 hours, HMT marathon recording would be uploading, and that will be uploaded by both Suraj sir and Chandrasekhar sir. So you will be able to watch that marathon at your convenience. It was about to premiere today, but then I thought ki already 4-5 PM is there in this session. So if somebody is not feeling relaxed, you can attend, you can watch that marathon tomorrow also. Choice is yours. That would be coming on the channel today in the form of recording. So in the video recording section, you can watch the heat and mass transfer marathon. Okay. And it would be live, it would be available after 1 to 2 hours. And second thing is, now we are talking about the production. In the production, we are left with these topics: metal cutting, metal forming, and we have metrology and sim. So guys, in these two chapters are completely formula based. I feel everybody know these two chapters are completely formula based. And here, if you see sim, only 3 things are going to be important: BLU, then we are going to have the G and M codes, and then we are going to have one more thing that is related to what? BLU, G and M codes. What is the third thing? I forget actually. What is that? G code, M code, basic length unit, and geometrical transformation. And here also we are getting the question from these 3 areas. And yes, metrology is a complete topic where we have limits, fits and tolerance and all. Okay. Here also limits, fits and tolerance are more important than other topics. So guys, these 4 topics we are going to cover in one session, but that session is not tomorrow, because from Monday we are starting the mathematics. Okay. So that's why tomorrow we are not keeping any session, because HMT also is there left for you. So if tomorrow we will have the session, you would not be able to complete HMT. That marathon is of 10 hours actually. So that is why we are not having this tomorrow. We are going to have this in some day between 21 to 30. That will be informed to you in the mathematics classes. Okay. So we will be having these 4 topics. So don't worry about that. Okay. So Zakmi, that you can definitely improve by the practice only. If you have any particular doubt, then we can discuss on that, don't worry. So guys, now we are talking about one last thing. Ki this is clear for everyone. Now in the tome we are left with these things: cam, governor and balancing. So now you tell me, would you like me to complete these 3 topics right now? Or for this also I can provide the recording in the comment section if you want. Okay, because they are very 3 chapters are there. They are also, if we are talking about this chapter, here characteristics of governor are more important. Here some formulas are there. Okay, so if you want we can go with that, but if your mind is not working right now, then it is having no meaning of going with that. Faninder, yes, metal cutting weightage is more, and I am going to be live for these 4 topics. Don't worry. These 4 topics we are going to meet live from 21 to 30th January, one day. That session we will be keeping one day, maybe 26th January we may plan. So one day it will be there for sure. Don't worry. Okay, so that is already planned. Don't worry. Okay, only the day is not fixed from my side. that we will fix it in one day. Why tomorrow I am not doing? Because yesterday I have taken, today I have taken, so it will be very hectic for me. And tomorrow I also have some paid class courses 1 to 2 in some batch. So it would be very hectic for me to have 3 classes continuously. That's why. But we will be having this for sure. So be ready for that. Okay, and from Monday we are starting the mathematics. Monday mathematics, Tuesday aptitude, Wednesday mathematics, Thursday aptitude. But those sessions will be at the max 1.5 to 2 hours. Not more than that. So we would be having 2 hours per day. That is not very big, so we can complete it very easily. And in between one day when aptitude class will be there, after aptitude class I will start metal cutting. So don't worry, I will be covering this part for sure. This is important, I know I will be covering it. But here, if you want, we can add recording, because I am feeling that you guys are tired, because from the responses what I am feeling is. So don't worry, if you want, last year marathon, these 3 topics are also covered. If you want, I will share it with you. You can go for the recording for these 3 topics. Faninder, every day we would be having one topic. Some topic may take 3 hours, 4 hours. Some topic will take 1.5, 2 hours, like complex number is small topic. Okay. So we would be going like that. Is it clear? Ha, 4 hours is the maximum you are saying, not more than that. Even some topics, like if you are having where complete mathematics is covered in 2 days, 12 hours, 15 hours, we are still taking 20 hours, 20 to 25 hours. So that is very good time, I feel so. Is it clear? So actually I wanted to teach vibration and gyroscope live majorly for today. That I have taught to you. Cam Governor, can you take balancing in live please? Okay, then let us start. I am ready for that. If you want, let us start. If you want, let us start then. Let us start. If you guys are okay, there is no problem from my end. Let us start the balancing then. Okay. So when we are talking about the balancing, but we will go in the gate way. Okay. We will go in the way of gate. Okay. Not with the everything derivation. Fine. So when we are talking about balancing, first of all, you should understand that balancing is done for the unbalanced forces. Unbalanced forces are those which produces vibrations. These are the forces which are changing with the time in the way of direction. Like we have a rotating body rotating with omega, whose center of mass is eccentric to the axis of rotation. So because of this, when it is rotating with omega, some force me omega square will be acting. So this direction of this force will keep on changing with the point, because that point will keep on moving like that. So the direction of this force will keep on changing like that. So here the direction of force is changing with time. That is why this force is a fatigue force. Is it clear? Great. Thanks, Farinder. So when we are talking about this me omega square, direction is changing with the time. So direction is changing with the time, so we call this force as unbalanced force. Then we are going to have the second thing. This is the sliding body like this. You know that already. Whenever this slider was at rest here, you are pulling this slider. So slider will also apply some force, that is said to be inertia force, which would be equals to mr omega square cos theta plus cos 2 theta by n. So So when we are having this, my dear, you can understand one thing, that here theta is changing with time, and when theta is changing with time, the magnitude of force will change with time. So here direction changes with time, here direction changes with time, here magnitude changes with time. So my dear, where magnitude or direction or both changes with time, these forces are said to be fatigue forces. They are going to create vibrations, so we need to balance them. So balancing of these forces are anyhow required. Okay. Now, when we are going for balancing, you can feel we need to balance the rotating bodies or rotating masses, and we need to balance the reciprocating masses. We need to balance rotating masses and reciprocating masses. First we will see the balancing of rotating masses. First we will see the balancing of rotating masses. So balancing of rotating masses can be done in two ways. One is static balancing, second is dynamic balancing. So when we are talking about the static balancing is done when all the unbalanced masses are in a single plane. Like let us say you are going to have a flywheel with spokes. Let us say this is the case. Or leave about flywheel, we are having, let us say, a body like this. And here you can see the center of mass of this part is here, this part is here, this part is here. Let us say this part is having a mass of m1, this is having m2, this is having m3. And it is at r1, at r2, at r3. And if this body will be rotating with an angular velocity of omega, you will find there are some forces coming into picture. One force will be going like this, other force is going like this, other force is going like this. So this is going to be m1 r1 omega square, m2 r2 omega square, m3 r3 omega square. These are the forces, and you can see all the forces are in a single plane, all the masses in a single plane. So here we will be going for static balancing. And when we are going to have, let us say this is the shaft, one wheel, two wheel, three wheel, or rotors, four rotors are there. For the first rotor, let us say mass is eccentric like this. Second, mass is eccentric like this. Third, mass is eccentric like this. Fourth, mass is eccentric like this. This is plane A, plane B, plane C, and plane D. Here you will be able to see, here this would be the M1 R1 omega square, because this is rotating with omega. So omega is same. You would be having here unbalanced force like this, here unbalanced force like this, here unbalanced force like this. So all four forces are in different plane, plane A, plane B, plane C, plane D. Okay, like if you want to see all the planes separately, I am showing you all the planes separately. Let us say this is the x-axis, y-axis. So if you see this, here this is the unbalanced force. 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 So they are having different planes and different direction. But if you are going to see from this view, then you will find all of them to be concentrated at one point. One is acting like this, other is acting like this, other is acting like this, other is acting like this. It will look like that. But otherwise they are in different plane. So in such cases, when all the unbalanced forces are in different plane, we call them as a case of dynamic balancing. So my dear, when we are going for static balancing, we just require one balanced mass, that is enough. But when we are talking about dynamic balancing, two balanced masses are required. When we are going for static balancing, we need to balance forces. Moments are self balanced, अपने आप बैलेंस हो जाती है. But when we are talking about dynamic, unbalanced force and unbalanced moments both need separate balancing. Here my dear, we have all the forces in the same plane and they are coplanar and concurrent forces. For coplanar and concurrent forces, there are two equilibrium equations. Here we have three equilibrium equations because forces are neither coplanar. Okay, they are not coplanar forces. They are in different planes. So we have summation fx0, summation fy0, summation moment 0. Is it clear for everybody? Please tell me the difference between static and dynamic balancing is clear or not. Please tell me that. Yes, Vinay, Zakmi, Atma, Lakshmi, Aritro, Farinder, Aniket. Abhi, very good. Very good. So now we are going for the case of static balancing of rotating masses. And here all the masses are in same plane. So my dear, we have this mass m1, this mass m2, this mass m3. And as I said, if only one balanced mass is required. So I feel you can understand if I will be adding the one balanced mass, after this addition of balanced mass, the entire system will get balanced. So my dear, for m1 we have m1 r1 omega square, for m2 we have m2 r2 omega square, for m3 we have m3 r3 omega square, and we are saying we are adding a balanced mass at a radius of rb and we are taking x-axis as reference. So you can see every mass is having some angle, like m1 is having a angle of theta 1, m2 is having an angle of theta 2, m3 is having an angle of theta 3, and similarly this balanced mass will be having an angle of theta b. So like if that is the case, my dear, you know, whenever we have studied engineering mechanics, if more than two forces are coming onto the system, more than two forces are coming onto a system, then we can do one thing, we can take all the forces in two components. Like we can break their x and y component. So we can have all the x components together as summation fx, all the y components summation y, and when these two will be having, the resultant can be found out very easily by writing resultant as square root of summation fx ka square plus summation fy ka square. And my dear, here the problem is, we are saying after having this balanced mass, the system is in equilibrium. So because of that, resultant will be 0. The sum of two positive things cannot be 0 if both are not 0. So if the sum of two positive things is 0, it is compulsory that summation fx individually is 0, summation fy individually is 0. So we need to write the x component of all the force and add them. So when you would be writing summation fx, you know that this m1 r1 omega square will be giving the x component as cos theta 1. So you would be writing m1 r1 omega square cos theta 1. Similarly, you would be writing m2 r2 omega square. Omega is constant for both, cos theta 2. Similarly, we would be having m3 r3 omega square cos theta 3. Is it clear for everyone? And balanced mass will be having mb RB omega square cos theta b, and that is equals to 0. Similarly, we can write summation Fy m1 r1 omega square sin theta 1, m2 r2 omega square sin theta 2, m3 r3 omega square sin theta 3, mb rb omega square sin theta b. You may be having a doubt here कि sir, why you are adding all the components? Because the x component of this force will be coming in this direction. But dear, when you are taking this at theta, this is the theta 2 angle, na? You know this is theta 2. Theta 2 is more than 90. So I know when I will be putting this angle, it will automatically be coming negative. So I need not to put it negative. I am putting positive. This cos theta 2 will make it automatic negative. So I need not to worry about that. So if that is the case, my dear, when you are equating them individually to 0, from here you can also write the equation like this. MB RB cos theta b will be coming out to be minus summation of mi ri cos theta I is equals to 1 to 3, because there are total 3 mass. Okay, this is going to be, I feel everybody understood this. Omega square will get cancelled out when you would be having mb rb sin theta b. It would be coming out to be minus I is equals to 1 to n mi ri sin theta I. This is becoming equation 1, this is becoming equation 2. You will go for square and add. So you would be going for mb rb square cos square theta b plus mb rb ka square sin square theta b is equals to, squaring minus sign will be going, summation mi ri cos theta I mi ri sin theta I. And you know that this is going to be square, because square and add you have done. When you are going for square and add, you know cos square theta b plus sin square theta b is 1. So you are going to get mb into rb is equals to the square root of. This is the first formula from which question will be coming. mi ri cos theta I ka square mi ri sin theta I ka square. So the point is, अरे भाई हरिकेश, actually that is the same slope method we discuss. Okay, actually this is the way of sir to teach that. Okay, so sir was teaching like that, I also teach it in the way of slope. So sir is giving the name like that, otherwise there is no such method like that. Okay, this is just the use of mathematics actually. Okay, like if you have attended my classes also, I go with the slope method. Like sir have given you, na, remember these graph. When I give that, I don't even go for the remembering of graph. I simply say whether the slope is increasing or decreasing. Okay, so just to होता है ना कभी कभी कुछ चीजें हम बोलते हैं ताकि आपको थोड़ा अच्छा लगे. So it is like that only. असली में ऐसा कोई मेथड थोड़ी है यार, मैथमेटिक्स है वो और कुछ नहीं. Is it clear? Theta is always considered from the x-axis. Theta is taken from positive x-axis. Okay, so actually like I go with that slopes in strength of material of SFD BMD. Sir is giving some remembering of curves, and if you remember that curves, you can directly answer. Both are same actually. Both are same. They are not having different. If you would be understanding mathematics, you will say, sir, your approach and Abhinav sir's approach is same only. The only way is sir is giving you 6 curves before that. I tell you why to remember the curve. I just need to go with one thing. You need to see whether the slope is increasing or decreasing. Because you know the slope of BMD is shear force. The slope of SFD is load intensity. So both are same. They are not even different. Okay. The only point is, if you want to go with the shortcut, go for the sir's way. If you just go from the fundamental, go in my way. Both are correct. Even fundamental is also short. It is not taking time. Okay, it is just the way of explaining. Even like when I have taught, I would say it as DS method. So you would be getting better. So sir is saying like that because sir is the only one who is teaching in that way. So that's why sir is saying it as AN method. Okay, fine. So shall we move on? Shall we move on? But it is just the mathematics. Just the way to interact with you guys so that you guys are feeling good in class. So this is MB RB is given as this. Okay, clear for everyone? Harikesh, then you can go with your way. As I said, you can go with that in that case. If you are not able to understand whether slope is increasing or decrease. If you can understand, I am telling you, you just need to see with the x-axis. Whether the theta is increasing or decreasing, that is slope. If that is difficult for you, I don't know what is easy then. I am feeling very bad by looking at that. For you, slope is difficult. If you cannot judge the slope, how you are able to judge that? I am really not feeling that correct for you. Okay, if you cannot judge the slope, how you can use that method even? There also you need to judge the slope. So that is really a idea of concern. Okay, इसको थोड़ा सोचना कि जब आप slope ही नहीं judge करोगे तो वो भी method कैसे लगा लोगे आप? Slope judge करना is the easiest thing. ठीक है? Okay. Okay, Harikesh, whatever you feel better, you go with that ना. कौन रोक रहा है आपको? ठीक है? Fine. So my dear, you are having here two variables. One is MB, other is RB. You are having here two variables and this is tone and vibration going on. Why you are taking so into that? बाकी students के लिए मुश्किल होगा. Okay? So just concentrate here for vibration and tone. So when we are talking about this MB and RB, there are two variables. If you don't know either of them, you cannot find out the second one. Okay? You cannot find out the second one. And whenever we are talking about MB and RB, always in the question one will be given. So either of them will be given. And second can be found out. Second can be found out. Is it clear? Is it clear? Even Harikesh, I would also like to see you when you will be going for most difficult cases. Then you would be feeling that slope method is giving you easy answers. Okay? You can also check those also if you still have any doubt. Okay? So just go for that for all level, all 17 case. If you can judge by that, then it's fine. So now we are talking about either of them will be given and second can be found out. So always either MB or RB will be given in the question and second you can very easily find out. This is how we can go with. I feel everybody understood this. This is about the analytical method. And now what about the theta B? How we will get to know that where this balance mass is to be placed. For that purpose we can divide the equation 2 by equation 1 and we can write it as tangent theta B. Tangent theta B would be coming out to be minus of summation I is equals to 1 to n mi ri sin theta I minus I is equals to 1 to n mi ri cos theta I. When you see this, never cancel the minus signs, because if you will be cancelling the minus sign, it is going to be a method of concern. It is going to be a concern. Why? Because my dear, the final sign will decide the quadrant of the balance mass. Here if you are writing tangent theta B, you know tangent theta is y by x. So here let us say you are getting some value. You are getting minus 4 by 5. If you are getting it minus 4y, x is 5. You know it will become minus 4 by minus 5. It means y is positive, x is negative. If you are getting this, it means balance mass will be coming in the second quadrant. So if balance mass is coming in the second quadrant, it means the resultant of all masses would be coming in the fourth quadrant. This is the unbalance. So to balance it, balance mass is coming here. But if you are going to cancel minus sign with minus, then it would be coming out to be minus 4 by plus 5. Here y is negative, x is positive. This will become fourth quadrant. So if you will be cancelling the minus sign in the direction of unbalanced force only, you are going to apply the mass, which will be increasing the unbalance to 2 times. Is it clear or not? Is it clear or not? Is it clear or not? Yes. Please tell me. So that is why you will never be cancelling the minus sign here. Although here you can make the minus plus, because here there is no problem like that. So here you will never be cancelling the minus sign, otherwise your selection will also get cancelled. This is said to be the analytical method. This is said to be the analytical method. It is said to be the analytical method. Now my dear, we are moving. Now my dear, we are moving for the graphical method. There is one method which is also said to be graphical method. Let us see that method as well. Let us see the graphical method as well. Let us see the graphical method as well, because after that only we would be able to enter into the dynamic balancing. So we are going for the graphical method now. Graphical method. So when we are going for the graphical method, as we are having the forces like this, let us say this is M1, this is M2, this is M3, and all are rotating with omega. So you can say that there will be a force M1 R1 omega square. There will be a force M2 R2 omega square. There will be a force M3 R3 omega square. So when you are going for graphical method, what it says? Graphical method says that you start with one force. Like, let us say you have this point as O. You start with one force, M1 R1 omega square. Let us say we are having some value, omega square is common for everyone. Let us not go for force polygon. Let us go for M into R polygon. So M1 R1, let us say you found out it is coming out to be 5 Newton by radians per second ka square. So you are getting M1 R1 as 5. You know the magnitude, you know the direction. So you will be going for this in this way. This is point A. This is M1 R1. First force. Then when we are going to have first force, you would be having the second force M2 R2. Where first force is completing, make the second force. Let us say when you are going to calculate M2 R2, it is coming out to be 3. Because this will be given to us. Similarly, when you go for M3 R3, you are getting the value to be 9, let us say. So M3 R3 will be coming like this. Now my dear, you can feel very easily this is the initial point, this is the final point. Joining will give you the resultant of these three forces. This is the resultant of these three forces. Is it clear? Yes, Ajay. No problem. So when we are having this resultant, then my dear, if this is the resultant, to balance this, we need to provide the balance mass like this. This should be the balance force, because with the balance force we should reach to the origin from the to the 0 point, so that the things are going to be balanced. So from here we get the balance mass will be acting like this. So we can apply the balance mass here, MB RB. But here also you are going to get the product of MB RB. Out of these two, at least one should be known. At least one should be known. At least one should be known. Clear for everyone? Static balancing is over. सर सीक्वेंस हम कहीं से भी ले सकते हो, कहीं से भी ले. सीक्वेंस इज नॉट इंपॉर्टेंट. ओके, sequence is not important. Everybody is clear about the static balancing. Now we are going for the dynamic balancing. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. We are going for dynamic balancing now. So when we are talking about dynamic balancing, there is a question given to us. Just try to understand properly. Within next 5-10 minutes we will complete dynamic balancing, and then we will enter into reciprocating balancing. Okay. So when we are having this, we have four masses A, B, C, D. We have four masses A, B, C, D. Okay, MA is given as 5 kg, MC is given as 3 kg, MB and MD are not given. And the distances are given like R1 0.3 meter, R2 0.2 meter, R3 0.25 meter, R4 0.5 meter. R1, R2, R3, R4 are given to us. So my dear, they have also given that the angle between A and C is 120 degree and it is making 0 degree with x-axis. Because they are in different plane, A, B, C, D, you can see. But when you will be having one view, from one view you can observe like these two. Other two masses we don't know. Neither masses are known nor their locations are known, but they are saying that with this all four masses the system is balanced. So you can also consider MB and MD would be the balanced masses, because you know in dynamic balancing we require two masses. Zakmi, it is not difficult. Directly question will not be there like that what I am going to do, because making graphs is not there for the GATE exam, but they can ask you from the concept of this. So you need to understand the concept only. Okay. So when we are talking about this case, let us say B and D are the balanced masses, because in the dynamic balancing we require two balanced masses. So they are saying now this system is entirely balanced. You need to find MB, MD and their locations. So for that, first of all, we will be making a table where we have four planes, four masses. 5, MB, 3 and MD. All the radius are known to us. These are the radius. Okay, so we can write the product of MR, because you know while making force polygon we are writing FC by omega square. Why? Because we are saying omega square is the common factor. So we are writing M into R. M1 R1, M2 R2, M3 R3, M4 R4. There is no problem. Now when you will see this force, there are 4 data. Out of 4, 2 are unknowns. If you can see this, there are 2 unknowns. If you can see, there are 2 unknowns. Better I will show by the red color here. That would be better. These 2 are unknowns. So my dear, with one polygon we cannot find out 2 unknowns. With one polygon we cannot find out 2 unknowns. So we cannot draw the force polygon. So now we are going for okay. If we are not able to make the force polygon, let us make the moment polygon first. Let us balance the moments first. So when we are going for balancing the moments, we need to do one thing. Like in the force polygon, we cannot balance the forces if there are 2 unknowns. In moment also the same condition is there. So we need to find out the moments in such a way that only one unknown should be there. So let us take this as the reference. If we are going to take this as the reference, then in this direction we will be considering negative, this direction we will be considering positive, but the distance of this force, like MB, let us say this, so this force is passing from here only, so moment of MB is going to be 0. So my dear, this will become L1, this will become L2, this will become L3. So we are going to write L1, L2, L3. L1 is minus 0.5 because it is negative direction. This is 0, this is 1 and this is 1.3. Y1, this is 1, this is 0.3, total is 1.3. So when you will be multiplying MR with the L, you will be getting MRL. This is also moment but a omega square. It would be minus 0.75, 0, 0.75, 0.65 MD. You can see only one unknown is there. You can see only one unknown is there. So it means moment polygons can be plotted. As only one unknown is there, moment polygon can be plotted. Okay? Arithro, I already told you this question cannot come in the gate, because there you cannot plot force and moment polygons. But this concept is going to be utilized at many places. So you should be aware of the concept only. Okay? So the very first thing what we understood is, if we are having force and moment both polygon, any of the polygon can be plotted first. First point, you can note it down. We can make any polygon first, force polygon or moment polygon. Second point, here we have taken the scale factor of omega square for both the cases. This is the common scale factor. While drawing, if I will take any other scale factor, there is no problem. I can consider different scale factor for force and moment polygon. Third point, when we are talking about force and moment polygons, whenever we are talking about the force and moment polygon, we can find out only one unknown from one polygon. Two unknowns cannot be found out. Okay? Now first we are going to plot the moment polygon. Let us say, to plot the moment polygon, the rule is very simple. That if moment is positive, the direction is same as that of force. If moment is negative, direction is opposite to the force. So you can see here the given figure is like this. This is MA, this is MC, X, this is 120. This is given to us. So you already know that the first moment is minus 0.75. Negative moment. Negative means opposite to the direction of force. You know that this is the direction of force for MA, RA, omega square. Let us say when you are going to find F1 by omega square, you would be getting M1 R1. And let us say it is coming out to be 5 Newton per radian per second ka square. If it is coming like that, we are starting. Direction is this. And let us say we are considering 1 Newton per radian per second ka square as 1 centimeter. So we are getting OA like this. This is M1 R1. Where first force is over, second will be starting. You know second is 0. So next point will also come here. Third force will be in this direction if the moment is positive. You can see the moment is positive. So you would be having in the third direction. Okay. Actually it was given as minus 0.75. So let me correct it. So we are going to have, we are going for the moment polygon. So we are getting MA RA omega square is the force, and moment we already know it is minus 0.75 for the first mass. If it is minus 0.75, direction will be opposite to that of the force. You can see here direction of force is this. So direction of moment will be opposite this. OA, this is 0.75. Okay. You can also consider like 0.1 is considered as 1 centimeter. So it would be of 7.5 centimeter long. So this is nothing but M1, R1, L1. Everybody understood or not why I have made in this direction? Because the direction of force is this. Moment is negative. Negative means opposite to the direction of force. Sorry, previously I was making by mistake force polygon. This is the moment polygon rule. So guys, now the next point you are having 0. So next point will be here only B. Next, MC is going in this way. We already know the magnitude. It is 0.75 positive. Positive means in the direction of force. The same 0.75, same length. You would be getting this. Now my dear, the next force is, next moment is 0.65 MD. This is positive. Positive means in the direction of force. But we don't know the direction of force, because MD is not given to us. But we know overall the system is in equilibrium. So if this is the starting point, this is the final point, this resultant is there, this resultant will be balanced by the last force, which is nothing but 0.65 MD. So 0.65 MD will be balancing it. So it is 0.65 MD. Let us say after calculation, it is coming out to be 6.5 centimeters. You know, you have assumed 0.1 is 1 centimeter. So 0.65, you will be getting MD to be 1 kg. Please tell me everybody understood or not. This is how the moment polygon will help us to find out this unknown. Please tell me everybody is getting it or not. Then we will be moving further. Please tell me guys, everybody is getting it or not. Then we will be moving further. Please tell me everybody is getting it or not. Then we are going to move further. Okay. Very good. So we got this MD, and you can see the direction is giving you where the balanced mass will come. So this mass will be coming somewhere here, MD. Okay. Now my dear, we will be going for the force polygon. Moment polygon is over. Now we will be going for the force polygon. Let us see the force polygon. Now we have one mass here, other mass here, and other mass here. Three masses are known to us. So now we are going for the force polygon. So when we will be going for force polygon, we have the values. First force is 1.5. You know the direction is this, 1.5. Let us say 0.1 is 1 centimeter. So 1.5 will be 15 centimeter. This is O, this is A. Then we know second is not known to us. Then I already told you, when you are making yes, when we are talking about this, second is 0.2 MB. This is unknown to us. I told you, you can make any force first, any force after. So we will make first this one, 0.75. So when we are going to make 0.75 first, if this is 15 centimeter, 0.75 is in this direction. So we would be making like this, 0.75. And now my dear, what is the next force? Next force is this. And you know the value of it is 0.5 MD. It is coming out to be 0.5. It is coming out to be 0.5. So 0.5 means what? 5 centimeter. 0.5 means 5 centimeter. And if you are going to plot the 5 centimeter, it would be coming like this. It would be coming like this in the direction. Like this. So this is the new point we are getting as D. Now if you are going to say O to this point, this is going to be the resultant of three forces, and if you want to balance it, then you would be having balance like this. So we got this distance, let us say coming out to be 1 point, this is coming out to be 12 centimeter. 12 centimeter is nothing but 1.2, 1.2, and you know the distance here is 0.2 mb. So when you will be keeping it to be 0.2 mb, you would be getting mb as 6 kg. So this is how we can find out the unbalanced masses. But these diagram you need not to make in the GATE exam. Only these points you need to remember, because sometimes they are asking from the points. Like you can make any polygon first, force or moment. While plotting the moment polygon, if moment is positive, direction of force is the direction of moment, and vice versa. Scale factor can be different for both. Any polygon can be plotted first. You can go for any force first, any force after. Sequence does not matter. So all these are the points, and this is how the dynamic balancing will be done. Please tell me everybody understood. With this we have completed the rotating balancing and we are entering into reciprocating balancing. Okay, this is the GATE question. If you want to do, you can do that. You can see this formula will be applicable. This is GATE 2005 question. You can solve it. M1 R1 cos theta 1 plus M2 R2 cos theta 2 ka square. This is a very good question from GATE 2005. M1 R1 sin theta 1 plus M2 R2 sin theta 2 ka square. Now whatever we are going to start after this question is the more important thing, because for GATE the questions are coming generally either from this formula which we are doing, or they will be coming from reciprocating balancing. Okay, after that the engine, 4-cylinder inline engine, those kind of things are very rare for GATE exam. So we will go for reciprocating. Okay. Yes, Ashray, Aniket, Vinay, Ajay, try to answer it. Try to answer it. Try to answer it. Try to answer it, guys. हाँ भाई, Dhanesh. Yes, answer will be coming out to be 150 mm. You know, this is rotating disc of one diameter has two eccentric mass. M1 and M2 are equal, 0.5 kg. 50 mm and 60 mm are R1, R2. 0 and 150 degrees, theta 1, theta 2. Fine. Answer will be coming out to be 150 mm. Okay, very good. Shreyas, बहुत बढ़िया. So guys, now without wasting the time, we are entering into the reciprocating balancing, which is important for exam. Okay, so we are going for the reciprocating balancing. So when we are talking about balancing of reciprocating masses, first of all you need to understand how the things are going to happen. Let us say we are having this to be a cylinder. In this cylinder, just try to understand properly, this is very interesting. We are having this slider, we are having connecting rod, we are having crank, and this is how the crank is rotating. Very good, Farinder. So my dear, when you are having this is OAB, you are going to say that when the crank is rotating, you know slider is moving in this direction. So slider was at rest, you are going to apply the force onto the slider. So as you are changing the as you are changing the state of motion of the slider, because slider is at some state of motion, that is rest. Anybody will try to be in its state of motion until you apply any external force, and it don't want to change it. So when you are trying to change its state of motion, which is rest, it will resist that, and it will resist and apply a force onto connecting rod. Connecting rod will transfer this force to the crank will transfer that force to the crankshaft, and you would be having that inertia force acting like this. And this force, if you will be writing, it is going to be F is equals to mr omega square cos theta plus cos 2 theta by n. And as you can see, its magnitude is changing with time, so it is a fatigue force, it needs to be balanced. So this is the force acting here. This force can be divided into two parts. We can write this unbalanced force as equals to mr omega square cos theta plus mr omega square cos 2 theta by n. And when we are writing like this, this force is said to be the primary unbalanced force. This force is said to be the secondary unbalanced force. Why we are going to divide it into two parts? Because we have seen in the flywheel chapter that the N, which is L by R, and this was very big for the Sir James Watt engine. So if N is very big, then obviously this component is going to be very less. So even if we are going for primary balancing, if we are not even going to go for secondary balancing, it would be not creating much problem. And even if you understand how to balance primary, the same way secondary can be balanced. So guys, we are going to have two forces. One is primary, other is secondary. First, our concentration will be on primary balancing. So let us assume that we are having only one force acting, that is the primary force. So we are assuming that this is the force which is mr omega square cos theta only. So my dear, I would like to tell you, for balance this, Sir James Watt have considered it in this way. Although this force is coming because of piston which is here, but he just assumed, let us say there is an imaginary mass acting, this is MP is the mass of piston. It is imaginary mass which is placed at the crank in such a way that when crank is rotating with omega, you know it would be MPR omega square. And the cos component of this MPR omega square is this, MR omega square cos theta. So this was imagined that mr omega square is having a horizontal component like this, which is nothing but mr omega square cos theta. So there was no such mass present in reality, but it was imagined that maybe some mass is present here whose horizontal component is coming like that. Then to balance that, suggestions came that we can also balance it by putting a balanced mass at a distance of B in such a way that B into B should be equals to M into R. And as it is present on the same crankshaft, it would also be rotating with the speed of omega. So you would be having B into B omega square is equals to M into R omega square. And if B into B omega square cos theta, it will also be equals to M into R omega square cos theta. So you can see the horizontal component of this will balance this. And when we have done this, we were very happy that horizontal components are balancing and there is no problem now. But when we have seen the life of this engine, it was still very less. It was still the same. Both aritro, then for rotating you will apply the formula of rotating, for reciprocating you will apply the formula for reciprocating. Both we are doing in that way. Okay, so both you can share the question to me, I will tell you. So if that is the case, BB omega square cos theta will be balanced by that. But dear, this balanced mass is a real mass. This was imaginary. Imaginary things do not give any component, but real things gives the component. So we would be having a component of BB omega square in this direction as BB omega square sine theta. So because of BB omega square sine theta, this balancing was flopped, because previously because of BB omega square cos theta we were having the vibrations like that. Now because of BB omega square sine theta we were having the vibrations like that. So only the axis of vibrations got changed. Only the axis of vibrations got changed, nothing more than that. So this attempt of balancing was completely failed. Then when this attempt was completely failed, suggestions were given for the partial balancing. So after that we went for the partial balancing. After that we went for the partial balancing. This figure is showing you how the balanced mass are attached. You can see this is how the balanced masses are attached in the crankshaft. Okay. So whenever we are talking about the partial balancing, if we are going to apply the balanced mass in such a way that B into B is C into M into R, where C value generally is varying from 0.5 to 0.75. So if you are going to do that, this time in the X direction you would be having the force equals to 1 minus C mr omega square cos theta. Why? Because this X component is mr omega square cos theta, this is BB omega square cos theta, and you know BB is nothing but CMR. So this would be the summation Fx, and the summation Fy would be coming out to be CMR omega square sine theta. So this time unbalanced forces came in both the direction. Just listen to me what is happening. Previously unbalanced forces were like that. When you have tried for complete balancing, unbalanced forces came like that. Vibrations happened like that. Then my dear, if you have done partial balancing, vibrations are at both the places, both the directions. But the thing was, its amplitude got reduced. This time amplitude is less. Amplitude is reduced by 50 to 75%. Because of that, life increased tremendously. And for these type of system, life is very, very big. Like previously 2 hours was the life, now maybe the life is 2 years. So 2 hours of life gets converted into 2 years of life. What else you want now? So because of that much tremendous increase in life, it was a wonderful accepted attempt. And based on the concept of complete balancing of rotating masses and partial balancing of reciprocating masses, the first locomotive engine of the world came out, and that was given the name of two-cylinder locomotive. That was given the name of two-cylinder locomotives. That was given the name of two-cylinder locomotive. Two-cylinder locomotive. So when we are talking about two-cylinder locomotive, as it was to run the train, the railways, train, you know, it is going to have a lot of stuff. More energy is required. For more energy, every wheel of the engine was provided with the cylinder. Engine is one only, cylinders are many. So you will be having one slider crank mechanism on this wheel, one on this wheel. So we are saying this is wheel 1, this is wheel 2, this is cylinder 1, this is cylinder 2, this is the axis, and this distance is a by 2, this distance is a by 2. So my dear, you can say this is the train, and if you are going to have the rail like this would be the axis. So on this rail we can show the wheels like this and cylinder. When we are showing this cylinder, actually what is that? This is a crank. Let us say this is crank. So this crank is connected with connecting rod is connected with slider is inside the piston, inside the cylinder. So you can also feel it like we are having this rod on which one crank is this, other crank is this, because both cranks were at 90-degree angle. This crank is connected to the connecting rod was having slider was having the cylinder. This is one cylinder, and here one more connecting rod, one slider like that, another cylinder. So this is how two cylinders were connected on the same crankshaft. Hi Blue, is it clear for everyone? Is it clear for everyone? So if this is the rod, this is one crank and this is another crank, because both the cranks are making 90-degree angle to each other. Okay. So when we are having this condition, my dear, you know both the sliders, whenever here force will be going on, they will try to rotate the crankshaft like that. So my dear, this is the case of two-cylinder locomotive. Very good, Ashray. हाँ भाई जख्मी आत्मा, गुड इवनिंग. अलग अलग कहाँ चले गए थे? Okay. So when we are talking about this, we are going to have two-cylinder locomotives, and whenever this partial balancing concept was used and two-cylinder locomotive was made, there were a lot of problems came into the picture. The effect of two-cylinder locomotive were very dangerous, and it was already known to Sir James Watt. That's why he denied also to do that. Okay. So when we are going to have this thing, I would like to tell you that, okay, no issues, Zakmi Atma, okay, तुम्हारे जख्म भर लो पहले. Okay. So when we are going to have this, my dear, there was some problem came into this, and the very first effect which will be coming into picture is nothing but the variation of tractive forces. So you know that we have just seen in a single slider crank mechanism, in x direction on the crankshaft a force was coming 1 minus c mr omega square cos theta. This will be coming because of one single slider crank arrangement, and second will be coming 1 minus c mr omega square into cos 90 plus theta. Why? Because you know both the cranks are at an angle of 90 degree to each other. So this is the force coming because of first single slider crank mechanism. This is because of second single slider crank mechanism. So on the crankshaft, these two forces are coming, and these two forces will be acting on the crankshaft. And my dear, when they will be coming, you can see they are variable. If you are going to write this tractive force, differentiate with respect to theta, equate it to 0, you would be getting the tractive force variation to be happening in two values. One is plus root 2 into 1 minus c into mr omega square, and minus root 2 into 1 minus c mr omega square. This is the range of force. Plus and minus are saying about the change of direction. So just imagine, this is the rail, wheel. We are imagining that this is the crankshaft. Although crankshaft is not directly connected, but still we are imagining like that. And this is cylinder 1, cylinder 2. So they are going to apply, like if this is the crankshaft, one force is coming like this, other force is coming like this. Or you can say both forces are acting like this on the crankshaft, but they are changing in magnitude and direction. So if some force will be acting on the crankshaft, it will try to slide like this or that. You may be thinking, sir, if tractive force will not be there, how the train will be running? Arey, train is running because of the rotation of the wheel. It is not running because of this type of force on the crankshaft. Because of that, even this can have slide. Or even if rotation is going to happen, as the forces are variable, these tractive forces, they are going to create this type of effect in the railway. And if that kind of effect will be there, you are sitting on one seat, someone is sitting on the other seat, after 5 minutes you will be on each other. That kind of high variations are going on. So because of that, we don't want this variation of tractive forces. So this you need to remember the formula, tractive forces are varying like this. So if you don't want this, you need to go for partial balancing. No, you need to go for complete balancing. When C will become 1, tractive force will become 0. There will be no uncomfort. but the problem was with the complete balancing, we were unable to run the locomotive. Yes, Jakshmi Atma. Life of that was very, very less. Now, my dear, the second thing we are going to see the variation in swaying couple. You know that as you are having this is the axis of symmetry. So you know that this distance is a by 2. This distance is a by 2. You already know tractive forces are acting like this. This tractive force is applying a couple like this. This is applying a couple like this. So when you are going to find out the total couple, it is coming out to be what? Total couple is coming out to be what? It is 1 minus C mr omega square cos theta into a by 2. This is one couple. One is clockwise, other is anti-clockwise. So it is going to be minus a by 2, other is going to be plus a by 2. 1 minus C mr omega square cos 90 plus theta into a by 2. This is also variable as a function of theta. So when you will be going for the total couple d by d theta is equals to 0, you would be getting this total couple to be varying between two values. One is minus 1 by root 2, 1 minus C into mr omega square into A. And second is plus 1 by root 2, 1 minus C into mr omega square into A. You can see one couple is trying to rotate the train like that. Other is trying to do like that. So they are going to give this type of motion because they are also having some phase difference. Because when one is becoming theta, other is 90 plus theta. So if one is maximizing right now, other will maximize after 90 degrees. So they would be creating this type of movement. You know, this type of movement is there with the snake. And the movement of snake is said to be sway. So that is why this was given the name of swaying couple. And this will be having a tendency to sway the train. And if that will be happening, you can understand the train may even lose the contact with the rails and create the accident. And a lot of uncomfort. Already this was there, now this is also there. So when both uncomforts are coming, this is not acceptable. But still, it was accepted because without this we were not able to run the train. Once again, if you will keep C is equals to 1, swaying couple will become 0. But we will not be able to run the train for longer duration. Within 1.5 to 2 hours, it will get failed. Okay. So guys, if that is the case, the third is hammer blow. We accepted first two things. We accepted swaying couple. We accepted tractive forces. But when hammer blow came, it was not acceptable. Why? Because let us say you are going to, whenever we are talking about the balanced masses in the railway engine, if you want to show, if you want to see, you can see the ballast masses are generally applied onto the wheels. Okay, they are applied onto the wheels rather than on the crankshaft, because if they will be applying on the crankshaft, there are chances that they may collide. Okay, it will be always difficult. So that is why balanced masses are always provided on the wheels. And when we are providing balanced masses on the wheels, it will become the case of dynamic balancing, obviously. So let us say you are providing some balanced mass onto this wheel like this. And because of this balanced mass, when the wheel is rotating with omega, there will be a force, that is B into omega square. This is the maximum value of this. And if this B into omega square is going to be more than the static load per wheel, if it is going to be more than the static load per wheel, then my dear, you know what will happen. Wheel is having one force upward, which is BB omega square, other load downward, which is static load per wheel. Load which is coming because of the weight of train and people's downward. BB omega square because of balance mass upward. If upward force is more than downward force, the contact of the wheel will be going to lift. And you already know for both the engines there is a 90-degree difference. So initially one will be going up, then second will be going up. One will be going up, second will be going up. You may be thinking, sir, it can topple also. Yes, it can topple also. But the point is, when it is rotating continuously, just at the other instant the force will come in this direction. So then the component of BB omega square, let us say this is theta, cos theta let us say, and this is, if BB omega square component is going to be less than static load, once again it will come down. But if the speed is very very high, then it will go like that. Otherwise it may go up, come back, go up, come back, go up, come back, go up, come back. So wheels would be having this. First was this, second was this, third is this. First was acceptable, okay, uncomfort to the luggage. Second was acceptable, uncomfort to the luggage. Third is unacceptable, it may result into accident. And why we call it as hammer blow? Because when the wheel is lifting up, coming down, lifting up, coming down, it is looking like someone is hammering over the rail. Is it clear? And if you don't want hammer blow, you have only one thing to do. You need to reduce the omega. And when you are going to reduce the omega, entire purpose of making high-speed engine will be going into vain. Then why you are talking about high-speed engine? It will not be a high-speed engine. And we need to compromise with the speed, and it will become the super passenger locomotive. So guys, when we are talking about this, here the question may be asking you, what is the hammer blow? So BB omega square is the value of hammer blow. Is it clear for everyone? So I would like to tell you, for gate examination, this part is going to be more important. 4 formulas. One is rotating balancing formula of analytical method. Second is tractive force. Third is swaying couple. Fourth is hammer blow. So for gate examination, this much is more important. After that, inline cylinder engine, radial engine, I am not saying they will not be coming in the paper. They can come, but not that important as this is. So I feel this was the part which I wanted to tell you. If you were asking, स्टैटिक लोड पर व्हील वो दिया होगा, स्टैटिक लोड पर व्हील दिया होगा, पर आपसे वो पूछेगा ही नहीं. आपसे जख्मी आत्मा क्वेश्चन पूछा जाएगा, व्हाट इज द हैमर ब्लो? सो हैमर ब्लो इज बीबी ओमेगा स्क्वायर. Is it clear for everyone? So guys, I feel this part, which is very important, we have discussed. Now will it be fine if we leave here and I will share you the session link in the comment section, from where you can watch the cam governor part if you want, because in the last year marathon I have taken that, but I feel you have requested, so I went for balancing again. So I already told you, now HMT marathon would be coming in the form of recording. You can watch at the preference time of yours. Okay, so tomorrow I am not coming with the marathon, but at 4:30 PM you can join me and Abhinav sir in the app, because in the app we are coming with civil versus mechanical war, where you can earn while you learn. Means you can earn, 3 students would be getting prizes up to 2100 rupees. Okay, so also rupees is second thing. First thing is you would be having the practice sessions of SOM. And also I would like to tell you that in the next 10 days I would be coming out with the practice session of all the topics. Be ready for that. And also be ready for one marathon I will be coming up for metal cutting, metal forming and all. So don't worry, with that I have promised you, I will be coming up for that. Clear for everyone? Okay, so now I feel rest everything we have covered. हाँ, जख्मी आत्मा, whatever direct and reverse crank method, that is radial engine only. It is not very important. If you see the previous year's record, it have never been asked. But I will not tell you that you have to leave it. I feel you have to do this. Okay, but in marathons we have revised whatever is required. Rest. If you still want to revise the videos of my, which I will be sharing, there that method is explained. You can go for that. Okay. Mathematics will be starting from Monday. I already told you Monday 11 AM will be the timing for that. Okay. Monday maths, Tuesday aptitude. Likewise we will go with one day maths, one day aptitude. Okay. Any other doubt or question if you want to ask me, please ask. Then we will leave the session. So two things you will get. One is the link of tone and vibration session. I am also sharing on my Telegram channel. From there also you can start if you want to go for cam governor, okay, and the rest part of balancing. जख्मी आत्मा अभी भी ऐसा होगा क्या इतने टाइम बाद? अगर ऐसा लग रहा है तो आप एक पर्टिकुलर टॉपिक छोड़ सकते हो. अगर उसके कारण प्रॉब्लम हो रही है तो छोड़ सकते हो, क्योंकि टारगेट 100 नंबर का मत रखो, आपको 75 प्लस का टारगेट करना चाहिए. इफ यू कैन इंक्रीज द एक्यूरेसी. हाँ, पीडीएफ आई विल बी शेयरिंग ऑन माई टेलीग्राम चैनल एंड व्हाट्सएप ग्रुप. अनिकेत, you can talk to me after 8 p.m. After 8 p.m. Okay. Okay. So tomorrow be ready. There are two things. One is at 4:30 p.m. You can join us on app. Link will be given to you in the description. Description for the app. If you want one-to-one counseling with counselor, also Google form is provided. Sir, please tell 4 important point once in this. You are telling what for WhatsApp group link? You can message me there. Okay, Zakmi. Abhi, which 4 important points you want to say? Okay, from where the questions will be coming. One is analytical method, rotating balancing. Second is tractive force, swaying couple, hammer blow. Okay, and other than that, if you want to go, the 5th one is direct and reverse current method, but the chances from that is very less. Okay, if you can do, please do, otherwise you can leave. And that also, the link of marathon which I will be sharing, there it will be there. Okay, you can also watch that part. Dear Shovik, you need not to join WhatsApp group if you are already at Telegram, but still if you want I will share. Okay, WhatsApp group link is also the same, like Mechanical by Dheeraj Sardana, Mechanical by Dheeraj sir. Okay, fine Faninder. एडिटिव में न्यूमेरिकल तो है ना, सिर्फ एक न्यूमेरिकल मिला था टाइम. हाँ हाँ हाँ, बिल्कुल वही है, वही करना पड़ेगा जख्मी. एडिटिव मैन्युफैक्चरिंग का करना पड़ेगा आपको, ठीक है, उससे लास्ट ईयर ही आया है. ओके, सो गुड बाय गाइस फॉर दिस सेशन. सो टोम एंड वाइब्रेशन इज वेरी वेरी बिग सब्जेक्ट. स्टिल वी ट्राई टू कंप्लीट मैक्सिमम पार्ट. एंड कैम गवर्नर, आई एम शेयरिंग द वीडियो, यू कैन गो फॉर दैट. ओके, सो गुड बाय फॉर दिस पर्टिकुलर वीडियो फॉर द टाइमिंग. Okay, fine.